So what is Python? Now Python is a high-level general purpose language. It's basically a multi-paradigm language where it supports object-oriented, functional programming, structured programming, and procedure-oriented programming. Okay, don't close the window. Okay, so we'll go step by step. Now, what do you mean by a high-level language? See, it's coming from year 1991. That's where Python was first released, and that's right, it's way back before Java or other modern languages came into picture. But yes, it is getting famous now, but it's an old language. Now, in that era, we had a lot of languages, right? Now, most of the languages were working directly on the machine. So maybe it is very close to the hardware. But Python, on the other hand, it's a high-level language. Now, why do we need a high-level language? Now, first of all, if we talk about your machine, it only understands one language, which is binary language, ones and zeros. That means if you want your machine to work as you want, you have to basically talk to it using ones and zeros. I know you're not comfortable with that. And that's where we have to write in different languages. Maybe there was a time we used to use assembly language, where you have to pass commands to do certain things. Example, if you want to add two numbers, you say add a comma b. So basically a will have a value, b will have a value, and then you add them. Now even that was not comfortable. We wanted to build huge applications. And that's why we moved from one language to other languages. Things started evolving, and then we got one perfect language, which is C and C++, and they were working fine. But then it's difficult to learn C and C++. Somewhere we need an easier language to work with. That's where Python came into picture. Now, it's a language which is high level. That means it is very near to English. That means whatever we see there, you will feel, okay, that's an English language. It's just that when you write that code gets converted into a machine code. So yes, there is someone who will convert that, maybe an interpreter or a compiler. We'll talk about those things later. But we need someone who will convert that. So you write a high-level language, which is similar to English. And when it runs on the machine, that's when it gets converted. Or before you run it on the machine, it gets converted. Next, we talked about general purpose language. That means using this language, you can build any kind of application. Is not specific to one thing. Maybe if you want to build a simple calculator which works on your machine, we can do that. If you want to build a web application, you can do that. If you want to build an AI-based application, you can do that. So we can use it everywhere. Most of the places. Then we talked about different paradigm. See, the thing is, different languages follow different paradigm. So we have this concept of procedure-oriented programming, where you work with procedures. We have a concept of object-oriented programming, where we have objects. So example, for procedure, we got C language. For object, we got Java, C#. Then we got functional programming, where you work with functions. And that's example for that would be JavaScript. But Python says, I can do all. Okay, so it's a multi-paradigm. And of course, it's not like other languages cannot work with other type. So few languages do support other types as well. So yeah, that's about Python. Is very, very famous. And the question is why it is famous. There are multiple reasons for it. Now, before we talk about it, let's go to python.org. And in this series, I might say Python, that fine, different pronunciation for the same thing. Now, if you go to this website, this is where you can download the tools to work with Python. And if you see what they're talking about is this. So use for Python language. You can use it for web development using, there's a library for that or framework. We got Django, we got Flask, Tornado. And you can also build a GUI application. Maybe it will make much more sense in the world of AI now. Using these tools. So we can also use it for scientific and numeric purpose, where you might have heard about sci-fi or pandas if you are exploring the AI world. We can also use it for software development, of course, and for system administration. But majorly, it's very famous nowadays because of AI, but also for web development. And I was telling about why it is so famous because of multiple things. The first one is it is one of the easiest language to work with. In fact, the founder of Python, Guido van Rossum, basically built this language so that anyone can learn programming language. It should not be only for specific people. So it's the easiest language to work with. And you will see why I'm saying that. Next, it has a huge community. So basically, any language when you talk about, and if they are famous, is because of their community. Or maybe they have a good community because they're famous. Okay, it's a cycle basically. But you have huge community. and you got a lot of libraries to work with. So it doesn't matter in which domain you're working with, you will see some libraries there. And in the AI world, most of the libraries are built in Python. So let's write our first Python code. See, the thing is, if you want to run Python, you need a place where you can write your code. Of course, you can use a simple notepad. But then when you write that code, your machine needs to understand it. And that's how the programming world works. So what happens is, when you talk about the IT industry, it's all about data, right? And to work with that data, we need software which will store the data, which will fetch the data, which will process the data. And to do that, we have to write some code. Now, of course, we can do that with multiple languages, but when it comes to Python, we need a place to write the code. And also, we have to convert that code into machine code. And that's where we have this concept of compilers, interpreters. So we are going to use those. And of course, we have to do that in the machine. So we have to install the softwares. But before we do that, what if you want to try out the code before installing the software? And that's why we can use some online compilers. And this is very famous, the online GDP compiler. And if you go there, it's not just for Python. We can do that in multiple languages. Example, if I go here, if I select C, this is the C code. We have to basically write multiple lines of code just to print hello world. And don't worry if you don't understand the code. We're not even learning C here. But in Python also, when I show you the code, I will explain later. So Java, this is the Java code to print hello world, and that's why maybe people are scared to learn Java because of all these words. And if you jump to, in fact, I want to explore VB. It's been a long time I worked on VB. So this is the VB code, the good old days. And coming back to Python now. Now, if you can see, it says Python 3. So yeah, there are multiple versions of Python. Python 2 was there for some time, and then now it's end of life. Python 3, we got different versions, and this should be the latest one which they're using. I'm not sure. But anyway, this is Python 3. And what you see on top here is the comment. And this thing here is your code. Now, what we are trying to do here is we are trying to print hello world. Okay, and whatever code you want to write here, you can write and you can execute. Now, this will convert that code into binary. It will run on their servers because we are running online, and you will get the output. Okay, and what this print is doing, it's a function. We are going to discuss what are functions, what are those brackets later. I know, I love surprises. So here, I'm just going to click on run. There are multiple options and put display screen. Okay, let's try this. Okay, trying the displacing for the first time. I think it will give a new window. Let me run it here itself, and you can see we got hello world. Now, don't get upset because of this black screen. I've seen people getting upset because of we're getting output on a black screen. So that's fine. We're learning a language here. And of course, in future, you're going to build application for web. You might be doing it for the web, the geo application. And most of the time, when you build a backend in Python, the front end will be done with the help of HTML, CSS, JavaScript. So don't worry about the black screen here. Output doesn't matter. I mean, output matters. Where it is printing doesn't matter. Okay, so that's how you can write your first code. But then I'm not happy because we're doing it online. Of course, I'm not saying that it's not a good place, but I need more control, and that you get on the local machine. Now, for that, we have to install some softwares. Okay, so when you go to Python website, there's an option of downloads, and we have to install some softwares. We have seen how do you run Python code online. But then I want the setup in my machine. So how do you get the setup? See, it's very simple. When you write a code, of course, you want to execute somewhere. And where you're going to write the code, you can use Notepad or you can use any editor for that matter. Example, if I open my Notepad and if I type a command, or let's say if I want to print something, and I'm going to explain what this print and stuff later. But let's say if I say print hello, I want to execute this. And when I'm going to do this, and that's where you need the Python interpreter. So to do that, go to the official website of Python. And intentionally I'm saying official is because there are a lot of places where you can get the Python setup, but they might be malicious. So better to go on the official website and go to downloads, and based on which OS you're working with. So if you're working with Windows, select that. If you're working with Mac and other platforms, I'm using Windows here. I will click on Windows. And in this, you have multiple versions. Version of Python as well as the version of Windows we are working with. Example, if your Windows version is 64-bit, like i5, i7, Ryzen. So you can go with the Windows Installer 64. If you are using the ARM-based chip, you can check that with your laptop and desktop. If it says ARM processor, go with this one. Now, since in this machine I got Intel chip, that to the 64-bit, I will go with this version. Even the Windows is 64-bit, I will click on this. And before I do that, make sure that you download the stable version. The problem is if you download the pre-release version, which might have few extra features, but then all these beta versions are not fully tested properly. And if something goes wrong, you have no idea what's going wrong. Is it you or your Python setup? See, of course, once you understand the language better, once you have built certain projects, you can try out the pre-release version. But now at this point, I won't suggest you to go with this. Go for stable version, click on this, and it will download. Now, I do have the setup already downloaded. Now, before you do this, in fact, I wanted you to check one more thing, which is, do you already have Python in your machine? If you have, then that step was not required, but I don't think anyone will have by default if you have not worked before on Python. Okay, so now open your terminal, and how do you check if you have Python or not? Just type Python and version. And if you see something like this by saying Python was not found, that means you don't have it. Also, sometime, when you install Python 3, that's the latest version of Python, sometime you get Python 3 as well. So check with this command as well, Python 3, and make sure you don't have any of that. If you don't have any of that, then you can install Python. So download it and then click on this simple installation. It will open this prompt. Now on the first screen, make sure that you tick this add python.exe to path so that you don't have to manually do all the process of setting the path. Why someone will do this is because when you save the files of Python, you store it in some other folder. The Python setup will be some other folder. So you have to link the path then. If you don't want to do that, just tick this and click on install now. Simple setup, you might have to say next at some point and it will be done. So it's happening, taking some time. Okay, so Python installed successfully. That's what I'm getting. Okay, so how to verify this? Go to your terminal and say Python version, and when you say enter, it will not work. But you will say, hey, you got Python there. It's not working anymore. See, the thing is, when you install softwares and when you try to run the command, you have to make sure that you reopen your terminal. And why I'm saying that is because people do miss it. And then they feel bad. Hey, we have done all the setup, still not working. It's because you forgot to reopen your terminal. Now, once you reopen it, just try it now and it will work. Cool, right? But in case if Python is not working, try Python 3. If that works, you still should be happy. But if that works, if Python 3 works and then you want to say, hey, I'm happy with this command, I don't want Python 3, then you can change it. There's allies you can use. Ask the AI models and it will give you the answer. How do you do the allies? Anyway, so for me, the Python command is working, so I will just work with that. Now, once you have Python installed, what you can do is you can open the Python prompt. See, if you have Python installed and in the terminal itself, if you say, hey, I got print, I want to execute a Python function or Python statement. If I say enter, you can't run your Python code directly here. You basically need a prompt, Python prompt. And the way you can get that is go to your terminal and just say Python and say enter. When you do this, you will get a pop-up here, or you will get something which says Python with the version and these 3 arrows here. That means now you can execute your Python code here. Now, which code I want to execute? I will stick to my print. So I will say hello, enter, and you got hello there. Congratulations. This is your first step to run Python code on your machine. So that's how you print hello here. Okay, but then what if you have multiple lines of code? Not just one, maybe 10 lines of code, maybe 100, maybe 1,000. Not a good idea to have all the lines of code in one file, but let's say imaginary stuff. How will you do that? Of course, you can type all the statements here, but then if you do that, how will you debug? How will you modify? A lot of problems, right? In that case, you need a place where you will type the code. Not here. I don't want to type in prompt. I will just say exit, come out. Now, once you're out, go to your notepad and type the code here, as I did here. So you can see which says print hello. But then how will you execute this file? It's very simple. Just save this. Now, when I'm going to save this, I will just store that in a C drive. So in the C drive, create the folder as Python codes or wherever you want to store it. And in fact, I will just use another thing. Also Python prax, because Python code I'm using for some other thing. So we got Python prax here. And give a name to your file. So I'm giving demo here. Any file name will do. Click on save and done. You got your file with your Python code. How do you run it? It should be simple. So type Python, first of all the command Python, and then mention the file name, which is demo.txt. Oh, unfortunately I don't have this file in this Navin folder. It's in the C drive. So I'll just go back, and now in this I have a folder called Python prax. That's a folder name, clear. And once you are in this folder, you can check in this folder, I have this file, which is demo.txt. And now I can run that command. So Python, and I can mention the demo.txt file name, enter, and it says hello. Awesome. Okay, this is working. But now the problem is, okay, what's the problem? See, the file name is .txt. Nothing wrong with txt in a major sense. But whenever you create a Python file, make sure that the extension of your file is .py. Again, there's no compulsion. It will still work. But there are certain features which we are going to learn later, like importing, where you need to have Python extension. Next, when you work with the IDEs, I will talk about IDEs later. Imagine a fancy editor in which you can basically, if you want to use that IDE features which they provide, you need to have dot extension, which is .py extension. And it is good for readability as well. So when you see some file by .py, you know that's a Python file. So I will just change this file extension here, save as, and instead of txt, I will say .py. Now when I do that, you can see the file is changed. It is demo.py. I can also check there are two files here now. One is .txt, one is .py. And now I will just try to run the command. So demo.py, enter, it says hello. So finally, we are able to run the Python code on the machine. I know, a simple code, and we are not even talked about what is this print and stuff. We'll talk about that later. At this point, the Python setup is working. So now we know where to write the code and how do we run it. So basically we can use a simple notepad where you can type the code, and then you can use an interpreter on your terminal to run the code. Here's the thing. When you build software, it's not just about writing code, it's also about debugging it. So debugging basically means removing the bugs from the application. Maybe there's something which you want it to work, and because of some issue, you're getting weird output or it's not running.
I should get some sleep.
So you have to debug it. Next, maybe you want to create documentation. Next, maybe you want to create a package so that you can deploy it on the cloud. So all these things should be at one place. And that's where IDE comes to the picture, which stands for Integrated Development Environment. Now, especially for Python, we got a lot of different IDEs available. The most famous one is VS Code. Okay, when I say most famous, is because VS Code can be used to work with multiple languages. Like we got JavaScript, C, C#, CSS, TypeScript, Python, Java, and list goes on. I mean, of course, you can't see that here, but it's great. And it is built by Microsoft, but now it is open source. Not what I mentioned, but yeah, it is open source. Now, when you go to VS Code here, this is their website. So you can say it says your code editor redefined with AI. So that's right. With the latest trend in the AI, you can use AI for development and it works. That's important. Okay, so that's VS Code. Apart from this, we got one more. In fact, there are multiple, but then this is also famous, which is PyCharm. Now, PyCharm is built by JetBrains. Now, if you have no idea what JetBrains is, this is a company who makes tools for the developers, and they have amazing tools for different languages, for different work. So if I go to JetBrains, this is their website, and this is a tool. But apart from PyCharm, which is specifically for Python, if you click here, developer tools, we have multiple options here. Now you can choose your language, and I'm sure they might be having some tool for that. Okay, so this is PyCharm only IDE you need for web development, data, AI, ML, and supercharged with AI enhance. And I'm a big fan of JetBrains tools. No, this is not a paid stuff. I mean, not a paid promotion, but yeah, there's one thing bad. Okay, I can't say bad. It's just that if you want to use great things, you have to pay for it. So this is PyCharm, and if you they give you two options. Now PyCharm is better than VS Code if you go for the first option, which is the paid one. So the PyCharm paid software, which is they call Pro, is amazing. There's no competition between VS Code and PyCharm paid version. But if you don't want to pay, then you have to use the community version, which is great, but it lacks features. Now, if you go down, in fact, if you click on download here, you can see there are two versions. One is PyCharm, which is unified product. I will come back to unified in some time. And there is PyCharm community version. Now, if you don't want to pay for it, you can go for the community version. You can click on download, free. But now, in the earlier days, they used to have only PyCharm, I think, or Pro, where you have to pay for it. But now you get this unified product where you have a combination of a Pro and community version. So for the first 1 month, you will get it all the features, but after 1 month, they will stop some of the features. And you will get to know once you use that. So don't worry, we are going to use VS Code most of the time, and maybe we'll try to explore PyCharm in between. And maybe intentionally I will do that is because you should not be dependent on an IDE. But you should know all the IDEs. Okay, that's the problem, and that's a fun actually, not a problem. That's a fun thing. Apart from this, we have one more, which is Jupyter. Now, people, especially in the AI ML world, they explore Jupyter like anything. But yeah, you can do that in PyCharm also, but in the Pro version, if I'm not wrong. But if you go down, this is Jupyter, which is very good, and I will show you why it is good. So when you install in fact, you can install on your machine. They got Jupyter Notebook. You can also try the lab, which has multiple features. But if you want to try it on the browser, click here. And out of this, I want to try Jupyter Notebook. You can try it online. Okay, we'll see that in one of the videos. So we have 3 options, and there should be multiple options, but there's 3 famous: VS Code, PyCharm, and Jupyter. So let's start with VS Code. Now, how do you get VS Code on your machine? It's very simple. Go to the website. There should be an option of download for Windows, and based on which OS you're working with. So I will click on download for Windows, and it will download on this machine. But I will cancel it is because I already have a system set up in this machine, and it's straightforward. You just say next, 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 and you will get the software. And if I want to show you, so this is how VS Code looks like. Okay, this is the first page. I will just close this and increase the font size. This is VS Code. Now, how do you work with this? It's very simple. You click on this. This is where you will see the project explorer, where you can see project, the folder, the files and stuff. This is where you can search for a particular file. This is where you can work with source control like Git. This is where you can run and debug. And this is where you can add extensions. Now, as VS Code works with multiple languages, sometimes you have to add the extension. In fact, most of the time, you have to add the extensions for a particular language or a particular feature so that you can work with it. Now, why they don't give everything in one place? Maybe they should provide all the extensions by default. See, it will make it very heavy because there are a lot of languages, a lot of tools. If they give everything, your system will die. And I don't want your system to die. In fact, they don't want your system to die. So it makes sense to not have all the extensions pre-installed. And we'll see which extensions we need. So first of all, I will just go back here. And what you do is you open a folder. So maybe in your machine, create a folder. Then open it from here. I'll go to desktop. So go with the folder which we are working with, which is Python codes. Or you can create new one. So we already have one file here. If you don't have that file, it's okay. Just click on this button here, which is new file. And name it anything you want. Let's say demo1. And this is how it will open. I don't want any suggestions. Close it. In fact, enter it. Now this is where you can type the code. So what code I want to type? I will say print. And in the single quote, just say Telusko, or I will say welcome to Telusko. I'll just save it. So you got your file, you got your code. And now in the terminal. Now if you don't see a terminal here, it's fine. You can just click here or if you see the option of terminal on the top, it's just because I have zoomed my IDE. They don't have a space. So terminal, new terminal, you will see that window here. And once you are here, just say Python and the file name, which is demo1. And click on enter. You can see it says welcome to Telusko. Or you can run it from here. So you can just click this and it will run. The only thing you have to do is, if you don't see this option, make sure that you have an extension for your file .py. You might not see this by default. So that's how you do it. So what's the beauty about an IDE? Just type the code here. Just run the code here. You can debug here, everything in one place. Now, let's talk about the extensions. So when you go here, for Python specifically, I already have those extensions. You can see installed is this theme which you're seeing here. Then Pylance, Python, and debugger. You don't have to install all. Just install this one, which is Python. So how do you do that? In the search extensions, just type Python, and you will see Python here. There's a tick here because it's already installed, or because it's from Microsoft. Yeah, you will see this. There should be an option of install. Just click that, and yeah, you'll be having an extension of Python in your VS Code. It might ask you to restart your IDE. In case if it asks, just restart the IDE. Yeah, and that's how VS Code works. Just remember this section on the left-hand side. Create as many files you want. If you want to get subfolders, you can do that. And there should be a run button here. You can change the layout if you want. So you can see we have all these options, and it works. And I think they also give you Copilot by default, or they have to sign up for it. We'll see that later. Okay, so that's about how to use VS Code here. And now it's time to work with PyCharm. So how do you get PyCharm? Go to their website, click on download. You can get the unified product, or you can get the community version. And it says community version is now part of the unified product. That makes sense. So download this one, click on download. It will download on your machine. I already have that set up in the machine. Just say next, next, next. It will be done. Now, once you have this, and if you, in fact, I would also want to show you the pricing for this. So if you are an individual, this is the pricing for you for the PyCharm Pro, $99 for first year. And for teachers, students, you get it for free. So if you have the student email, teacher's email, you can do this. I'm a content creator, so I got one. So that's the pricing. Now, once you have that in your machine, open PyCharm. This is how it will look like. You will not see any projects because you might be doing this for the first time. I've done this before, and that's why I see all these options here. Now, in this also, you see the option of notebook like you have in Jupyter. You can do that from here as well. But then we want to create a new project. So we'll just click on new project here. And you can name anything you want. I'm just naming it as Python project 2 because I'm not going to use the same project again. And then you mention the version of Python we are working with, which is 3.13. And click on create. Now, once you do that, you will see the project here. We have external libraries by default because it has its own way of creating a project here. Now, how do you create a file in this PyCharm? Now, first of all, on the left-hand side, we got project section. We got Python console here. If you want to execute certain things, you can get the terminal. You can get the version control. On the right-hand side, you see notifications. You got chat, Juni. Yeah, looks good. Now, in this project, you will right-click and say new Python file, and you name it. And by default, you will get the extension as .py, okay, by default, because this is PyCharm. That's the only language it supports, right? Now here, I just want to increase the font, and this is why I love JetBrains IDE. You can just go to appearance and click on whatever number. I think 175 is a good number. It should be visible. Now here, I will just say print. I will just say hello and save, and you will see an option of running here. Click on this, and it runs. You can say we got hello. So we got a console, and we got the place where you can type. We got project section. So this looks cooler than VS Code, but VS Code is lighter than PyCharm. So it doesn't matter which one you use. Both are amazing. Personal preference. We'll be using VS Code because a lot of people are familiar with this. If you love PyCharm, use it, no issue. Code will remain same. And now it's time for Jupyter. Of course, we're not going to install this locally. We'll try to run it online. You can just try. If you want to install on this your machine, click on this, you will get this set up. But we'll try it on the browser, the notebook. Try it on your browser and go down, click on Jupyter Notebook. And this is what you will see. Of course, a lot of things are pre-built. What I will do is I will just click on File, New, notebook, it will ask you for the kernel. I want to select Python, select here. Okay, now this is how it looks like. I will zoom it a bit. Now if you want to print, this is where you type it. I will say print in single quote, hello, and just click on run. You will see the output here. Now this makes sense when you want to write smaller code, or if you want to see the graphs. It's fun when you work with pandas here where you see all the graphs and stuff. So this is good. Okay, so based on what you like, some people prefer Jupyter, some people prefer VS Code or PyCharm. So based on your liking, you can try it out and it works. If you want to get multiple files, you can just click here, file, create new notebook, and it supports a lot of shortcuts to work with it. You can also write documentation. Example, this particular cell has a code. This cell you can have a markdown. You can write some notes here. So this is a good place actually to learn. But if you want to work on a big project, PyCharm or VS Code. Now once we have the setup done for the Python, then we have done for the IDEs we are going to use. Of course, we're not going to use all. We'll start with one. But before we jump into VS Code or PyCharm, the idea is when you learn a language, you want to start from the basics. And that's what we are going to do now. And when you install Python, so in fact, before we go for Python, I want to show you one more thing. When you open a command prompt on Windows, this is the command prompt which you can see on the screen. And on this command prompt, when you perform some operations, so let's try dir. Now, when I do that, it will list all the files in this particular folder. So in the Naveen folder, I got all these files, right? So basically, command prompt understands the command. Example, CLS will clear it. But when I perform 2 plus 3, it will say 2 plus 3 is not recognized as internal or external commands. That basically means your command prompt work with the commands. So pre-built commands, it can be internal or external. But on the other hand, in Windows, basically we got something called a PowerShell. Now in this PowerShell, which looks like a command prompt, but a bit different, this is a tool built by Microsoft to have their own shell kind of thing, which we have in Linux-based OS or Mac. So we got shell there. Where we use bash. Here they have created something called bash. I mean, sounds good, but it's more like a bash, but then for Windows. And now they have open sourced it, so we can use it in multiple places. Now PowerShell supports scripting. Okay, so when I say the same command dir, I think the command dir works here, command ls works here for the same thing, because ls coming from the shell background. Then I can also use clear for clearing. I can also use CLS. So it's a combination of command prompt with shell, and it's fun. But since you can run a scripting language, so even Python people call it scripting language, and makes sense because you can write scripts there. But then by default, we got this shell. And in shell, if you say 2 plus 3, you do get the output as 5. Okay, so this is how you run shell. Again, we are not here to run shell programming, but you can write shell commands here like echo, and if I say Naveen, it will print Naveen. So echo is a command in shell to print something. But if you want to do that in Python, how will you do that? So let's say I want to get into Python, and that's why you can type Python in the command prompt or in the PowerShell. It works. When you say enter, it will open a prompt. Now this is called the Python IDE. In fact, you can open that Python IDE in a separate window. But you can do all the things here. So let's say if you don't want to do that here, so I can say IDE, and it will open a separate prompt where you can perform the operation. So we have an option of creating a file. You can edit the file. You can run the script, and you can configure. So there are a lot of options here which you can work with. If the font is small, okay, it's zooming the height, not the font. Okay, but we have to find some setting for the increasing of the font. This is the Python IDE, which is the integrated development learning environment. So it makes sense to test something, to learn. But then we are going to use prompt here, the Python prompt. And this is also a REPL, which is read, evaluate, print, loop REPL, where you can read the text, you can write the text, you can evaluate something, you can print something. So that's how it is. Okay, so here what I'm going to do. First of all, I will say 2 plus 3. The space is not mandatory. I will just increase the size a bit. So the space is not mandatory here, but it looks good. I will say enter, and you got 5. Okay, that works. What else we can do? We can perform multiple mathematical operations here. So we have done for the addition. Maybe if you want to do subtraction, you can do that. Maybe you can, if you want to multiply, you can do that. Even you can have not just one operations, but multiple. So let's say 5 plus 9 minus 4, even that works. Oh, okay, we got the same 10, 10. Just a coincidence. But it has to follow some grammar, right? Example, let's say if I say 8 plus 9 minus 4, it will work. But what if I miss 4 there? Will it work? If I say enter, it will give you some bad words. It will say Python has some issues in the file, which is creating the behind the scene. It says invalid syntax. So this is not a syntax which will work. Okay, so I will just clear it out. I want an empty screen. So yeah, it will follow the grammar. You have to follow it. Otherwise, it will not work. Now let's say I'm going to say 9 plus 2 multiplied by 3. Now, of course, there should be some output for this. And when I read this from start to end, it will be 9 plus 2, 11. 11 into 3 is 33. That's what I'm expecting. On the other hand, if you know the rules of BODMAS, where multiplication will come first, then it will be doing the addition. In that scenario, it will be 2 into 3, which is 6. 6 plus 9 is 15. So what do you think? Will it be 33 or 15? Let's try it out. When I say enter, we got 15 is because it is following the BODMAS. So it is multiplying first, then it is adding it. But what if I want to add first, then I want to multiply? So as per the BODMAS, we have to put a brackets there. So I can put a bracket 9 plus 2, and then I will say multiplied by 3. And when I say enter, it will be 33. So yeah, BODMAS is there. So what else we can do here? Let's say I want to find a cube of a number. So 8 into 8 into 8, that's how you find a cube. Of course, square is 8 into 8. Cube is 8 into 8 into 8. If you want to find 8 power 4, it will be 8 into 8 into 8 into 8. I'm not sure how many times I have said 8. Doesn't matter. But you got the point. When I say enter, we got 5 and 2, right? But what if I want to find 8 power 12 or 8 power 10? That's a big number. So of course I can damage my keyboard by typing all those things, or we can use something called a power, something like a caret sign. This should work, but it's not working. It's not working. It is doing something else. We'll talk about it, what it's doing later, something to do with bitwise. But at this point, it's not working. So we have to use double star to do the power. So 8 power 10, and this is the number. I'm not sure if 8 power 10 is that number. We just have to accept whatever Python says. Or we can just find for 3. If it says 512, then the previous one should be correct, provided the value, the output of this is not out of range. Okay, so that's a tricky part. Anyway, the point is, this is how you do the power. We have not tried the division. Let's try division now. So let's say I want to do 8 divided by 2. Of course, it should be 4. But then we are not getting 4, we are getting 4.0. Why? It's because when you say 9 divided by 2, you got 4.5. That means when you do divisions, you do get the point values. Now these are called float numbers. So it says 9 divided by 2, of course you are getting 4.5. That means when you do 8 divided by 2, you might get the decimal value or the point values here. So 4.0 makes sense. But then when you try to understand the division of a number, what you get is you get 2 outputs, right? So if you see on the screen here, we got, let's say if you're dividing 9 by 2, you got 2 things. One is the quotient, which is 4, and the remainder, which is 1. So how do I do that? What if I want quotient and remainder separately? In that case, you can say 9, you just have to put double slash. And when you say 2, now you will only get the quotient. But what if you want a remainder? In that case, you have to use something called a mod symbol. And you say 2 and you got 1. This will make much more sense once we start with even or examples with the conditional statements, but you will see that later. At this point, just remember, if you want a quotient from a division, you say 4, you say double slash. If you want a remainder, you use a percentage symbol. We can also call it as a mod. So that's how you basically perform the operations in the Python prompt. Again, we are not using the VS Code or other stuff at this point. We'll do that later, but this is what it is. So let me talk about something about variables. Of course, we'll not go in detail. There should be a separate video dedicated for variables. So let's say I want to perform some operation. Maybe we can pick up from any one of it. Maybe I want to pick up this particular operation here. So in the prompt, you can just you can press the arrow button up, or then you will get the previous commands. Now here, when I do that, of course, I got 5 and 2. And then if I want to use this value in the next operation, so let's say I'm performing 5 plus, and I want to say 5 plus 512, but then I'm not sure about the previous value. I'm saying 512 here, but maybe I'm not sure about the previous value. So in that case, if I want to pick the last value, how will I do it? In that case, you can use something called an underscore, which is kind of a box which stores the previous value. I can say variable, but we don't have a name for it. Now, what do you mean by variable? Imagine variable as a box in which you have a value, if that makes sense. So a box where you have a value and we are naming it something. So here the underscore is a name for it because that's the only box you can see in front of you. So it says 5 plus box. Okay, and box says 512. When you say enter, we got 517. But now if I say 2 plus 512, I can't say underscore because when you say underscore now, it will pick up the last value, which is 517. Okay, what I want is 512. Let me show you the proof. When I say enter, we got 519 because 2 plus the previous value, which is 517, but I want 512. Now, if you want to do that, we have a simple concept. Let me clear it out. What you do is, you store this operation, which is this, in a variable, a named variable. So let's say I will say num1 equal to. Now what is this num1? Num1 is the variable, a box with a name as num1. Then in that box, you are storing a value which is 8 power 3. That equal to is for the assignment. So this value is getting assigned to this num1. So of course it will first evaluate the value, which is 512, goes into num1. Now when I say enter, you can see it is executed, but you're not getting anything because in the previous operation, when you were doing, whatever we are doing, you are getting the print of it in the next line. But here it's not doing it. It's because when you assign a value, it says, okay, I'm done my job. I'm assigning that value to a variable. If you want to print it, just mention that you want to print it. So you say num1. But then in actual programming of Python, when you do that later, you will be using something called print. Again, we have not talked about what is print till this point, but it works. We'll talk about it later, what is print is. This is a way you do that in the upcoming sessions, not here. But here, num1 works. Okay, now if I want to perform some operation, let's say 4 plus 8, and this is 12. But now I want to perform the operation which is 5 plus. Now this plus, I want to add 5 and 2. So of course I can type 5 and 2, or I can't use underscore because underscore will be the last value, which is 12. I can use num1, if that makes sense. Not just num1, I can create num2 as well with a new value, let's say simply 8. And now I'm saying num1 plus num2, and you can see we got 520. And the beauty is, you can create another variable. You can store the addition of num1 plus num2 in this. And now I can print num3. So it's that awesome. So this is how you can store the values here. So yeah, that's about it. So till this point, we are working with numbers and everything is working fine. But now we want to work with text. Now what happens when you work with text? And this text in programming are normally called string. Okay, so let's go with this. So when you say a number, so let's say if you want to represent a number, let's say 45, and when you say enter, that's a proper value. Now when you open a prompt, a Python prompt, and when you type something, it tries to convert that into some sensible thing. Example, when you say 45, it knows that's a number. So it will take that as a number and say, okay, I got your number, this is your number. That's what you can see on the screen. But now if you type a statement, again, what is statement? We'll talk about that later. But in short, in Python, basically whatever code you write, each line is one statement. Not always. A statement is one thing. So normally we write one statement in one line. It may happen that you write one statement in multiple lines. It will make much more sense once we talk about this in the upcoming videos. At this point, when you write a number or a statement, it will try to read that and convert that. Here, 45 works. But what if I say Naveen? Now Naveen is my name, and when you try to do that, Python says, what's wrong with you? Why you are saying Naveen? See, when you have a variable, example, let's say if I say num is equal to 8, now num is a variable, right? And the value for num is 8. And then when you try to print num, it works. So this num is a variable. Now Python knows it is because you have assigned the value to num just before that particular statement when you're printing it. What about this? This is not a variable. And my intention was to treat that as a string or a text. It's not happening. It's because whenever you type something, Python tries to convert it. So here, num, it knows. Naveen, it has no idea. So we have to say, hey, that Naveen is not a variable. It's a string. It's basically a text which I want you to take and do whatever you want, but take that value. And if you want to do that, you have to put that in a single quote. So basically, you can write Naveen, but you have to make sure that you put single quote at the start and the end to specify this is where it starts and this is where it ends. And it's not just a word, it can be multiple words. Example, if I say Naveen Reddy, Telusko, so it can be multiple words in one particular string. And at this point, I'm just want to focus on Naveen. I will say enter and it works. You can say it says Naveen as it is. Of course, you can use print, which we were using before, and you can put that here. Again, I'm not talking about print in detail yet. We'll talk about that later. But imagine print is printing something, and at this point, I'm printing Naveen, and you have to make sure that you put that single quote. Otherwise, if you don't put it, again, your Python will be unhappy by saying what you're doing, why you're saying Naveen inside print. I have no idea what you're talking about. So when you say print, you have to put single quote and then Naveen, then it knows, okay, that's a string, I want to print it. And now this time there's no single quote, because when you simply say Naveen with single quote, it will print single quote as well, because that's what it is representing, that's a string. But when you print, it says, okay, I want to print Naveen, so it is what it's doing. When you write multiple lines of code, when you want to do that, when you want to execute, we'll always use print, will not be putting this openly there. It's just for ideally, which we are using here, or the prompt. Okay, so this is working. But what if you want to print, so let's say I want to print something. Example, I want to print Naveen laptop. Okay, so when you do that, when you say Naveen laptop, or maybe Naveen Telusko, it's time for self-branding or self-promotion. Okay, so when you say enter, you can see we got Naveen Telusko. As I mentioned, you can have multiple words. What if I want to be grammatically correct here? So something like this. I want to print Naveen's Telusko. Will this work? Think about this before I enter this. If you have answer in your mind, that's good. Let me enter and verify if it is matching with yours. Enter. Oh, it's not working. Why it's not working is actually very simple. Because if you see here, let's talk about this particular thing. Here when you say single quote and single quote, this single quote first is a starting point. This is the ending point. Perfectly works. But here, when you say this statement, this is the starting point. Where is the ending point? Logically for us, it's here. This is the ending point. But then if you read this statement properly, this is where it starts and this is where it ends. Okay? And there's no starting point again, and then we are ending. That's why Python is saying, okay, I'm happy with this. This looks like one particular string. What comes after, I have no idea. And then you are putting extra quote here. So it says unterminated string literal. Okay, so this is where you start the string literal, and you're not ending it. Example, if you end it here, then it will give you a new type of error because it says you forgot the comma or something. There's no issue with this particular thing now. It is creating issue with this. What is this S after this name? Okay, let me just clear it out. And now let's try to solve it. This is what we're trying to solve, right? What we want to achieve is, of course, if I remove this particular quote here, it will work. But I don't want to remove it. So in this case, instead of using a single quote, you can use a double quote. So string you can represent with the help of single quote or double quote. Both works. So if I say enter now, there's no issue because it knows string is getting started with double quote. It will end with double quote. This single quote here is a part of the string. There's no issue. The problem starts when you want to print, let's say, Telusko in double quotes. Okay, something like this. I will just delete this and I will show you what I want to print and then you help me. So I want to print something like this. I want to print Naveen's. Oh, what did I do? Okay. So this is what I want to do. I want to print Naveen's, then space, and then Telusko in double quotes. If you want to do that, of course, you have to put that in a print, but then inside this print, you have to put some quote, single quote or double quote. Now you think what will work? If you put single quote, example, something like this, if you do that, then this particular single quote will feel bad. I mean, why I'm here. But if you put double quotes, then this Telusko will feel bad. Why the double quotes are here. Okay, so we have to keep something happy. So what we can do is, see this single quote here, it has no special meaning because this has a meaning because this is where you are specifying starting and ending point. This has no special meaning. And we have to tell that to Python, hey, we don't want to treat this something special. And if you want to cancel this special effect of the single quote, you can put a slash. So whenever you want to cancel something, we will see that in the next section of this video. If you want to cancel some special meaning, you put a slash. And now when you do that, there's no problem because this particular single quote is treated as the starting of the string. This is getting treated as the ending of the string. And the special meaning of this quote is getting cancelled by that backslash. So that's important. Next, I will just clear this out. I just want to have a fresh. So let's say I want to print Naveen here. And of course, it will work provided I put that in the single quote. And I will do that, enter. But what if I want to print Naveen 10 times with a space, of course? So I will just say Naveen space, and then I will again say Naveen space, and then I can keep doing that, okay? And this will work. If I say enter, this works. But then I don't want to print this multiple times. If I want to print 10 times, I have to type 10 times. Instead of that, you can simply use a math here. You can say, I got a string and I want to do that 10 times. It will work. Okay, it is that simple. So Python is actually fun because you can do all these things with Python. Now I want to try out one more thing. I will just clear the screen. And here I want to, I'm saying Python. It should be print code. I will say C:/users/Naveen. Now when you do that, what do you think will be the answer? Of course, I'm putting that in single quote. There's no special symbols here. And when I say enter, it should work. The moment I do that, it is giving you error. It says the Unicode error, Unicode escape Kodak cannot decode bytes in position 2 and 3, which is 0, 1, 2, and 3. This 2. Now, why it's saying Unicode is because when you say /u or /n, so when you will have a character after slash, it treats, or the alphabet after slash, it treats as a special character. Example, /n means new line. There are multiple characters, multiple Unicodes here, and it says you will have issues when you do that. Now what I want to do is I want to cancel out the meaning of slash. Again, I will do slash because /n itself is a special meaning. Okay, so when you say double slash, now it will work. So this is something you have to remember when you work with slash or special thing inside your string. You have to cancel the special meaning. You can put one more slash to cancel the meaning of the slash itself. I know that's tricky, but it's quite fun if you know how to work with it. We have talked about text, and normally we call it as a string. Now in this video, let's try to focus more on string and let's see what we can do. So first of all, I will get into the Python mode and I will clear the screen. And now let's get started. So the first thing I want to do is I want to work with a string. So of course I will use my name just to promote myself. Okay, maybe I'm self-obsessed. Doesn't matter. So we got Naveen here, and then when I enter, you got the name, the string itself. But what if I want 2 words? Of course, you can put that into a string in single quote. You can put Naveen Telusko. It works, right? There's nothing wrong. But what if I got 2 different strings? One is Naveen, one is Telusko. So again, there are 2 strings now. So this is one string, and this is one string. So when you do that, what happens? Will it give you bad words? I mean, will it give you errors, or you will get the output? So when you run this, it works. So basically what it is doing is, it says, okay, I got 2 strings here. One is this, written side by side. So maybe my job here is to concatenate it. And that's what it is doing. It is basically concatenating these 2 things, and things are working fine. That's cool. In fact, I should have given a space there just to have this type of output, but you got the point, right? So when you got 2 strings like this, you can simply keep them side by side and it will work. But let's say I got a name variable, and in this name variable, I got my name. And when I say enter, okay, so I got a name variable in which I have my name Naveen, and now I want to print Naveen Telusko. So Naveen is the name, I know. But what if I want to write Telusko here? What do you think? Will it work? It worked before when you had a string literal. So this is called a string literal. So when you got 2 string literals, there's no issue. But now we got a variable and a string literal. What will happen? Now, maybe this time Python will not be happy with you. Python will say, what you doing? This is not how you write a variable and a string together. And that's what it says, This name makes sense. What is this Telusko after that? It is an invalid syntax. Now, how do we solve this? Pretty simple. You can simply go back here, name, and then you can say Telusko. It's just that you have to tell your intentions here. When you have a variable and a string literal, you tell your intention. See, my intention here is to concatenate these two. So Python says, in that case, give me a plus operator. This plus operator is actually a smart operator because when you give numbers, it will add to numbers. When you give a string, it says, okay, I can't add them, I can concatenate them. And that's what it's doing here. Okay, and when you say enter, you can see it came side by side. It's just that I wanted to give a space here and now it works. So that's how basically you do the concatenation of a string literal and a variable. So now let's work with string as a collection of characters. Okay, what I mean by that. So what I will do is, first of all, I will clear this. Okay, just keep it empty. And now I want to have a text as a variable. And inside this, let me have a value as Telusko. Now this Telusko word has 7 characters, right? And I will say enter. So basically, if I try to print text, it will print all the 7 characters. That's a string. But what if I don't want to print the entire set of characters, or I can say that I don't want to print the entire string? How do you print a particular character here? So let's say I want to just get T out of it, or maybe I want to get a E out of it. How will you do it? So let's take text, and then you use something called a square bracket here. Now this is kind of a list which we are going to see later. But at this point, imagine if you have a string like this, it has 7 characters as you can see on the screen, and each character will be having some number, right? So we can count. So example, let's say if I have a desk here and on this desk I got multiple objects, I can count, okay, 1, 2, 3, 4, 5, 6, 7, 8. That's how we are counting, right? And same goes for this Telusko 1 to 7. But in programming, we start the number by 0. Okay, so here, the first character is 0 index. That's a new word now. Now, index, we refer to a particular location. So here, the T is at 0th index. Then we got E, we got 1 index. L is 2 index. That's how it works. So the O is the 6th index. But yeah, when you call them as what location, you can say first or 7th, but when you say index, it is 0 to 6. Okay, and if you are new to the world of programming, this is where people do struggle to work with the index numbers, but don't worry, you will get used to it. Okay, there's no easy way of saying this, but you will get used to it. Okay, so you will say I want something at this 0th index, which is the first position. When you say enter, you got T. Okay, now if you want to get, let's say, some other location, let's say if I say 3, now what is your guess? So, or not guess, it should be accurate, right? You can see on the screen, it is U. That's right. It was a guess for me because I can't see the screen. That's post-production, which you can see on the screen. Okay, now if I say 6, then of course it will be O. But what if I say 7? And that's where Python is not happy. Python says, hey, stay in your limit. I mean, it says string index out of range because you're going outside the range. The range is 0 to 6. That's what the text here. And when you say 7, basically you're looking for the 8th location, which is not there. So it says string index out of range, index error. And it's important for developers to read the errors as well. Just because something went wrong, you will say, hey, let me just check the code again. No, first check what the error is. Okay, now I know I'm out of bound or out of range. I can just come back and, okay, I will fetch 6. That's what we can do. Now, this is how you go with the range. But can we try a negative range here? So let's say I want to try with -1. So guess what it could be in your mind. And now let's see. If I enter, it says O. Okay, now that's weird. Why it says O for -1? Because see, if you try to understand the normal range, the T starts at 0. So before this, there should be empty, right? It should say out of range. It's not doing that. It is for -1, it is saying O. It's because the string in Python, it allows you to have 0 to the plus index, like 6 here. Also, it can allow you to have minus index, which is -1, -2, as you can see on the screen. And it is helpful. You know why? Because when I was doing with this text 6, in my mind, I was still calculating. Even if I know this, I've done this multiple times, but still, somewhere in my mind, I have to be very accurate with what is the index for this O, and that is 6. But let's say if I don't want to get confused, I want to get the last character. I can simply say -1, it will give me last character. And then -2 is second last, -3 is third last, and that's how it goes. So it is helpful in that scenario. Now, if you say text of -7, it will be T because that's the first character. But again, if you try to do -9, it will say the same thing. You are going out of range. Okay, so let me print text again. Now let's try something else. I want to print the, let's say, USKO. I just want to print USKO. Now, if you want to do that, I can simply say text. And from this Telusko, I want to fetch the last 4 characters. That means I want to skip the first, the second, the third, which means index 0, index 1, index 2. So I want to skip this 3. So I have to start from 3 and then I have to end where? Okay, so end should be the last value which you want plus 1. So the last value which I want here is USKO. O is 6. I have to say 7. Enter, and you can see we got USKO. Now, why 7? If you are wondering, it's just that it will exclude that particular value. Okay, it will include 3, it will exclude 7. Let's say I want to get the first 3 characters. Now you help me. So it will be text, and you might be thinking how you're helping me. That's all mind power. You think that I will get to know in the past because I'm recording now. Okay, such a weird example. Anyway, come back. So if I say 0, and I have to start with 0, right? Because I want to include T. So we are trying to print TEL. So 0, 2, I have to end where? So I need to get L also, which is at index 2. So if I say 3, it will take TEL. Let's say I want to print from L. So L starts with 2, and then I have to end at 7, right? But even if you say 9, there's no issue because you're starting with L, and when you say 9, it simply says, okay, go till the end. I don't care where it is. Even if you say 100, it will end at O. That also means you can skip the last part. I mean, if you just want to print at the end, why to even have a higher number? Just say empty, it will go to the end and your job is done. And not just for the end part, you can also define for the start part. Let's say I want to end at 3. I want to start from 0, but end at 3. You can do this. So Python is fun, right? Let me clear this and let me print text again. What else we can do here? Let's say I want to print LUSKO, but I want to change that TEL to be capital and USKO to be small. Okay, so first of all, I can assign directly a new value to it. Example, something like this, and enter. This will work. If I say text, there is no problem. The new text itself is TEL capital and USKO small. Now, why it is working is because you are changing the value of a variable, and you can change the value of a variable. Nothing wrong with that, right? But now what I wanted to do is, okay, let me just get back to Telusko. And now if you say text, it is Telusko. Now what I want to do is I just want to change the existing string. Let me repeat. I want to change the existing string and make the first 3 letters capital. If I want to do that, maybe I can say text. And then, okay, first of all, I just want to get some extra space here. I will say text. And then I can specify from 0 to 3, which is the first 3 characters, because 3 is excluding. I can say equal to TEL. Now, if we can do this, that means the first 3 letters will be changed to TEL, capital TEL. USKO should remain same because we are trying to change the string itself. And if you say enter, it is giving you an error. It says you can't do that. String object, which is str object, does not support item assignment. Basically, you can't change the existing string. Okay, that's cool. So this is one thing you have to remember. You can't change the existing string. You can change the value of a variable, but you can't change the existing string. Now, if you're thinking both are same, right? No, this will make much more sense once we talk about references, objects. It will make sense. Okay, apart from this, I want to show you one more thing, and in fact, 2 more things, and then we are going to end this. Let's say if you want to find the length of a string, you can use the len function. Again, we have not talked about functions at this point, but just imagine there is something in the world which will take your text or your data and find the length of it. That's what it's doing here. Maybe I also want to print something. Maybe I want to write a poem which is not in one line, because if you say text is equal to, and if you say my name is Naveen Reddy, welcome to Telusko. Okay, by default I'm saying T is E capital. So if I do this, I'm writing this in one line, right? And maybe I want to print this in 2 lines. So one thing you can do is you can put a /n here, and then when you try to print text, not like this, but if you try to print text with a function, it will print on 2 different lines. So we have to put this /n here for the new line. So this will get printed, and then this will print a new line on which you are printing welcome to Telusko. There's another way of doing this. I'll clear this. Also text is equal to, you can use triple double quotes. Okay, that's weird. But, and then you can say enter, and you can say my name is Naveen, welcome to Telusko. And when you do this, you have to make sure that you end with triple double quotes. And when you say enter, it worked. And if you try to print text, of course, it will print in this fashion. But if you print in a text or you're using a print function, this is what it does. Okay, so you want to use this syntax or the syntax which I've used before, your choice. So yeah, that's about string in Python. We'll talk about list. And before we do that, instead of working with the prompt on the terminal, so basically till this point I was opening Python in the terminal, but now I'm going to use IDE, and we have talked about this before. So this is one way of testing your Python code, or if you are learning Python, you can use this. The reason I was using the terminal is because it looks good. The black screen, of course, I can set it black here, but then the font and other stuff are good there. But ideally provides you some extra features which we are going to see in this particular video or in the upcoming videos. In fact, when you open IDE for the first time, it will give you a white light theme, and the font will be small. So you can go to options, configure IDE, and then you can change things from here. Not that difficult. Now, once you are here, now let me create a list. Now, first of all, why in this world we need a list? See, when you talk about saving a number, if you want to store a string, it is very easy, right? You can simply take that value and store it in a variable. And we have done that before. Example, let's say if I want to store a number, I can create a variable which is num1. And in this, I can store a number, let's say 65. It is so simple. If I say enter and if I try to print num1, it will print it. But what if you have multiple numbers? In that case, we can create a variable nums. Of course, name doesn't matter. But here, let's say I'm going for a variable name nums. And in this, I want to have multiple values. So let's say 45, 87, 21, 24, and 99. So we got all these numbers here. And I want to store this in one variable. Even if I say enter, it will work because it's a different data type, which we're going to talk about later. But if you want to create a list, okay, so what is list? List is basically a collection of values. So I'm going to put that in this square bracket. So when you have this values in a square bracket, and you saw some little animations there, it completed the list. So that's one list with 5 values. And if I say enter, no error, everything is happy. And if I print nums, this is your list. It's that simple. Okay, so whenever you want to have multiple values, we can store that in a list. Now, what if you want to, of course, when you wanted to print everything, you did that. But what if you want to print a particular value? Let's say I want to fetch the first value. Can we do this? Now, if you go back to the concept of string, which we talked about, in string, of course, it's a sequence of characters or a bunch of characters coming together, or I can say collection of characters coming together. And if you want to fetch a particular character, of course, you can use the index numbers. Here, we can use the index numbers. How? So I will say nums, and in this square bracket, again, I have to mention the index number. Okay. See, you have to remember where to use square bracket, where to use round bracket, and that's all about programming. Okay. Programming is fun. It's more English. It's just that you need to remember which bracket to use where. So when we use list, we have to use square bracket. In the upcoming videos, we'll see some other data structures which will have some other type. Okay, so we got nums of 0, and if I say enter, we got 45. Yes, you can also print the 99 here. So I can say nums, and maybe I can use the index number 5. If you remember, this is one of the issue with index numbers. Start with 0. We got 5 values. So index number, if I say 5, of course, it will give you bad words. It will say stay in your limit in its own way. It says least index out of range. Okay, so I know the last index is 4 and this will work. But since I was not sure at the start what will be the last index value, I said 5 and I'm saying 4, it is working. But can we use negative values? Remember, in string we have done that. So here, if I say -1, it works, right? So this is the advantage of using the positive and negative index values. Now we can also do slicing here. Now if you remember, in string also, we wanted to print a specific section of a string. Now that is called slicing. Now in this example, let's say we got a list here, and out of this list I want to print the last 3 values, or maybe these two values, 21 and 24. So the index number is 2 here for 21, and then index number 3. This is what I want to print. So I can say nums, and then I can specify from where I want to start. I want to start from 2, and then I want to stop at 3. So we have to say 4 because 4 is excluded. And if you say enter, we got those 2 values. Okay, so this is called slicing because you're getting a slice of a particular list. Okay, what else we can do here? Can I print from 21 to 99? Yes, we can. So the way we have done it, okay, so when I say up arrow, it is not printing. I think I have to do some setting for that. History previous is Alt P. Okay, so if you want to get the previous value, it is Alt P. That's what I got to know from the configuration. And if you ignore this, if you say 2 colon, it will go till the end. Is that easy? Till this point, we only had the numbers. What if you want to have different data type? Yes, you can do that. It's not just about, okay, you can't even clear it here. That's one tricky part. But okay, let me do it by giving enter. So I will say names. So I want to have a string array here, or string list here. So I will say Naveen. So you have to make sure that you put the single quote there. And then you will say, let's say Harsh. Then you give a comma, you will say Kiran. So you got all these values, and if you say enter, and when you try to print names, you got all the values. It works, right? And not just the names, of course, you had string here, you had numbers, but we can create a separate list which will have different values. So let's say I want to have a name here. Then I want to have 67 as a number. Then maybe I want to go for float value as well, 6.5. So you can have different type of data in one list. There's no restriction that it is homogeneous where it only has one type of data. So if you say enter and if you try to print mix, it works. Okay, so this is the beauty of list. You can have mixed values. So we got integers, we got numbers, we got string, and we also got a mixed value. But can I create the mixture of nums and names? I want to have this list. So this is first list. This is second list. Can I combine that in one list? Okay. So when I say combine, there are 2 meanings of it. So I will say mix here. And in this mix, I'm just using the same variable again. I can say nums and I can say names. Now what I'm trying to do is I have 2 lists, nums and names, and I'm putting that inside a list. So this is list inside the list. So when I say enter, there's no error, it is working. So when I say mix, you can see we got the mixed values. You can see it is starting from here and it is ending here. That's your list. And inside this list, we got 2 lists, 1 and 2. Now, why this is important? So let's say if you try to print the first value of a list, if I say mix 0, what do you think? Which one will print? Now this is tricky, right? Now if you think this is going to print 45 because that's the first value, no, that's not the case. It is printing the entire list of numbers. Reason, if you say the size of this mix, okay, so if you try to find the length of this mix, you can see the size is only 2. That means we only got 2 elements in mix. This is the first element and this is the second element. So the entire list here is 1 element, okay? And then you will say, okay, I want to fetch this 45. How will I do it? That's fine. You can say mix and then you can specify, okay, I want to get the first list, which is this particular entire list here. And from this list, I want to get the first value. So then again, you can write a square bracket and you can say 0. So it will print 45. What if you want to print, let's say, Kiran here? So in this case, you will say mix. And inside this, you will specify, okay, from the mixed list, I want to get the index value 1. And from this index value 1, I want index value 2. So you can say 2. Enter, and you got Kiran. So this is how basically you can have a list inside a list. In fact, if you remember, we talked about mixing this two lists. So of course, we got that. We got one list inside this, we got two lists. But what if you want to create single list, which will have all the values? In that case, you can say mix equal to nums plus name. So if you want to combine the values, you do this, and you can see all the values are combined now. So let's see what else we can do with list. I have restarted this window, so I have entered this value once again, nums and names, and of course I can print this. But before I do that, I also want to create mix, which is the combination of nums and names. And if I try to print mix, this is what we got here. So what I'm trying to do now, when you check, let's say nums, and if you say dot, and this only works with the IDE, the moment I say dot, it will take some time, maybe 2 seconds, and it will pop up some functions there. So these functions are operations which you can do with your list. Like you can do append. Of course, in the post, we'll try to zoom it so that you can see it. So we can say append, clear, copy. I don't want to clear now because I will lose the value. Copy, count, extend, index, insert, pop, remove, reverse, and there is also sort at the end. Okay, so we got all these functions here. Now we'll start with append. Now what is append here? So append takes a value from you. Okay, that's what it says. So let's say I'm going to add 33. Now what will happen is, we got the nums with all these values. When you say nums.append 33, it will add that value in the list at the end. Okay, so if you say enter, and if you try to print nums, that's what you got. You got this value 33 at the end. Okay, so apart from append, what else we have? So we can say nums dot. So let's try to explore the other methods. If the pop-up is not coming, you can even say control space, it will be quick. Then you can also use something called count to give you the count of values. So when you say nums.count, and you have to mention the number. So let's say I want to see how many times 14 occurred. So when you say 14, it says 1. And if you use a different value here, so let's say 15, and there's no instance of 15. What else we can do here? So I will say control space. I can even find the index of a particular value. I can insert a value. Now, what's the difference between insert and append? Of course, insert will also insert the value in the list. And when you say append, basically you add at the end. But using insert, you can insert in between. Let's say I want to insert a value 55, but I want to do that at index number, let's say 1. So what will happen is, currently the index number 1 is 56 here. Now, when you say at index 1, I want to add 55, all this value will be pushed, and then 55 will be here. So when you say enter, and if you try to print nums, you can see we got 55 and then 56 and the entire values. Now, if you observe one thing, when we are trying to work with string, and when we were trying to change the values or the characters of a string, it was not allowing it because it was immutable. List, on the other hand, is mutable, and that's why you're able to do that. So mutable simply means it can be changed. So we are able to change the values of a list because it is mutable. Okay, what else we can do? Now, since we can insert or add, we should be also able to remove the values. So I can say nums dot remove. And in this remove, I can pass a value. So let's say I want to pass a value 56. I want to remove 56. I can simply enter that and it's removed. It is not returning anything, and that's why it's not printing anything there. But if you say nums, now there's no 56. But what if you want to remove not from the value, but from the index? Because here, when you say remove, we are passing the value, right? If you want to provide the index, then you can't use remove. In that case, we have to use pop. And in this, you can pass the index value. Let's say I want to remove 45 from here. So this is 0, 1, 2, 3, 4. So I can remove 4. Now, why this word pop? See, when you talk about programming, we have this beautiful type of data structure which is called stack and queue. So stack is a data structure like list. The difference is stack follows last in, first out. So the last element which I have added will be popped out first. And that's why it says pop. Okay, it's like, when you have a stack of books and the last book which you kept will be the first book, you will take it out. So that's pops. And when you say enter, now you can see it returns the value 45 and then it also removes it. So if I say nums now, 45 has been removed. In fact, you can also write pop without passing the index value. And you know which one it will remove? We have just discussed. Last in, first out. So the last value will be popped out. In fact, we can remove multiple values. So there is a keyword in Python, an inbuilt keyword, which is called del. And you can perform the operations on list with the help of del. So you can say nums, and you can specify from where to where you want to delete. So let's say I want to delete 14 and 36, these two numbers. So I can start from 2 and I can say 4 because 4 is excluding, enter, and it is not returning anything. So if you try to print nums, so 14, 36 have been, okay, so it is 4 is included. Oh no, 36 was already removed, and now we have removed 14 and 36. Okay, so we only left with 23 and 55. So the list which started with huge amount of values, we only got 2 now. Okay, now since we are removing the values, maybe I want to add more values here. So let's say, let me insert some values. Now to insert the value, we can use append, we can use insert. But what if I want to insert multiple values? In that case, we can use something called extend. And in this extend, you can pass a list in which you can pass a value. Let's say 44, 56, 11, and 99. So when you say enter, so all these values got added to nums. So if you try to print nums, this is what you got. So we have talked about list as a immutable type, right? So what we can also do is if you try to print nums here, we got all the values, right? But let's say I want to replace these two values, 44 and 56. So in this case, I can say nums, and I'm going to replace the index number 2, 2, 3. So we have to say 4 equal to, and then we can replace those values, let's say 54 and 76. Now when you do that, and if you check the new list, we have replaced those two values. So yeah, we can also replace a particular value with the help of this syntax here. Okay, now let's explore some Python inbuilt functions. In fact, okay, so let's finish the functions of list first. So we can also use something called reverse to reverse a list. So when you say reverse, and if you try to print the list, so the sequence was 23, 55, 54, 76, 11, 99. Now it is reversed. We can even do sorting. So I can say sort, and if you try to print nums, this is what you got. So these are the inbuilt functions of, or these are the functions of a list. But in Python, we got some inbuilt functions we can use on them, which is min. Now, when you pass a list inside a min, it will basically find the minimum number. And when you say max, it will, of course, now you know, it will find the maximum number. We can even do sum on this nums, which will give you the sum of numbers. Okay, can I apply min on names? Because we do have names. There's no issue. It says, okay, minimum is Harsh. Now, you know why it is Harsh? Because if you go up, this is where names and Harsh is minimum, is because Naveen starts with N, Kiran starts with K, and Harsh starts with H. So H comes before N and K. That's why. Okay, what about max? You know you will get Naveen there. But can I do sum on names? And Python will be unhappy with you. What you're doing, okay? Cool. So these are the things you can do with Python. You can apply different functions, and it's cool. List is cool. So that's it from list. So when you want to store multiple values, we have an option of list, which we have used before. But then there are other sequences which we can use. And one of them is tuple. So let's try tuple and let's see what it does. So I'm creating a variable called tup or tup, doesn't matter what you call it. In this, if you want to store multiple values, the way you can do that is, let's say 23, 45, 67, and 43. Now, when you created list, we have used a bracket, which was the square bracket, right? And when you do that, so this is your list. And how do I know that? Of course, with not the name there, name can be anything. But there's a function in Python called type. Now, when you say type and when you mention a value there or a variable, which is tup in this case, and when you say enter, you can see it says class list. Again, what is class? We'll talk about that later. But this is of type list. Now, if you want to create a tuple, how do you do it? There are two options. One, you can remove the brackets and keep it empty like this. Now, this is also a tuple. When you say enter, and when you check the tup again or the type again, okay, now that's rhymes. Okay, so when you see the type, it is tuple. Okay, now there's one more thing which I've did now. When I clicked on the up arrow, I can see the last commands. Normally, this is how you do in the command prompt or the terminal. But in the ideally, you will not get that support by default. So what you do is you go to option, click on configure, and there's an option of keys here. In this, if you scroll down, there should be history, next, history, previous. Make sure that you change these options. And once you do that, you can click up and you will get the last command or last history, basically. So that's one. You can keep this number without specifying any bracket, or you can keep a round bracket. Both works. And when you say enter, again, when you check the type, it is tuple. So that's how basically you can create a tuple. And the way you have done in the list, you can do those things here. Example, let's say if you want to find the minimum value out of this thing, it's 23, which is the first value. And when you say max, you will get 67. So these things works. You can also do sum here. Now, what is the difference between tuple and list here? Now, when you said list before, you used to get multiple options, right? We had an option of remove, pop, then we have also seen append, insert. Now you can do those things because list is mutable. That means you can change the values or you can change the elements of it. Now in this case, when you say tup and when you say dot, control space if it is not popping up quickly, you can see we got two options. We got count and index. What count does? Count basically checks for a particular number, how much occurrence you have of the same number. And second, index will give you the index value of a particular value. But there are no methods which talks about inserting or removing. That means tuple is immutable. Let me show you how. So if I want to fetch a particular value, let's say I want to fetch this 67 here, the way you can do that is by mentioning the index number. Again, we have to use square bracket whenever you want to use the index value. That's something you have to remember. And when you do that, you will get 67. It's straightforward. But if you try to change the value, let's say if you want to have the 65, and when you say enter, it will not work. It will say tuple object does not support item assignment. That means you can't change the value or the elements of a tuple. There's something you have to remember. It's immutable. Now, why this immutability and mutability is important? Now, once we go in the upcoming sessions, when we talk about different topics, I will mention, hey, this particular type or the structure supports only mutable data, or it only supports immutable data. So you should know which is mutable, which is not mutable. And when you work on a project and if something is not working, the value is not getting changed, you should know, okay, this is tuple, I can't change the value. So those are things important, and that's why this immutability and mutability makes sense. Now, apart from min, max, or type function, we can also use a function which is length to check the length of a tuple, and it says 4 because you got 4 values here. So there's something you can do. Apart from this, we can do one more thing. Let me say tup a is equal to, so that's the variable, and in this let me have some values. And it's not just you should have a value of the same type, it can be of different types. Example, I will say 2 here, and I will say Naveen, and maybe I can have 7.9 as a float value. When you say enter, there's no problem. If I try to print up a, you got all these values. Now there's one beauty about Python as being easiest language to work with. When you say this value, which is tup a has all these values, we got 2, Naveen, and 7.9. What if you want to store this value in a particular variable? So let's say I want to store this 2 in a variable num. The way you can do that is by saying tup a, you can give a square bracket and you can say 0. So with the 0 index, this will be picked and it will be stored in num. There's no problem with that. But what I want to achieve is, I want to have 3 different variables for 2, for my name, and for this value. So I can say num, comma, I can say name, comma, and I can say num1, another value. Now what will happen is, all these values will go into these variables. And if I want to show you how, if I say num, you can say num is 2. If I say name, it's Naveen. And if I say num1, it is 7.9. So this is more of a unpacking sequence because we are unpacking the stuff here into the variables. And this is the beauty of Python. It makes things very, very easy. There's only one thing you have to remember. When you do this operation, which I have done just now, so this particular operation, let's say if you try to fetch one more thing, which is num2. Now, will this work? Logically, it should not work is because we got one value, 2 value, and 3 values. So in total, we got 3 values here. So the length of this tup a or tup a is 3. And the variables you're trying to assign here is 4. Now at this point, Python will feel bad and it will give you some bad words by saying, what you're doing. It says not enough values to unpack. Expected value were 4 and got 3 because in tup a, in your tuple or tuple, you got only 3 values. So now we know that tuple is immutable. But let me show you one thing where you can make it mutable. So let's say, okay, not mutable in that sense, but let's see the example. So let's say I'm creating a new tuple, which is tuple, let's say this is B instead of 2, so that you will not get confused with the numbers. And in this, I'm going to have some values. Let's say 34 is the first value. Then my name, Naveen. And then I'm going to have, let's say, a list of values. Okay. That's right. You can do this. You can have a list inside a tuple. In fact, not just lists inside a tuple. You can have a tuple inside the list. You can have a list inside the list. You can have a tuple inside a tuple. So because those are the types, right? And this is actually one element. So for a collection of values, this is one element. So for the tuple, this thing 34 is one element, Naveen is one element, and this is one element. Now with this thing, if you try to change, let's say if you try to change the first value 34, of course it will give you some bad words. It will say what you're doing. No, this will not work. Makes sense. And if you do that with the list as well, if you try to assign a different list or different value altogether, or different type of data altogether, there should not be an issue. I mean, of course, it should not work. And with this also, it will not work. You can't assign the value. And we have talked about this before. Tuples are immutable, so you can't do these things. I'm trying to replace this with this, and it is saying the same thing. But let me try this. I will say tup B, and if I want to change a value of a list, so let's say in this tuple, we got this list, and in which I have a value which is, let's say, 5. I want to make this 5 9. So I can say tup. First, I have to target this particular list, and this list is your index number 2. So I'll say 2 here. And this from this list, I want to fetch this 5, again, which is 2. In fact, let's try to change 4, because that's into some index, so that you will not get confused with 2 and 2. So I'm trying to change this 4 and make it 9. So if you say 9, there is no issue. If you try to print the tuple, you can see it is working. So you are able to store, or you're able to change the value of a list because that's immutable. Yes, that's a part of a tuple, but you're not changing the tuple, you're changing the list. So it's just one element which is immutable, but the element inside that list can be changed. I know it might look complex, and that's why you have to try by yourself to make a sense out of it. In fact, you can do one more thing. I want to introduce a new keyword here. So let's say I want to check if 34 is a part of this tuple or not. So I can say 34 in tup B, it will say true. True means this is, so true and false, those are the Boolean values. And it checks 34 is in tup B. Basically, in will check if it is there. If it is there, it will return true. If it is not there, it will return false. Example, let's say if you try to match Naveen in tup B, you can see it says false. Now, this Naveen is this Naveen difference because there is a capital N here. Okay, that's something you have to remember. Yeah, that's about tuple. And the most important thing is two. One is this round brackets, and second, it's immutable. So we have talked about list. We have talked about tuple. Now this comes under sequence. Now we got one more sequence which we can work with, is called set. Now if you go back to maths, in maths also we have this concept of set. Now what is set? Set is basically a collection of values. Okay, there's a collection here. Set is the collection of unique elements. Okay, let me add one more thing. Set is a collection of unordered unique elements. Okay, what do I mean by that? So what I'm going to do is, let me create a set to show you. So I will say set1 equal to, and let me assign the value. Now to assign the value, how will I do it? What kind of bracket I'm going to use? Because we have to put multiple values. Of course, we can't use square bracket, that's for the list. We can't use round brackets because that's for the tuple. Okay, so we only left with one, which is the curly brackets. But and also, if you talk about maths, when you try to create set there or represent a set, you use curly brackets. Now in this, I'm going to say 23, 56, 78, 21, and let's say 56 again. Now when you say enter, of course there should not be any error, and there is no error. But then before I print this, let's repeat that statement once again. So set is the collection of unique unordered elements. So when I say enter, you can see, I mean, before entering, you can see there are 256 values when I assigned it. But when I say enter, 56 is only once. Second, the order is not maintained. If you can see, 23 is at the end now. 21 is at the second. It should be at the second last position. Then 56 is only one, and that came in first. Then 78 moved here. Now you might be thinking there might be some logic to it, some sequence because of which it is following. It's not ordered, first of all, because sequence is not right. It's not sorted because it's not in sorted order. Then what's the scenario? So there's a reason we use set, and you will understand that reason in the next video. But then set normally stores the value in different way, the way list and tuple works. Now what happens is every value in a set goes through something called hashing. So what we do is we take the value, doesn't matter is it number or string or anything, it will take the value, it will do the hashing operation on that, and it will give you the hash value. Now based on that hash value, it will store the elements in that fashion. So it's not stored based on the numbers you mentioned here, it is stored based on the hash value. Now why hash value? It helps you to speed up the process of saving and fetching. Okay, so set is used there. Okay, so that's why it is unordered and it only supports unique values. Cool. Now what are the things you can do with set? First of all, there's a keyword which we have used before. So let's say I want to check if 21 is there in set. Oh, okay, so I've entered wrong value. Yeah, that's true. But if I say 22, is it in set? No, that's false. So this is one operation you can do. What else? Let's try to say set1.count. Or maybe let's try to do length, not count. So it's a length of set1. Count will not work is because it is unique element, so there's no number of occurrence there. But length is there, so length works with 4. Now let's say I want to check if there was a type of set. So I'm just trying random things which we have done before. So the type of this set is of class set. So the way we have done for the list and tuple, so we have different types there. So this is set. But let's say I want to create the empty set. So the set without any values, I will say set2 is equal to. Now what do you think? How do I create the empty set? So in this, basically what we have done is we got values here. But if I keep the values like this, and if I say enter, there's no error. But if I try to find the type of set2, you can see it says class dict. So dict stands for dictionary. So this is of type dictionary, not this set. But why? In the upcoming videos, we'll focus on dictionary as well. So, and we'll know that this is how dictionary is defined. So how do you specify the set? Now, in that case, we have to use a function of set. So I will say set2 is equal to. So there's a function called set. And if you keep it empty, and now if you say type, it is set. So this is an empty set. So if we try to print this, this is empty. There's nothing there. But let's say I want to specify some values. So I will clear that first. And this is set2, let's say. And in this, I'm going to assign some values. And the way you can do that is, of course, with the help of set, or you can put curly brackets and you can put the values. Let's say I want to have a collection of characters here, something like this. So I got ABCD, MNOP. That's one. And then set3 is some other set. Let's say vowels, A, E, I, O, U. And let me add something extra, PD at the end. Enter. Now we got 2 set. Let me also print them. And you can see these are the values. And it's not ordered. Okay, it is printing randomly. I should have repeated some value here, but that's fine. You can see we got unique elements here. Now, if you remember something in maths, when we worked with set, we used to create Venn diagrams. So there used to be union of a set or intersection of a set. The different symbols which we can use, and we can do that here as well. So let me try the first one, which is set1 minus set2, and let's see what happens. Oh, sorry, I'm using the wrong thing. It's not set1, set2, it's just set2 minus set3. Now when you do that, you will observe when you say minus here, it is removing all the characters from set2 which is there in set3. So if you start with A is removed because that's here. B is still there because there's no B here. C is still there. D removed because we said D here. Then M is there, N is there, O removed, and P removed because P is there. So that's how minus works. Let's change the operation here. Let's say pipe. And if you observe, everything is there, either in the set2 or set3. So A is there, B is there, C is there, D, M, N, O, P is there, A is there, E is there, I is there, O is there, U is there. Okay, everything is there. So this is all the values of set2 and set3. Let's try with and with and it will only print the common one. So A is common between these two, then P is common, D is common, and A is common. So those are the common things. Let's try one more. So instead of pipe, we will be using the caret symbol. And this will print things which are not common. So A is removed, B is there because that's not common, C is there, she should be there. D is not there because that's there in both the set. And that's how basically you can use these operations. In fact, there's one thing which I missed in the tuple video. So in tuple, basically, let me create a tuple once more. And if I assign the value, so let's say I want to create a tuple of one element. How will I do that? So of course I can say 45, but if I say enter, and if I say type of tuple, it says int, it should be tuple, right? It's because you only have one value. It ignores the brackets there. So in case if you want to have a tuple of multiple values or one value, you can give 45 and comma, then it knows that that's a tuple. Okay, this is something I've left with. So yeah, we have talked about list, we have talked about set, we have talked about tuple, and that's how this thing works. So we have talked about sequences where we talked about list, tuple, and set. Now when you go back to list, normally we can have multiple values in one place, which is a list. The thing is, when you work with list, you work with the index values. Example, if you see on the screen, if you have multiple values, and if I want to pick a particular value there, I have to use the index numbers. That's good. But let's say if you want to create a phone book, how will you do it? So let's say you got a phone numbers as values, and if I want to fetch them, I need the index number. Difficult to find, right? And that's where we can use something called a dictionary, which sounds like a dictionary like this. And yes, we got words and the meaning of it. So that's the key and a value pair where you have a word and the meaning. On the other hand, you got a key and a value. That's what we want to do here. Something like this. So let's say I want to create a data here. So we can have any values here, right? And then to refer this, we need to use the index numbers. Now, when it comes to dictionary, this is not how you do it. You basically need a value which is there, but you also need a key for it. So how will you define that? First of all, you can't use square bracket. We have to use the curly brackets. But now you will say, hey, that's for the set. We can't use it for the dictionary. We can. If you remember, in the video of set, we have talked about the curly brackets where we wanted to create the empty set. And then the type was dictionary is because this curly brackets is actually for the dictionary, which we can use in set. Okay, so this is the set now. It is not dictionary yet. How will you mention this is a dictionary? You have to specify the key for it. Example, I can say this is the key, which is 0 is the key for 34, 1 is the key for 35, 2 is the key for 67, and 3 is the key for 8. And it works. You can see there's no error. And if I want to fetch a value here, let's say I want to fetch this 67 here. So I have to say 2, and this will work. Now you'll say, hey, that's what we can do in list as well, right? Anyway, we are using index numbers here. So the beauty is this key can be anything. But in the case of list, it has to be index value. So let me create another type of dictionary here with different values. So let's say this 8 is Naveen. This 2 is Harsh. 1 Sushil and 0 is Kiran. Now what we are doing is for every value here, we are specifying the key for it. Okay. Now when you say enter, there is no error. But if you want to fetch a particular value, let's say these values can be anything. It can be age or it can be, okay, that's not my age 8. But this can be anything. This can be age, this can be roll numbers, this can be a phone number, this can be anything. Now if you want to fetch a particular value, I have to specify the key. We can't work with index numbers now. So if you say 1, which is not the index number, right? You can say it says, hey, you are saying 1, but there's a key error. I'm not able to find any key here, which is 1. So you have to be very specific with the key now. So you can specify, okay, I want to fetch data with Harsh. So Harsh is a key and 67 is the value. You can't do other way around. You can't specify the value and say, okay, I want to get the key in this syntax. Okay, so this is how it works. Now, one thing to observe, when you say 1 here, of course, 1 is not the key, and that's why you got the error here. And Harsh is there, and that's why you got the value. There's another way of getting this data. So you can say get data.get, and you can pass the key here. So you can pass Harsh. So get is a function, belongs to dictionary. And when you do this, you will get the same value. So this syntax and this syntax are different, but does the same thing. It will give you data. But it differs when you are saying get and specify something, some key which does not exist. In that case, it will not give you error. It will say, okay, I'm not able to find it. What are you trying to get? Let's do this. Let's try to print and let's see what get returns when it doesn't find. It says none. Okay, so it says none when it's not able to find it. But this is not something I want to show to my users, right? In that case, what you can do is you can say data.get, and let's say I want to specify a key which exists. Let's say Kiran. And alternately, Of course, Kiran will print 34, we know that. But in case if you have this dictionary which is created dynamically where you are not sure what are the keys and values, in that case, you can have an alternate text where you can say, okay, not found. So if Kiran is there in the dictionary, great, you will get the value. If not, it should print not found. When you say enter, you got 34 because Kiran is there in the list or in the dictionary. But if you try to use, let's say 1 here, which is not there in the dictionary, or any value, not just 1, even if I say a different name here, let's say Gaurav, enter, you can see it says not found. It's because it's not there, right? Gaurav is not there in the dictionary, and that's why you got not found. Let's try something. So I want to create this data once again, okay, the way we have done, but with one change. Let me repeat a key here. Let's say I want to repeat Harsh. And then I want to repeat a value as well. Let's say 34. Okay. So you can see the value 34 has been repeated. The key Harsh is also repeated. Now when I do this and when I print data, observe something. Harsh is getting printed only once. I mean, Harsh is there only once. And the value 34 is 2 times. That means this keys here, this Kiran, Sushil, Harsh, Naveen, those are the keys. That represents a set. That means a key is a collection of set. So you can say keys are set and the values are list. Okay. And that's why you can see the values are getting repeated because in list we can repeat it. Now with that knowledge, if I want to create a dictionary from a set and a value, can we do this? Let's try. Let me create keys here, which will be a set. We know that now. And let me have Naveen and let's say Hitesh and Shamik. So we got these keys here. And of course, even if I repeat the elements, it will have unique values. And then let's say we have values, which will be a part of a list. And we can give some values to it. And doesn't matter what these values are. And you have to make sure that these are matching. So 3 values, 3 keys, 3 values, enter, no problem. So we got a set here. We got a list here. Now I can create a dictionary, let's say dict1, and I can combine these two. Okay, so how do you combine a keys and a value? Now, when you want to combine something, there's a function inbuilt in Python called zip, in which you can pass the keys and you can pass the values. Now, what zip will do is zip will basically take these values and it will combine it, but it will not create a dictionary out of it. So if you want to convert this zip output into a dictionary, you have to use a function which is inbuilt again, which is called dict. And when you say enter, let's try to print dict1 and you can see we got the values. So Hitesh is 34, Naveen 64, Shamik 87. And things to remember, the sequence is not maintained. Naveen was supposed to be 34, but Hitesh is 34. So there's something you have to also understand the behavior of the set. If you don't want this to happen, then you have to use the list here. That should work. So let me clear the screen. And let's say, let me print the data again just to see if the data is there. Yes. What if I want to remove the element? In that case, you can say data dot pop. So there's a function called pop inside the dictionary. And you can specify the index value here. So let's say I want to remove Naveen from here. So I can say that and delete. It returns the value of Naveen, but now if you print data, Naveen is not there. Not just this, you can also use del, which we have used before, and you can specify the dictionary. But this time you have to say something like this syntax. Sushil, and now I hope Sushil is not there. Okay, so Kiran and Harsh, both 34. In fact, you can also have a dictionary inside dictionary, something like this. Let's say I want to create data and I want to get a new dictionary now. And let's say this time we are going for the programming languages with the IDEs. So let's say for JavaScript, we use VS Code. For Python, I'm going to use the list, because for Python, we can use VS Code or we can use PyCharm. And for, let's say for Java, now the thing is, for Java, for different modules of Java, we use different IDEs. Example, let's say if you want to work with Core Java, use something else. So I can use a dictionary here and I will say for Core Java, I'm going to use, let's say, VS Code. And when it comes to Spring, let's say, I'm going to use IntelliJ IDEA. Okay, now that's a big code, big dictionary. And when you say enter, there's no error. If you print data, this is what you got. Now let's say if I want to know about JS, of course I can say JS here. There should not be an issue. It says VS Code, the IDE. When it comes to Python, it will give you a list. Then you can specify, okay, I want to get one value and it will give you VS Code. Now, when it comes to Java, you got a dictionary. Now, if you want to be specific, okay, I want to work with Spring, in that case, you can say Java and you can say Spring, it will say IntelliJ IDEA. So that's how basically you can work with dictionary. So dictionary can have a list, dictionary can have a dictionary inside it. And yeah, that's all about dictionary. Till this point, we have talked about variables, we have talked about different type of data. So we have worked with normal variables in which we can have numbers, we can have string, we have worked with list, tuple, dictionary, set. Now let's go back to the basics of variable. So what I'm going to do is, let's say I have a as a variable and I'm trying to store a value which is 5. A simple expression where you're saying a equal to 5, and we know when you print a, it will be 5. Now what is happening behind the scene? So we are assuming that there will be a box inside the memory which will be having this value 5, and the name of that variable or the box is a, right? That's what we are thinking now. Now when I say b equal to 5, so of course it should make a different box. So there should be two boxes, one with name a and one with name b, and if you try to print b, of course it will also print 5. Right? So two boxes, same value, 5 and 5, and we got a name A and B. So let's say if you are storing this value in the memory, so of course there should be an address to it. Now when you say you have an address there, I want to print it. How do I do that? May not be an address, but there should be some identity to it. And that's what I want to print. And that's where inside Python we got this inbuilt function called IDE, where you can pass the variable which is a, and it will print the identity of it, and that's what you got here. So this is the huge number, but remember the last 3 digit which is 056. Let me try it for b. Of course it should have a different ID, but when you print it you will get the same value. I mean, that's weird. Why two different boxes have the same address? Something like this on the screen. It's a conflict, right? Now what is happening is, let me try. Okay, so let me explain with this changes. Let me make b with value 6. When you do this, and when you try to find the ID of a b, so before I do that, what do you think? Are we changing the value of the box from 5 to 6 with the name b? If that's what you're thinking, say this. We got a different address. That means b is not the name of the box. It's basically every box will have an ID, and a, b, all those things are just references. But referring to what? They are referring to something called objects. Everything in Python is an object. A simple number like 5 is an object. A name like Naveen is an object. A list which have multiple values is an object. Everything in Python is an object. Okay, so what we are doing is those boxes are your objects, and inside this object you got values. And all this a, b, and whatever variable name which you use, they are just references and they are referring to it. So in the initial case, when you said a equal to 5, we got a box there with 5, and it will also check, do we already have 5 in the memory? If you already have 5, it will not create a new box. It will use the existing box. But since we executed this as the first line, we don't have 5 anywhere. So it will create 5 and it will refer a to that address. So there should be some area where you have a mapping of the references and the objects. So a is referring to 5 box, and then when you create b equal to 5, here also we are creating a variable which is referring to a box 5. Now since we already have 5 here, it will not create a new box. It will refer to the same box. So a and b referring to the same box. And that's why when you try to print the identity of it, you got the same values. But what happens when you say b equal to 6? Now in this scenario, it will say, okay, I'm trying to save 6. I don't see 6 anywhere. So I need to create a new 6 box, or a box with value 6. So it will create that box, and that box will have a different ID. And that's what you are printing it here. So b, which was initially referring to the box 5, which is referring to box 6 now, is all references. Let me try one more thing. I will create a variable called k, and k will be referring to, let's say, 5. Now what do you think? Are we creating a new box of 5? No, we have talked about that before. We have the same box of 5, but k as a new variable is referring to the box 5. Okay, so there are 2 variables referring to box 5 and 1 variable referring to box 6. Now, if I say b is equal to, let's say, 9, now b got a new value, and if I try to find, okay, first of all, let me print the ID of k. We have not done that. So you can see it is the same value as a. And if you try to print the ID of b, it's a new value now. Okay, so now we got 2 variables referring to a, referring to 5, which is a and k. We got 1 variable referring to 9, and there is no variable referring to 6. Now what happens to that box 6? Because nobody is referring to it. It's a memory wastage, right? Because you have a box there and nobody is referring to it. So what happens in this case? Now in Python, we got something called a garbage collection. So garbage collection is like a mini software which comes to your memory and say, okay, I want to clean up. Now which object will clean up? Will it clean up 5? No, because 5 is referred by A and also K. Will it clear 9? No, because 9 is referred by B. What about 6? No one is referring to 6. Now, in this case, garbage collection will say, okay, I got this object, nobody is referring to it, let me clean it. And that's what it is doing. And the same thing we do in our daily life, right? So let's say if you are cleaning a room and if you see a box or maybe if you see a remote lying on a floor, you know this remote is getting used for something. So you will keep it on the table. But if you find a paper which is no one is referring to it, you will throw it. So it's all about references. So if you find an object, no one is referring to it, just throw it. And now it's not just for numbers. We can also use it for, let's say, string. So let me create a variable called name and let me have my name there, which is Naveen. And let me create one more and I will say this is name1 is equal to, and I will say Naveen. Now when you try to print the ID of name and the ID of name1, you will find they are similar. So whatever we have talked about here is also applied for the name. So what is happening is inside your memory, you got this object called Naveen. And I mean, of course, you got the object and you got a value Naveen, and there are two variables referring to it. And this concept is called string interning. So basically, when you create a new string, it will check, okay, we got a string pool. Inside this pool, let's create this variable or let's create this data Naveen if not found. And then when you try to do that for the next time, it will say, okay, we already have Naveen in the pool. Let them refer to the same object. Why to create new one? That's a fun thing which Python does here. Now, this string interning works with the normal data, right? If you have a small string, it will work, one or two words. But let's say, I will just clear this out and let me create a new variable called A. And in this A, I'm going to create a string. I will say my favorite color is black. That's the first string. And even B is the same. Now, whatever we have talked about till now, I have not changed anything in this text here. Okay, both are same. So of course, it should be created only once in the memory. So if you try to get the ID of A, it's this. And if you try to find the ID of B, it's this. And they are not matching. Why string interning is not working here? It's because string interning works with small words or maybe a couple of words, but not a string like this. Why? Is because if you try to store everything in a string pool, you're wasting your string pool memory because it's a small memory. And if you try to put big string, it's of no use. Maybe in normal life, you don't repeat the same string again and again. You do repeat words, but not the entire string. But yes, if you feel I got a message which is of 10 words and you want to repeat it, you can do string interning. There's a process for it. Manually, you can ask your Python to say, hey, I want this to be done using string interning. It will do it. But normally it will not. And not just for string. Let's say if you work with numbers, because earlier we have worked with small numbers, 5, 6, 9. What happens when you work with big numbers like this? If you say A is equal to 1000 and B is equal to 1000, now what do you think? Will it be the same ID or different ID? They're different. So even that cache stuff works only for the small numbers, not even for big integers. Otherwise, you're wasting memory because you repeat small numbers, not the big numbers. So Python is smart in that case. So yeah, that's what about how your variable gets stored in Python. We'll focus on data types. In fact, we have worked with them before. We have worked with numbers, string. In fact, in sequence, we have talked about list, set, tuple, dictionary, right? So we have all those things. But there are certain extra things which I want to add in this video. And of course, we'll revise the old concepts as well. So let's say if I want to work with a variable, and if in that variable, let's say the variable is x, and I want to store a number 10, of course, the type of this variable x is 10 or is int, right? So if I say x, it's of type int. Remember this is a class type int. We'll talk about what is class later. At this point, read it as type int. Now, apart from this, if I want to work with float values or point values, I can say pi value is 3.14. Okay, I did something weird there. It should be 3.14. And if I try to find the type of it, if I say pi, it is float. So we got a type int, we got a type float. Apart from this, we have some more types which you can look at. One of it is complex numbers. Now, if you remember, if you go back to your maths concept, we had this concept of complex numbers, which is something like a plus bi or ib, depending upon which standard or which book you're referring. But yeah, so we have this complex numbers, right, where I defines an imaginary number. Now, if you want to define that in programming, the way you do that is not with I, but with j. And we can do that in Python. Okay, so let me show you. So let's say if I create a variable called c, and if I want to create a complex number, I can say 6 plus 8i. Okay, not I, but j. There's something you have to remember. In Python, we have to say j. If you say I, it will give you error and you can try it out. If I say enter, no problem. And if I try to print C, that's a complex number. How do we know that's a complex number? You can check the type of it, and that is complex. In fact, there's another way of creating a complex number. So let's say if you have these values in some variable, let's say you got a equal to 2 and b equal to 3. So we got these two numbers. And with these two values, I want to create a complex number. So it should be something like 2 plus 3i. In that case, you can create a variable c, and you can use an inbuilt function in Python called complex, and you can pass these two values. You can pass 2, 3, or since you have these values in a variable, you can say a, b, and if you try to print c, that's the complex number. Now, these functions are inbuilt functions, and not just complex. We got functions like int, float. Now, why you will be using them? Example, let's say I got this pi value, which is pi 3.14, and if I want to store that in a variable and I want to make it type int, let's try that. So let's say the variable is k, and in this I want to store the value of pi, but in the integer format. So if you say pi, then the k becomes a float value because pi is float. Now, if you want to convert that into integer, you have to pass that pi value in the int function. This is again an inbuilt function which will take a value and convert that into a integer value. Enter, and if you say the type of k, it is int. But what will be the value of it? Since we are converting this number into integer, you are going to lose some data. And what data you are going to lose? The point value. So if you try to print k, it will be only 3. On the other hand, if you have a integer value, which is k in this case, and if I want to create a new variable, let's say p, and I want this p to be a float value, and the value should be coming from k, which is of type int. So if you say k, of course the p becomes int now. In that case, you have to convert that into float by using a float function. And now if you check the type of p, it's of type float. And yes, if you try to print p, it will be 3.0. Now, all these are numbers. We can also work with string, which we have talked before. So if you say a name, and if you say a name is Naveen, and if you check the type of this name, it will be string. So we have talked about this. This is just a revision for you. The only new thing I think was about complex numbers. But in numbers, we got one more thing, which is of type Boolean. I know Boolean would be true and false. Why it would be integers or numbers? Let's check it out. So let's say if I try to create a variable, let's say a is equal to 7 and b is equal to 6. We got these two values. And I want to check which is greater. So I believe that a is or b is greater than a, which is not the case. But you can believe anything, right? So if I say greater equal to, and I can use an operator here, and I believe that b is greater than a, which is false, but in my mind it's true. And let's try to print it, and that's false. I am wrong, and I'm happy with it. So this is false, right? Because b is, yes, it is smaller than a, and this is a Boolean value. So false is a Boolean value, and we got two options only. We got true or false. Example, if I convert that from less than, then greater than, so we change it to less than now, and it will be, I have to print it also, it will be true. So we got two options. We got false and we got true, or true and false. In fact, you can directly store this values to a variable. I can check, is it? Okay, doesn't matter. Is it true? And if I try to print is it, it says true. Okay, so you can assign the values, not just true or false. I mean, not just true, it can also assign false. Now, why I'm saying these are numbers a few minutes ago, it's because you can convert this Boolean value into numbers. Example, if I say k is equal to, and if I say true, of course, the value of k would be true. But what if I try to convert that into integer? What will happen? If I try to print the value of k, it is int. The same thing happens when you do that with false. It is k is 0. So true is 1 and false is 0. This is something you have to remember because we're going to talk about this in the upcoming sessions or videos. So that's the Boolean type. Apart from Boolean type, we also got something called none. If you're coming from other languages, we got something called null there, but in Python we got none. Example, I can say result is equal to, or maybe I will say result, and if I try to print result, we're not getting anything. But if you try to print it, I just hope it will print something, and it prints none because there's no value assigned to it. And you can manually assign the value, which is none. Even that works. If you try to print, it will be none. Now let's shift our focus to sequences. So we have worked with list, and okay, let's say L. And in this L, if you say 4, 5, any value, this is the type of list. And if you try to find the type of it, it is list. Apart from this, we also got something called tuple. So we'll just change that square bracket to round bracket. And if I say T, and if I check the type of T, that's tuple, we can also create a set. And if I see the type of this S, that is set. And we have also worked with the dictionary, right? But apart from this, we got one more way of creating a sequence, and that is called a range. So how do we create a range? So you say range. Let's assign the value somewhere. Let me assign that to R. So R range, and I will assign, let's say 10. Now this R is a range. If you print R, that's a range. And if you try to find the type of it, it's a type range. But why you will reuse something called a range here? So first of all, range is a function which takes a parameter and it returns a range. But why do we use it? See, if you want to create a list, okay, so it's something like this. If you want to create a list, and if you pass R in this list, see what happens. Okay, it gives you an error. Let me try with set. Maybe I have used list as a variable somewhere before doing this. Anyway, so if you try with set, you can see we got this value. So when you say range, range starts with 0 by default and ends just before the number you have assigned, which is 10. But let's say if you want to include 10, then you will say 11. Okay, but now let's say, let me just print R, range is still there and set is still there. Okay, set, I'll specify R, this is still there. But what if I want to print even numbers till 10? So the way you can do that, you can say set, and again you will use range inside this. But if you set 10, it will print the same sequence again. So you have to start from 2 because that's where the even number starts. And then you have to end at 10 because I want to include 10. So you have to end it at 11. But you have to also mention the steps. By default, this step is 1, and that's why you can see 0, 1, 2, 3. That's a sequence. But if you want a step of 2, you will specify 2 here, and you can see it is 2, 4, 6, 8, 10. Step of 2, and starting from 2, ending at 10. And that's how range works. There's another way of using range using loops, which we're going to see later. But at this point, this thing works. So these are the types which are available in Python, which you can use. There are other types as well, but these are highly used. We'll talk about operators. In fact, before this also we have worked with the operators like addition, subtraction, but let's see what else we can do. Now in this video, we'll focus on arithmetic operators and relational operators. There are multiple options which you can perform. In fact, with string also or list, we are able to fetch values. Those are also operations. But then if we talk about arithmetic and relational, they are a bit different, and we are going to see that here. So let's create two variables here. So I will say A is equal to 3 and B is equal to 2. Simple variables, simple values. And I want to perform some operations on them. So of course I can add these two values, store it somewhere. But let's say we don't want to store it anywhere. I can simply say A plus B. Now what we are doing is we are trying to add these two values. A, which is 3, to B, which is 2. And then when you click on enter, you get the value 5. As simple as that. Now, apart from addition, we can also do other operations like A minus B, which is subtraction, then A multiplied by B, which is multiplication, and A divided by B, which is the division. Okay, so you can perform all these operations here. Now, we have also talked about double slash before, which will give you the quotient, not the point value. And if you want to get the remainder, you can use mod to get the remainder, which is 1 in this case. So these are the simple operations which you have. Now, what else we can do? So let's say I want to add A and I want to increment the value by 2. So the value of A is 3 at this case, and I want to increment the value by 2. The way you can do that is by saying A is equal to A plus 2. As simple as that. And of course, this will also give you 5. So the current value of A is 5. Makes sense, right? But there's a trick here. This is the plus operation, or you can say addition. But also we have used one more operator here, which is equal to, right, which is the assignment operator. Now, this is not the first time we are doing this. In fact, in the first two lines also, we are assigning them, right? So 3 is assigned to A, 2 is assigned to B. So that's your assignment operator. Okay, but then if you want to perform this operation, where if you can see, we are incrementing A itself. So can't we just use some shortcuts? And yes, we do have shortcuts. We can say A plus. So we want to increment A, but how much? So I have to say 2. So we are increment the value of A by 2. This is a shortcut, also called assignment operator, or in some languages we call shorthand, if that makes sense. Even this works. If you say A, this is 7 now. So of course, A was 5 and now we are incrementing by 2. So this is 7. In some languages, we also use A++, which doesn't work here. You can see we got an error. But you can use this shorthand. And if you want to increment just by 1, you can say A plus equal to 1. Even that works. If you check the value of A, it is 8 now. So let me clear it. So that's how you can work with the arithmetic operators and assignment operators. In fact, for assignment, this is a fun thing about Python, or the amazing thing about Python is if you want to assign values to two variables, let's say X and Y. So if I want to assign the value of 6 to X, I can do like this. And if I want to assign 5 to Y, then I have to say enter. And on the new line, I have to say Y equal to 5. Can't we just assign those values in one line? And Python says, yes, hold my cup. I should have said something else, but I'm not sure who is watching this video. So X comma Y, 5 or 6 comma 5. So what we're doing is we are assigning the value of 6 to X and 5 to Y. And if I say enter, let's check the value of X, let's check the value of Y, and they have been assigned. So that's how basically you can work with the assignment operator, and you can assign two values. Now, if you go back here, the operation which we have performed, which is A plus B, A minus B, those are called this plus minus here called binary operators. Now, why they are binary is because we got two operands, right? A and B, and we got one operator. So this one operator working with two operands. But what if you have a single operand? In this case, we can, let's say if the value of A is 8, and I want to negate it. I want to make it minus. So you can say minus A, it will be minus 8. Now this operator here, which is minus, is applicable only for one operand. So that is called a unary operator. Okay. But again, the value of A is still 8. It's just that we are printing it the minus 8. But if you really want to make it minus 8, the value of A, you can say A equal to minus A, if that makes sense. Now A itself becomes minus 8. So that's the arithmetic and assignment operator. Let's talk about the relational operators. Now here, let's say I got the value of A as 4 and the value of B is, let's say, 3. So we got two variables and two values. I can compare them. Okay, now when you compare these two values, you can do that with the help of less than equal to, or less than, or greater than equal to, or just less than, or just greater than, or not equal to. And when you do that, the result type would be Boolean. And we have talked about Boolean before. Let me show you what I'm talking about. So if I want to check if A is greater than B, and in this case, yes, A is greater than B, it will return true. If I say A less than B, it will return false. So this operations results in a Boolean value, okay? And not just less than, greater than, we can also try, in maths, we do less than equal to using this symbol. Here, we don't have that symbol on the keyboard. So we have to say less than equal to B. And when you say enter, it is false. It is not less than and not even equal to. But what I will do is I will just make the value of B as 4. Now A and B both are 4. And if I do the same operation again, it says true. Now it is not less than, but it is equal to. So at least one of the conditions should be true. We can also check for A is greater than equal to B. Now it is not greater, but it is equal to, so it will return true. So that's how we can work with the relational operators. Also, we have one more. I want to check if they are not equal to. So, or maybe equal to. So you can say A equal to B. So it will check if they are equal. Now, why not single equal to? That the way we do it in maths is because single equal to is for the assignment, right? So if you say this is assignment. And if you want to compare, we have to use double equal to. And when you say enter, it returns true. What if you want to check if they're not equal? In that case, you have to say not equal B. So this exclamation means not. And when you say enter, it says false. It's because they are same. So that's how we can work with the arithmetic, assignment, and relational operators. Now let's talk about logical operators. First of all, why do we need them? So let's go back to the previous example. We got the value of A as 4 and B as 4. Okay, both are same. We should have changed it, right? So let's make it B as 5. Of course, doesn't matter, but so we got two values now. A is 4, B is 5. And now I want to check if A is less than 10, and I want, so of course, this will be true, and B is greater than 1, and this is also true. So both are true, makes sense. But I want to combine them. Okay, so I want to check them in one line. So based on these two values, I want to do something. So in programming, basically, when you say your software can think, your computer can think, it's because of these things, right? Where you decide your path based on what result you get in terms of true or false. Example, should I take the umbrella outside when I'm going? It depends upon if it is raining. Of course, I have to take the umbrella, or maybe it's a rainy season, I will take the umbrella. Or maybe I'm not even going to the office, I'm going to play cricket. So why do I need an umbrella? I want to enjoy the rain while playing cricket. So these are the conditions which you check. In the same way, we got two conditions here, right? And I want to combine them. So maybe if it is Sunday, and if I'm not going to office, if it is Sunday, and if it is raining, doesn't matter. I will not take the umbrella. So I will take the umbrella only when it is Monday or weekday, and it's a rainy season. So if the both scenario is true, then only I will take the umbrella. I'm lazy, I know. But here, how do I combine this? So the way you do that is very simple. You just keep that in one line. So first condition, second condition on the same line, and you say enter, and your Python is not happy. Python says, what you doing? This is not how it works. Or maybe it says, we don't do that here. Anyway, so if you want to combine these two conditions, this is not how you do it. You have to put something in between. That's how the syntax works. So take these two conditions, and in between you say and. Okay, like in English, we do that. So this condition and this condition, if both are true, return true. As simple as that, right? So that's how you combine two conditions. If it is that simple, why we are making the entire video on it? Because there's a trick. Let's say instead of using and, if I use or, because we also use that in English. Sometimes we say and, sometimes we say or. Of course, we don't use that in the same place. Based on different scenarios, we use them. But here also it returns true. Then which one you should use? That depends upon how and or works. Now, first of all, if you are coming from a mathematical background, you might have seen this before. There is something called a truth table. Now see, this condition is true, and this condition is also true. So when you do a and operation on true and true, you get true. This is true and this is true, and when you do or operation on true and true, you get true. But what about the other scenarios? Example, I will make this as greater than 10. Now B is not greater than 10, okay? And in this scenario, this will return true. But if you do the same thing with and, it will return false. So yeah, things are different. It's not same. Because this is true and this is false, still your or says true. This is true and this is false and says false. Now, to understand this more, we have to look at the truth table. Now, let's look at the truth table for and first. Now, let's say we got two inputs, A and B. Let's not use A and B. Let's say something else. So, for condition 1, C1, C2. So, we got two conditions. And in these two conditions, both are true, then you will get true. We are talking about and here. So, and means both are true, then true. If the first one is true, second is false, it will be false. Let's say in the third one, first one is false, second is true, it will be false. And if both are false, it will be false. That's how and works. So only place where you get the true in the output is if both are true. On the other hand, if we talk about or operations, if both the conditions are true, of course you will get true. If one of them is true, also you will get true. So let's say true, false, it is true. False, true, it is true. False, false is false. So the only way you will get false is both should be false. Example, let's use or here and let's make this both as greater than 10. Then you will get false because both are false. So this is how and or works. But also we got one more, which is not. So let's say I got result which is true. Okay, so of course if you print result, it will be true. If you say not result, of course you can't use exclamation here. That's only for the relational operators. But if you talk about logical operators, we have to say not. Now what not will do is not will just reverse it. It will say false. So result was true. If you say not result, it is false. It will just reverse the condition or the output. So those are your logical operators. Once we have talked about the basics, it's time to go for the intermediate level. Now, from the first video, we are talking about functions, right? Now, if you remember, we have talked about print, and then we moved towards int, float, and multiple functions. So let's understand what are functions, and that's where we are going to start. But then before that, I want to shift from IDE or the prompt of Python to IDE. Now, of course, you can use VS Code or you can use PyCharm. That's your choice. I'm going to use VS Code, and in between, maybe we'll shift to PyCharm. Doesn't matter, right? It's an IDE. Now, I have opened IDE, which is VS Code. I just wanted to give you some glimpse of what the things I'm going to work with. So if you're working PyCharm, do that, the same thing I'm doing. So open VS Code or PyCharm. In PyCharm, basically you have to create a project, and we have done that in the first few videos. Now in VS Code, I'm going to open a folder in which I have a folder in documents called Python course. In this, I'm going to create my first project, and we'll open that particular folder here. Okay, so again, doesn't matter what the folder name is. Make sure that you have your one empty folder, and that's what I got here. Now in this folder, I'm going to create a file, and I will say this is my first file. So or maybe demo should work. So this will be demo.py. Again, extension not compulsory, but then a good practice, and certain places where it will be compulsory. So keep the extension. And here I'm going to say print just to test if things are working out. Now I'm saying print hello. And since I do have the extension for this .py and also the VS Code extensions, which is Python here, I should be able to see this play button, which is run. For PyCharm also, when you type the same code with a file, you will be getting an option of running there. So when I run this code, it will be running on the terminal here, and that's what you can see. We got hello. Now, this is how basically you run the project, right? When you actually work on a project, this is what you're going to do. But since I'm teaching, I don't want to see, I don't want to show all this extra stuff here. I want things clean. The first thing I will do is I will run this code using Python commands. I will say Python and demo.py. Okay, that's one thing. And you can see I got hello. Also, I want to hide this path here. There are multiple ways of doing this, and I was able to find the simplest one. There are multiple options. You can basically you can change the configuration of your terminal or the PowerShell, and permanently you can get rid of this path, or maybe you can reduce the path, because as you can see, this particular folder is in Python course, that's into documents, that's into OneDrive, and then the path. So to reduce this, I have a script with me, and a simple script, thanks to AI. So I got this script here, which is function prompt, this one. This is the curly brackets open, there's a space here, then double quotes, PS for the PowerShell, the arrow, and then there's a space and this. Now, if you are using some other operating system and some other terminal, not PowerShell, I'm not sure about the prompt. So what you can do is you can just copy this and paste this in the AI model and say, okay, this is for PowerShell, what is for Linux or shell or different prompts. So check that out. Now when I say enter, you can see I got a smaller prompt here. And just to confirm I am into this particular folder, I will also check with the help of pwd, which is present working directory. And yeah, present working directory is first project, so I'm good to go. And here, if I run this, you can see we got the output hello. So that's the basic changes I wanted to make. And now once we have this done, so let's try to understand what are functions and why do we need it. See, when you're building a project, of course, in your project, you'll be having a lot of lines of code. Till this point, we are working with IDE and then basically the prompt, and then you are able to enter one line of code, and then we were able to see the output, and it was fun. But then when you build the actual software, it will have a lot of lines of code. And there are certain things, certain line of code, which you're going to repeat multiple times, right? Now, example, let's say if we talk about print hello here. Of course, if you look at this code here, and we are talking about this from a long time, this print is a function, okay? And how do we know that's a function? So we have a name for it, and then we are opening this bracket, closing this bracket. This is a function. Now, why this is useful? As I mentioned before, when you have a lot of lines of code, and if you want to reuse them, you can put that in one function. Let me show an example here. So let me remove this part as of now, and let me write a code. Let's say I want to add two numbers, as simple as that. So we got two variables. We got a as value 5, we got b as value 4, doesn't matter what other values are. And then we got a c variable in which you are basically adding these two values, a and b. The value of a is 5, the value of b is 4. So we know the value of c would be 9, and then here you can print it. So you can go to print and you can say c. Basically, you're printing the value of c. I think this is the first time when we're writing multiple lines of code in one go, not like a prompt where you are entering a equal to 5, then b equal to 4 in different lines. Here, we have all that in one line. Okay, in other languages, basically we put a semicolon there just at the end so that we can define, hey, that's the end of the line or the statement. But in Python, the simple enter works. Okay, even if you say semicolon, I don't think there's an issue in Python, but and why do we need extra symbol there? Now this is your code. Okay, now if you execute this, of course, you will be getting the addition and you'll be printing it. Let me show you. Of course, I can run that here, or I can type Python. You just have to make sure that you're in the right folder, and you can see we got 9. Now let's say if I have a lot of lines of code, maybe 10 or 100 or maybe 1,000 or maybe 10,000. Okay, it's not a good idea to write everything in one file, but let's say we have a lot of lines of code and maybe you want to reuse this code multiple times. So basically, let's say somewhere after 50 lines of code, you have this code again. So in between, you have a lot of codes here. And after that, you got this particular code. Now, why do we need this? You have to write this code because we want to do the same thing again. Maybe you want to add two values again. Now, don't you think if you want to write this code multiple times, then just write them once and give it a name. Something like this. Take this code, put that in a box, something like this. Maybe I can just draw some lines here to specify, hey, that's the box. And this box need to have a name if I want to call it again. So this is a code. I want to put that in a box and call it multiple times, or maybe once, my wish. And we can name this as add block. Okay, that's a block, and we got a name for it, which is add block. Now, since I have a name for it, now I can call it multiple times. So let's say in some other file, not in this file, maybe in some other file, I can simply say, hey, remember that block add, just call it. So I will say call add block, and this code will execute. Is that fun, right? But then if you can see the IDE, the VS Code is not happy with the statement here because this is not a Python syntax, this is English. So how do we do that in Python syntax? First of all, you don't give this lines here. Okay, let's put the lines there. First of all, you don't say add a block. That's not how you write a block. You need to create something called a function. Okay, this should be a function. Now, how do you create a function in Python? You use a keyword called def. Def stands for definition, and then you give this function a name. So I'm going to name it, let's say add. I don't want to think a lot. So add, and then you have to give round brackets to define that's a function. Now you have to open the function. This is the opening of the function. This is a closing of the function. But then again, Python is not happy. This is not how you create opening and closing. So how do we do it? First of all, you need to remove this. This is not how you do it. So how do we do it? Just after the add, you give a colon to define that whatever comes after this is a part of this particular function. Okay. And how do you say that it's a part of the function? You give a tab. So whatever code you need to be a part of this function, you have to write that with a indentation. So I'm giving a tab. Okay, so everything now belongs to this add. So the tab is not compulsory. You can also give a space, a single space, but you have to make sure that you're consistent with all the spacing. So for the first statement, if you're using 4 space, which is 1 tab, for the second statement as well, you have to be consistent. Okay. In other languages, we use curly brackets to open and close the function. This also looks curt, but then Python wanted to make it simple, so they have removed the curly brackets. You can just follow the indentation. This is a boon for Python developers because they don't have to type extra symbols, but also sometimes it can be confusing. Hey, where is that function starting? Where's the function ending? But you will get used to it. Okay, so once you know the indentation properly, you will get used to these things, and I got used to it, so that's fine. So this is how you define a function. Okay, at this point I will remove this. Just remember, this is a statement I have written. In fact, I can also use a comment there. I'm not sure if you have talked about comment before. A comment is basically a way to write something in the file but you don't want your Python interpreter to interpret. So you can say, hey, that's a comment. Okay, don't execute this. So in Python, we use hash as a symbol to write the comment. And now once you have done that, let me clear this and run it again. In fact, it looks good if I put that, or maybe I should keep it here. Enter, and okay, there is no error. That's a good thing, but there's no output. That's a bad thing. Now, why there's no output? Because we have commented this. Okay, let's uncomment this and say, okay, call add block, but again, this is in normal English. It's not happy. I will remove this, and let's find how do we do that in Python. So to call the function, you have to say the function name, round brackets, and that's it. This will call the function, okay? Now, you might be thinking, okay, this is a part of the function. Why this is not part of a function? Is because if you observe, for all this code here, all these lines, there's a space, there's a tab space, right? 4 spaces. Here we don't have any indentation. So this particular line is outside the function. Okay, that's something you have to remember. And now after making the changes, one thing you have to do is you have to save it. Very important, and run. And now you can see we got the output 9. Now, it's not that you can call it only once. You can call this as multiple times as you want. Add. So write it once, write this code once, and call it multiple times. Not just in this file. You can write it in other files as well. That's cool, right? And now you can see this is calling that 3 times. So you can call it 1,000 times, it will call 1,000 times. Not a good idea. Why someone will do that, but it works. So let's get back to one line of code. And now what else we can do? See, every time you call add, it will print 9, because that's what you're doing. You are hard coding the value of A and B, and every time you execute this function, you will get 9. I don't want that. I want this to be dynamic value. So let's say if someone is calling add and they want to add, let's say 2 and 3. Maybe someone wants to add 10 and 20, or maybe a big number. So how do I do that? So one way, you can just pass the value here. So you can say add, I want to pass 2, 3. Now this time I want it to add 2, 3, not 5 and 4. But if you run this, you will get an error. It says, okay, you're passing 2 arguments, but you're not accepting it. Don't you think if someone is passing the values, you need to accept it as well? And that's where you have to accept it. So let's say I'm accepting that in 2 variables called x and y. And again, variable name can be anything. So these 2 values, 2 and 3, will go in x and y. Okay, now there should not be any issue. Let me just run this once again. Oh, what I'm doing. Let's run this. Okay, there is a problem here. It says we are passing 2 and 3. Oh, can you see that round? I have not saved it. My bad. Okay, now you can see it says 9. But why 9? It should be 5, right? See, we are accepting those values here, but we are not assigning those values to A and B. We are still assigning 5 and 4. So let's say x and let's say y, and now it should be happy. Let's run this, and you got 5. That's how you can specify the values. Okay. Now let's say I don't want to print the value here, because what is happening is every time you call add, it will add those 2 values. It is printing it. That's a default definition of it. That's how we defined it basically. But let's say I want it to not print it. Maybe I want to do something else with that value. So let's say if you are calling add, maybe you want to print it. Maybe I'm calling add, I don't want to print it. I want to save that output in a file, or maybe I want to save that output in the database. Maybe I want to send that output to a server. My wish. Okay. So here, since we are printing it, it will always print it. So I would say, hey, let me decide what to do with that value. So what I want to do is, when I call add, I want you to give me the value. Give it to me. So I will say result. Now, since it will give, I have to also accept it. So I will call add, and it is responsibility of the add to give me the value. And that value goes into result, and I can do whatever I want with that. But unfortunately, let's try to print it. And I will say, with the statement, I will say result is, I will print result. So I want this to be printed as result is and then the value. But if you run this, you got 5 here because we are still printing it. And it says result is none. None is because this add function is not returning anything. And that's why you got none. Okay. If you are coming from other languages where we have a concept of procedures, this looks like a procedure where it executes something but not returning, but I want it to return, okay? And you might be thinking this is not returning anything. It is actually returning something. And you know what is that returning? It is returning none. None is a thing in Python which says it's none, okay? So it returns none, basically. What I want to do is I want to return C. So instead of printing it here, I can use a keyword called return, and I can see. So I can say return C here, which is a variable. So when you call add, it will add these two values, and then it will return the variable which is C, and that value will be assigned to result. And now if you see, it still says none, and I'm doing this mistake multiple times. I'm not saving it, and the result is 5. It's finally working. So maybe I will, if I execute this again, I will just copy this code and paste it here. Or maybe instead of saying copy paste, we should say code reuse. If I pass a different value, let's say if I pass 5 and 8, that should be 13. And you can see we got result is 13. That's how we do it. So yeah, that's about functions. And I want to show you one more thing. I know that's a lengthy video, but it's interesting. When you look at print, it's a function, right? And somewhere it is defined. The way we are defining add function, even print is defined somewhere. And when you hover on print, it specifies what the print function is. They have defined it using print name, and then it does some things. But there's a description of it. Prints the value to a stream or standard output. With string inserted between values. Okay, so it has a good definition or a description. And if you hover to add, it simply says there's a function called add. It takes two values and returns something, but there's no proper description for this. If you want to provide description, you can put that in triple quote or triple double quote. So you have to open triple double quote, and then you have to close it. In between, you can say adds two values. Okay, and now when you save it, and if you hover to add, you can see we have added this little description here. Okay, that's all about functions. Again, functions is a huge concept. It's just that for the upcoming videos where we are going to talk about certain things, this topic is important. That's why we have talked about functions here. Now, once we know what are functions, let's go to the next topic, which is modules. See, for different tasks, we are going to create different functions, right? And we know that now. But when you say a task or a group of tasks, normally what you do is, let's say if we talk about calculations. Now, for calculations, you might be doing addition, subtraction, division, multiplication. That comes under one particular thing. On the other hand, we can talk about, let's say, logging to a system. So log in, log out, maybe creating a new user, deleting the user. Those things comes under one system. On the other hand, we can also talk about e-commerce, where you are adding a product, deleting a product, or maybe adding a product to the cart. Those things comes under one thing. Now, of course, if you want to do individual thing here, let's say adding two numbers, we create a function. If you want to log into a user, that is one function. If you are doing a checkout of a product on e-commerce website, that is one function. But all these functions are different, right? So there's a grouping of functions which we can create. And normally what you do is you take this grouping of functions and put that in one module. Let me repeat. You take that bunch of related functions, or maybe functions belong to one domain, and put that into one module. So what is module? You can imagine module as a box in which you have all the related functions. Of course, you can have unrelated functions, but then why someone will do that, right? So module will have all the related functions of one particular thing. To give an example, let's go back to this thing here, and let's say I don't want to work with add anymore. We can remove it. In fact, let me remove everything. What I want to do here is, let's say I want to find a square root of a number. So if you want to find a square root of a number, let's say I will say result equal to, and in this result, I want the square root of this number 25. And we know the square root of this number is 5, but I want to do that with Python. Now, you can write the code for it. Okay, we are expert in Python now. We are expert in maths. No, I'm kidding. We're into learning phase now, but you can do that. Okay, you can write a code to find a square root of a number using Python. Like we did for finding a square of a number. So let's say if you want to find a square of a number 4, you can simply say 4 into 4. You will get the square of it. But if you want to find the square root, instead of writing the complex mathematical formula here, what I can do is I can use some inbuilt functions. The way we have done with print, we have done with int, all these are inbuilt. In the same way, we got this particular function called sqrt, which is inbuilt function. I can use that and I can put my number, which is in num, and it should give me the square root. And at the end, I will just print it. As simple as that. Okay, let me see if this works. So I'll say Python and demo.py. If I say enter, it's not working. If it is not working, let's stop the video and done. No, I'm not stopping the video. You can see the length of it. So why this is not working? So I'm saying that this is inbuilt and now it's not working. That means, is it not inbuilt? It is actually inbuilt. It's just that this type of functions, which are not normally used, but yes, people do use it. So we don't openly put that to Python, hey, anyone can use it. Because sometimes you don't want to use it. Why it is openly available? See, print, int, we always use. sqrt is a very special function, belongs to mathematics, right? It will be used only when you want to do mathematical things, right? So in that scenario, we can say, okay, this is not openly available, but this belongs to a module which you can use. Okay, so what is module? A module will have a bunch of features or normally functions, and this belongs to a module called math. Okay, so if you want to use that module, I can say import, and I can mention the module name, which is math. There are a lot of modules available. So if you say import and control space, you will see a list here, I hope. Yeah, there are a lot of modules here. We got base 64 if you want to perform operations with that. You can use a calendar module. You can use color sys, never used it, but yeah, we have an option. We got concurrent module, important. We got date time module. In the same way, we got math module, which we are going to use. And when you say import math, basically you got this module, and then using that I can say math.sqrt. So sqrt is a function which belongs to math module. So if you want to use a function of a module, mention the module name dot the function name. I hope this time this will work. If not, we'll stop the video. For sure, it worked. And now we are not stopping it. So the answer is 5.0. Is because sqrt normally gives you float values. You will get 5.0. Yeah, if you want to convert that into int, you can just pass that into int function and it should work. Okay, this is how basically you use a module. Now, of course, we can create our own modules if you want, but at this point, we are just using the existing modules. So math is a module of which we are using a function and we are able to do the things. And now, of course, sqrt is not the only function available in math. There are other functions as well. But this video is not about math. Okay, this video is about module. How do we import a module? That's what we have seen now. In fact, I want to show you one more thing with module. So let's say in math, basically we got one function which we are using, but we have multiple functions, right? Now, the moment you say import math, you can use all the functions in the code. But what if you don't want to use all the functions? You want to restrict how many functions I want to import. Also, I don't even want to write this math at the start. I can just remove it, but then Python will not be happy. If you remove that, Python will say, hey, what is this sqrt? So in that case, what you do is, instead of using this particular statement which you have used here, I will just comment it. And then you say, from math, I want to import sqrt. Okay, this is a syntax for importing one or two or limited number of functions. So from math, import sqrt. Now you don't have to mention math here. And you can see there's no zigzag lines there. I can simply try this now and it worked. So yeah, that's about the working with modules. Since we are talking about math, let's check out some more functions. Now, math has a few more functions to work with. In fact, if I go back here and if I say math dot, in fact, for that, I have to also uncomment this part. And if I check math, there are so many functions. One of the function is ceil. Now, when you talk about a number, let's say float values. Example, when I cleared my 10th standard, the percentage I got is 59.4. Now, whenever someone asks me, normally we do a round off, right? And when you do a round off for 59.4, it should be 59, right? Because you increase the value when it is above 0.5. But I used to say 60 because I used to always apply ceil function. So what is ceil basically? So let's say if you have a floor and ceil on top, and if you have a value somewhere in between, if it is near to the lower value, it will go there, right? That's the round off. But in ceil, it will always go to the maximum integer for that range. So example, if I say ceil of 59.4, and if I try to save that result somewhere, so it's a result 1 equal to, and if I try to print the result 1, let's see what output you get. So if you run this, you will get 60. Okay, that's my 10th percentage, not 59.4, because I use ceil. Otherwise, if I want to talk about someone else, let's say if I talk about my friend at home, even if that person gets 59.9, it's always 59. Okay, so float will give the lowest integer and ceil will get the highest integer. Now, why I'm showing you this is because I wanted to show you not my 10th percentage, but in math, you got multiple functions, and that's how you can try out. In fact, there's one more way of checking documentation. So let's say I will just remove this line. And also, if you don't want to write math.ceil, you can also use you can also import from math import ceil, so that you don't have to write that here math.ceil every time. You can just use ceil. One more way to get this, if I open terminal and if I increase the size here, that's huge. Okay, so if I go to Python now, and there's a function available which is help, and in this help you can mention what documentation you need. So I need documentation for math, enter, and this is the documentation. So if you want to learn about a particular module, you can do like this. Otherwise, you can also, let me just clear this. You can also use help math dot specifically. You can, if you want to understand about ceil, you can mention that. It will talk about what ceil does. So see the return of x as an integer. This is smallest integer, which is greater than x. Okay, that's the documentation. Apart from this, you can also use something called power for finding a power of a value. Example, result 1 is equal to power of, let's say, 5 raised to 3. So it will give you 5 raised to 3, and you can, if you want, you can just print it here. I don't want to print the square root now. I'm lazy. So if you do that, it will also work. So that's how you can find the power. So there are a lot of functions you can try it out. So for every module which we're going to talk about, you can also do that. You can check out different functions and use it. One more thing about the IDE is, this and this is different color because ceil you're not using anywhere. So it's a different color. It helps you to understand which function you are importing from the module, but you're not using it. So that's a feature you can use. I just want to show you one more thing before you go. Let's say if you don't want to use this syntax, if you want to use import math, and everywhere if you want to mention math dot something, so instead of that you can also say, if you don't want to use math as a word, see it is small, but sometimes you have a big module name, you can create a alias of it, something like import math as m, and everywhere you can use m dot, and that should work. Okay, just to confirm, yeah, it works. So that is from math module. We'll talk about how to use swap two variables. Now, there are multiple ways of doing this in different languages. We have different ways, but in Python, we have a very unique way, which is only for Python. Let's see that. In fact, we'll talk about other techniques as well, and then we'll move towards the Python way or Pythonic way. Okay, but before we do that, let's take two variables here. We got a equal to 5 and b equal to 6. So we got these two variables, simple variables, no fancy stuff. And now I want to also print this. Let's print this first and then we'll see. So here I'm saying a colon, comma a, and print b colon and b. Okay, so we got these two variables assigned and also printing it. So let's run this and you can see whatever value you're assigning, you are just printing it. Now what exactly swapping means? Swapping simply means the value of a and the value of b need to be swapped. So a should get 6 and b should get 5. Now why this is useful? When you build application and when you want to process data, sometimes swapping is important. And also when you want to sort. So there are different sorting algorithms available in which those thing works when you swap variables or swap values. So let's see how do we swap. Normally if you want to think, as a human, what we do is we say, okay, let a get the value of b and let b get the value of a, and this should solve the problem, right? But let's see, let's try. So I will just clear this and run, and you can see, okay, something went wrong. Both are 6. Why? So if you go step by step, what is happening is in these two lines, we are assigning value, no problem with that. Here, we are saying a is equal to b. That means the value of b, which is 6, goes into a. That means the new value for A is 6. Okay. And then in the value in B, we are assigning the value of A, and the new value of A is 6. So both are getting 6. We are losing 5 here. So this is not the ideal way in programming. So that means we have to make sure that we don't lose the value of 5. And the way you can do that is keep the value 5 somewhere. That should solve the problem, right? So let's take C and let's keep the value 5 there, which is in A now. So the value 5 goes into C, then the value 6 goes into A, and now I want the value 5 to go to B. In that case, I will not say B equal to A, I will say B equal to C. Okay, now we are able to swap. I will show you the output so that you will trust me, and you can see they have been swapped. Things are working fine, but the problem is we are using extra variable. See, every bit is important. So when you use these two variables, they are taking some space, right? Let's say X amount of space. When you have two variables, you are taking 2x of space. And just to swap, we are using the third variable. That means 3x of the space. We are wasting that extra space there. How do we solve that? So let's avoid using the third variable. I will cut that and put it somewhere so that we can refer it later if you want. Okay, let's go back here. Now I'll use the second way. Second way is basically to use mathematical formula. So we have A plus B. I will just write it first and then we'll explain what I've done. So this is a mathematical way of solving this problem. What we are trying to do here is we want to swap, right? So when you say A equal to A plus B, what we are doing is the value of A is 5, the value of B is 6. So the addition is 11, okay? And then the new value of A is 11. Then with the new value of A, which is 11, minus B, which is 6, 11 minus 6 is 5, the value of B becomes 5. Then the value of A, which is 11, the new value of B is 5. 11 minus 5 is 6. The value of A, which you get, is 6. So 5 and 6, that's what you got. And that's how basically you swap it. So I will just try to run this. Swapped. Okay, now what's the benefit of this? The benefit is you are not wasting extra memory for the third variable. Okay, you are saving memory. But for saving memory, we are increasing the number of operations which you are doing. Now this is where you do the trade-off, which is more important or which is less you have. So if you have less memory and better CPU power, you will go for this way. If you have more memory and less CPU power, you will go for the third variable. So none of this is a best approach. It's dependent upon your requirement. Okay, so this is another way of mathematical way. But even this has some shortcomings. You know what? The 5 and 6, they are small numbers, right? And this will take less memory. So let's say if this takes X amount of bits. When you add them, it will increase that bit size a bit because 5 and 6, when you add, it is 11. So 11 will take more space than 5 and 6. So we have one more way, which is XOR. It normally works with the bitwise operator, and it works in the bit way. So you're not losing any extra bit also. Okay, so every bit is important, as I mentioned before. So this is 6 and 5. So everything is done. Now, whatever we have discussed, this is actually the other language way of doing. In Python, we have a very easy way, okay, which is A comma B is equal to B comma A. As simple as that. And when I learned my first language for the first time, it was C, then C++, then Java. And every time I was working with swapping variables, I was like, hey, why can't we just write that in one line? I learned Python a bit late. And when I saw this, I was like, this is what I was waiting for. Okay, and now if you say it is swapped. But the question arises how it is working. Is it not overwriting the values? Example, in the earlier case, we were overwriting the value, right? And that's why we were losing the value of A, which was 5. In this case, when you assign the value of B to A, don't you think we are losing value? So what is happening is behind the scene, there's something called tuple packing and tuple unpacking happening. So here, when you write this, it is doing tuple packing. So it will fetch the values of B and A, which is 6 and 5. Once you fetch the value, it will pack it as in a tuple. And then that tuple goes on this side, it will do the unpacking of the tuple and assign the value, which is 6 and 5. Okay, so it's not overriding it in one go. So it is step-by-step process, and that's why this swapping is happening here. So that's how you swap two variables in Python. Now let's see, how do you get input from the user, because till this point we were hard coding all the values. Even to swap two values, we have hard coded these values. If you want to take a name and whatever operation we did with list, tuple, everywhere we were using the hard coded values. But your application will not be used by you, it will be used by your users, and they need to enter the values. How will they do it? And how will you ask for it? And that's where we have to know how to take input from the user. So it's quite simple. Instead of taking the input or assigning the value there, let's take the input. How do we do it? To print something, we were using a print function. And to take the input from the user, there should be a function. And logically, the function name should be input. And yes, the function name is input. So we'll say input, not input, input. Okay, that's a bit confusing. So we got input, and so this first one will take the input for A, the second one will get the input for B. Things should work out. So now let's try waiting for the input. 6 and 4 swapped. That's how you take the input, right? So simple. And that's how you end the video. It's only been 1 minute. See, the thing is, the video should not be that small. When you ran this for the first time, let's go back here and run this. As a developer, you know that you have written input there and it is waiting there to input. But think about it from a user perspective. For the user, it's a glitch. It's a bug in your application. It got stuck. It's not doing anything. It is not printing anything. Nothing is happening there. So you have to let your user knows, hey, we are waiting for your input. And the way you can do that is by passing function as a parameter. So you have to say, enter the first number. And you have to give some space here so that when it prints on the screen, there should be some space for you to enter. And then here we'll say enter second number. As simple as that. And then we give a space. Now, if you break it and run it again, let's run this. And you can see now it prints something. So now as a user, I know, okay, it says enter the first num. I will say 5, enter second num. Okay, I will enter 6, swapping done, right? That's how basically you can use the input function. Cool, right? Now, let's say instead of swapping them, I want to add them. That will make much more sense. So let me remove this and let's add. So I will say C is equal to A plus B. And then at the end, I will also print C here. Let's see what happens. Let's clear this and enter. Okay, asking for the first number. Let's say 5 and 7. Okay, something went wrong. I was expecting 12, but we got 57. Why? We are asking for the input from the user. User is inputting 5 and 7. We are even adding them. Nothing looks wrong here. See, the thing is, when you look at the input as a function, it's an inbuilt function, right? And this is how it is defined. All these are inbuilt functions. Input is a function which takes something from you and it returns the string. And that's what is happening here. Whatever your input is giving you, it's of type string. And when you add it to string, it gets concatenated. Now we want to add them. And this is where what you have to do is before you add them, you have to convert them into integers. So what you can do is you can say int a. So you can take the value of a and convert it into int, assign to a. Same thing you can do for b. And now this will basically convert that into numbers. And now when you run this, let's say 5 and 7, you got 12. Okay, so important thing to remember is you basically have to convert that into numbers if you want numbers. By default, it will give you string. Okay, that's for this particular thing. Let's say you're not asking for a string, a number. Let me remove all this thing here. Let's say you're asking for a character. So enter a character. And when you do this, when you take into a variable a and when you try to print a here, let's see what happens. Let's say a character u. It works. Let's take YOU. It gives you YOU. What you wanted is only Y, right? Now the thing is, input by default give you string. Doesn't matter what you enter, it will give you that. So in case if you just want to print the first character, you can do that, right? Slicing we have done in the earlier videos of the course. If you run this and if you say YOU, it will just print Y. But it is taking everything and it is storing everything in A. So even if you enter a huge string, enter, it prints A, but don't you think you're wasting so much of memory that you're storing in A? What if you only take the first character? So you can write that here as well. So it doesn't matter how much you take from the user. Let's say this much, enter, you will only get L, one character. Okay, so yeah, some tweaks to show you what you can do with the input function. But now you know how to take the input from the user. It's time to go for the next step. See, when you work with programming, it's not just about calculations. We have done that till now, right? Adding the numbers, subtracting them, or maybe you also are working with the data. So maybe you're trying to save it, you're fetching some particular element from the data. We can do those things. But what makes a software very powerful is the power of thinking. That's right. Okay, we are not talking about AI at this point. We're just saying a software should be able to think when to do what based on some conditions. Should we go this way? Should we go that way? And that can be done with the help of something called if. In fact, there is a list here. We can talk about if else, and there's also something called else if, which we are going to see in the upcoming videos. So let's get started. So the first thing I'm going to do is I'm going to create a file, and we'll name this as ifdemo.py. Again, a simple file name. And in this, let's try to demonstrate what is if. So we can call it as a if statement, and it's just that my Copilot is unable and it is giving you suggestions. Okay, just because the file name, AI is getting smarter day by day. So I just want to snooze it for maybe few hours because I'm going to record videos now. I don't want your suggestions, Copilot, for some time. Okay, so let's see the use case for if. See, when you want to execute certain statements based on some conditions, maybe you want to execute this bunch of statements or you want to execute that bunch of statement, that can be done with the help of if. Now, how do we use it? So first of all, let's take a number variable with the value 6. Again, the value, imagine this value is coming from the user. And now once you got this value, I want to check if the given number is even or odd, because what is the best example for if to start with? It's always even or odd. So what I'm going to do is I'm going to print here, which is even, and let's also print odd. So we are printing even, we are printing odd. But if you execute this particular statement or this particular file here, which is ifdemo.py, you can see it is printing both. It is printing even, it is printing odd, and that's odd, right? Okay, ignore my poor jokes. But the point is, I want to execute either even or I want to execute odd. I don't want both at the same time based on this value. So now we know we are smart. We know 6 is an even number. It should print even. How do we do that? So we have to explain to the program, hey, what do you mean by even odd? It's very simple. If, okay, now this is how you use the syntax. You basically specify if and then you specify true or false, because if ultimately look for true and false. So if you say true here, that's how the syntax is. If and then true or false, and then you give a colon, and then here you put print inside it. Now this is called a suite. So this is a block. Normally in programming languages, other languages like C, C++, Java, C#, name the language, you normally use curly brackets, but Python says, hey, we don't do that here. We basically use tab here, and which makes sense. Why to waste extra curly brackets on the screen, which makes programming a bit difficult. See, if you are coming from other languages like C or C++, you are getting used to it. So you know what the curly brackets are, and when you look at the code, you don't get scared by it. But imagine if someone is looking at the C code or C++ code for the first time, they skip their heartbeats for a second, okay? Or they just ignore the file. Here, Python wanted to make it simple, so here we got. So it's if as a block, which we call a suite, and we do that with the help of the if keyword. Then we specify true or false, then give a colon, and then whatever statements you want to put inside if, you do that with the help of this particular space here. Okay, example, let's say if I just comment this odd part for time being, and let's say if I want to print, okay, caps lock is on. If I want to print, let's say by, now if you observe, I'm putting this print even inside the if suite, or I can say a block. But if I'm keeping this by outside, now how do I know it's outside? There's no opening and ending. It's just that the spaces. For this particular thing, I'm using 4 spaces. So it will check, okay, this is 4 spaces. That means whatever statements after this are going to be part of if they have 4 spaces. Example here, doesn't matter how many tabs, how many spaces you have between two statements, if you have that 4 spaces here or 1 tab, it will be treating that as a part of if. Okay, so I want to show you that by running it. So I will run it. You can see it's printing even and by both. Why both is because if true, when you say it is true, it will simply check it is true. Okay, that means I just have to execute this. So this block or this suite will be executed when it says true. So that means yes, it is going to print even. Also by is because it is part of it. Okay, but then even if you keep it outside, it will still going to print. You know why? It's because this is true. So of course it is going to print even, and print by is the outside part. So it is going to execute anyway. I know you don't trust me. What I'm going to do is I'm going to make this false. Okay. Now when you make this false, the execution will come here by saying, okay, it is if and there's a false. That means I'm not going to execute this block. It will come out. It is going to print by. And whatever I said before this is correct. It will only print by. It is by. So yes, I'm correct. You know how I know I'm correct? Because I've done the same code before making this video. So I know it works. And if you are using certain IDEs, the IDEs which supports all these things, if you observe the color of this print is different from this print. You know why? It's not because it is part of if. It's because it is part of a if block, which always check false. If you make it true, then it will show its true color. I mean, it shows its actual color. Pun intended. Yeah, that was. Anyway, so if you run this, it will print even and by. Now you got to know why this particular spaces or tab is important. So I'm going to remove this, or maybe I can just keep it here. I'll just cut this part and keep it somewhere down because I want to say by at the end. It's a good gesture. Okay, but then this is true and false, and it doesn't make sense, right? Why you will put a certain statement which is always going to execute? When you say true, it is always going to execute. So true is not something you want to put here. You want to put a condition which will result in true or false. So I can say num. Okay, how do you check if it's a number even or odd? Now, if you go back to previous videos, we have talked about different operators. One of the operator is this mod operator or the percentage symbol. And you can say num mod 2 or num mod 2, which is num divided by 2, but it will not give you the quotient. It will give you a remainder, and we just have to compare that with 0. Simple stuff, right? If this is 0, it is going to print even. As simple as that. Okay, let's try this. Let's go back, run, and it says even. Okay, it still says even. But how do I print odd? Now that's odd. Okay, so what if I put this odd? If I remove this comment here, it is going to print odd anyhow. But I want to print odd only when it's odd. So what we can do is we can put if, and you can say num mod 2 equal to 1. So we are checking for even, we are checking for odd, and let's see if that works. Okay, and we have to make sure that you give those spaces. Again, it's not compulsory to use 1 tab or 4 spaces. You can also give 1 spaces. That works. But you know, when you build projects, it will be used by others, your teammates. Maybe you're making it open source. The world is going to say it, and you don't want them to be uncomfortable looking at 1 space there. So let's make this as a standard. Let's go for tab. Okay. Or if you love your spacebar, or if you hate your spacebar, you can hit your spacebar 4 times. Whatever works for you. And now if you try to run this, it says even. But if I change this number to 5, it should print odd. Otherwise, I'm going to close this video. Yeah, it says odd, and I'm not going to close this video. Eventually, I have to. So basically, what we're doing here is it is checking if this number is, number 2 is 0, then it is printing even. So if block or the suite will execute only when the condition is true. Otherwise, it will not execute. Cool. So that's how you do even odd. This is not the best way to check if the number is even odd, but yeah, it works. Now we know how to use if. But when I said it is not the best way, what's the other way? So what's the best way to find or to check if a number is even or odd? So basically what we're doing here is we are checking if the number is this statement here or this condition is here is true. If it is true, it will execute even, right? And then we are checking if this statement is true. If it is true, it will print odd. Now, what's wrong with this code, or not? Why it is not efficient is, what if you are passing number 6? okay, and then you are checking for this, and we know it will be true, so it will print even. Now when we know it's even, then why it has to even check for this particular block here? Don't you think it is assumed that if a number is even, it's not going to be odd? We are not into a quantum mechanics where you'll be having multiple states at the same time. So here it has to be one. Either it should be even or odd. How do we do that? And that's what you can do. Either it can be even or it can be odd. So odd. Okay, so something we have to use there, odd. So we can say if this is true, then you execute this, else execute this. English, else. So instead of this, I can simply use else, and that works. So as you can see, we are saying if this block, checking condition, if it is true, it will print, else it will print this. Let's try it out and let's see if it's really working. Run this, it says even. And now if I say 7, not 78, that's a big number to check. And you can see it says odd. But now I'll be saying, hey, how do we trust you? How do we know that if this is getting executed, this is not going to execute odd, or it will not even go to else? Now, to see the proof, we need to understand how debugging works. Okay, now first of all, what is debugging? Now see, when you talk about applications, now in your application, when you write a code, of course it should behave the way you want it. But sometimes when you write a code, you make a mistake, not the syntactical errors. Example, if you miss this particular colon here, now this is a syntactical error. Your compiler or your IDE will say, what you're doing. Okay, so you can see all this red bar here. There's a red line here as well, which shows where the error is. And also the red, so everywhere you can see red, 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 and even if you try to run this, it will give you some bad words. Okay, so it says what else? I think you missed this particular colon there. So this is syntax error, and this is easier to solve. But when you have logical error, where you have written some wrong statement somewhere, and because of that, it is not giving you the expected output. Example, by mistake, if you say 1 here, the code will work. There's no compile time errors. It will give you error while you're running it. Okay, when I say error, it means it will give you some wrong output. If you know it is wrong output, you can actually see, hey, why it is wrong. But most of the time, you don't even know if the output which you're getting is wrong. And that's tricky. So, and that's why we normally do testing and all those stuff to see whatever, based on some inputs, how you're getting the outputs. But here, let's say if you want to debug. So these things, the logical errors are normally called bugs. And when you have bugs, you basically have to remove them. Find them, remove them. And the process of doing this, we call it as debugging, removing bugs. And as straightforward, right? And based on this, I have this very poor joke, but also it makes a lot of sense. If debugging is removing bugs, then what is coding? It's adding bugs. Every time you write a statement, it can be a potential bug, right? Example, this statement, I don't think there's a bug here, but this can be a bug. Or maybe if you're writing very complex software, every line can be a potential bug. How do we solve it? First, debug the application. Second, do testing, like unit testing, automation testing. You can do those things. But here we are only talking about debugging, so let's stick to it. So what's the process of doing this? Now, in most of the IDEs, if you look at the play button here, and if you drop down this, you will see an option of running a file, which is straightforward. When you click this, it will run the file. But also, you will find something called a debugger. Now, it's very straightforward when it comes to PyCharm, because PyCharm is built for Python. But VS Code, on the other hand, is built for multiple languages. You can use C, C++, Java, C#, Python, JavaScript. You can do everything here. And it gives you that flexibility that you can run any file. If you want to debug based on some conditions, you can do those things. So it is straightforward button here in PyCharm, but here it says, okay, you have to debug. It might give you a prompt to select which type of thing you want. In fact, if I don't do these things from here, there's also an option here, run debug. You can click on run debug. It will give you this prompt where you can select, okay, I want to go for Python debugger. In case if you're not seeing this option, so maybe you don't have the Python extensions. How do I verify that? Click on these extensions and search for Python. Scroll down and make sure that you have Python from Microsoft as an extension. If you don't have it, search for it, install it, simple stuff. Again, when you install it, you have to restart your IDE to get the effect. Okay, so let's debug this. Now, I clicked on it, debugging, and nothing happened. Something happened here, it is printing the output. But how do I do this? So what you can do is, if you can see, there is, when you go here, it shows you this red bubble or red color, red circle. This is called a breakpoint. In debugging, you can mention, okay, execute all the statements and stop where you want to check. So you can add a breakpoint here because this is where I want to check. Then you can go back here and click on Python debugger. And then you can see it ran till here. Maybe it doesn't matter how many statements you have before that, before this if, it will execute all and it will stop here because this is where you're adding a breakpoint. And then from here, you can run step by step. And this is called step over. So if you can see, there's a button here, which is step over. You can also do that from F10, but yeah, I can actually use, because see, normally when you are actually debugging the application, you don't want to touch your mouse, right? You just want to do that from the keyboard and say, okay, F10, 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 because you're focusing. But since I'm recording a video, I have this mic between my eyes and this keyboard, so I will stick to mouse. On the left-hand side, you can see we have variables here. These are all your special variables, and this is a variable which you have created. So if you have multiple variables, you will see that here. Again, when we go for loops, it will make much more sense. You will see more variables there. And this is where you can have some watch. Again, we'll see that later. Now, let me go for the next step. So I will click step over. You can see it is skipping the entire print here is because this condition is false. It is jumping to else suite, right? Now, if I make this 6, again, I have to stop it and I will go for 6 here. And let's do the debugging now. Or I can just say, okay, if you want to start a debugger, you can also click here. Otherwise, you can click F5 or function F5, whatever is there, run debugger and stopped here. Now, if I click on step over, it will print this because 6 is an even number. And then it will just jump out directly to by. You can see it is skipping this else part. If is true, then it will skip the else part. So the idea was to talk about debugging, which we are going to use this multiple times later. Oh, now I'm tired. It's time to take a small break and move to the next part. Maybe even you're also tired watching the video. Take a small break. So now let's talk about nested if. Now, what exactly nested if means? Nested means one inside the other. So if you have if here and then you are printing here, let's add some conditions or something. So let's say based on some other value, whatever variable you want to use here, let's say I'm going to say salary. Again, it's bad to compare the salaries, but let's do it. It's fun. So let's say we got a salary as 5 and we don't know what this currency is. It can be rupees, dollars, or bitcoins. If the salary is 5, I want to print great job. If the salary is less than 5, I mean greater than 5, great job. Less than 5, better luck next time. Something like that. But only if it's an even number. Okay, so of course I can do that outside if I just want to print great job or better luck next time. But I want to do that only when the number is even. So that means I have to do that inside this if. So we can do this. We can write if inside if, something like this. And I can say if salary is more than 5, I can simply print here, great job. Else I can print better luck next time. Okay. Now what we are trying to do here is we are saying if inside or if else inside the if block. This is called nested if. Nothing fancy, simple stuff. Just wanted to show you how it works, and let's run this. And you can see it says better luck next time because the value is not more than 5. But if I say 7, and if I try this now, it says even and great job. But now if I make this as an odd number, it doesn't matter what the salary is now, it's not going to execute them. It will only print odd because the entire block is skipped as soon as it says this condition is false. So that's how we can use nested if. Now it's time to talk about else if. So that's right, we have talked about if else and now it's time to go for else if. That's reverse of it. Now why do we need it? So what I'm going to do is I'm going to create a new file here and let's name it as elif Now this is a simple file. Now what I'm going to do here is let's take an example to understand this. Let's say we have a number which is 1 and this number can be anything. I want to print the word format of it or name format of this. So if I say 1, it should print ONE. If I say 2, it should print TWO. And of course, this should not be done with the help of AI. We want to manually print those values. Now we will do from 1 to 5 so that will not waste a lot of time for all different numbers. So here, how do we do it? I want to print, so of course here there should be a print statement which will print 1, and then likewise we need 4 more. So we got 5 here, and this should be 2, this should be 3, this should be 4 and 5. Okay, so we got these 5 values. Now based on what number you enter here, it should print one of them. But here, if you directly try to do this, and if I try to run this file, which is elif demo, okay, elif underscore demo.py, you will see it will print everything. We don't want to print everything. We just want to print one thing, which is this. So based on 1, it should print 1. And if I say, let's say 3, it should print only 3. Now the way you can do that, and we have done that before, what you can do is you can use if. So you can check if num is equal to 1. In that scenario, you can give a colon here, and then you can give that in a tab. So it will only print 1. Right, and we can do it for others as well. So this will be if the number is 2, then you will print 2, right? And I think I should do it for everything now without wasting your time. And the last one, I'm already feeling tired now, so if I say 5, it should print 5. Okay, now this will work because we know how if works. So it will check if the number is 1, then it will print 1. If the number is 2, it will print 2. If the number is 3, it will print 3, and then so on. Or if I run this, it will print 3. And whatever number you have, if you type 5, it is going to print 5. Now, of course, if there's a number which is, let's say, 6, now we don't have any number for this or name format for this, it will print nothing. But maybe I want to print something here. So in this case, I can say else, or maybe I can say if the number is more than 5 or any number apart from 5, I can print incorrect. Okay, so even if you say 6 now, it will print incorrect. But then this will not work for negative numbers, right? So negative numbers, it will print nothing because negative numbers are not even matching with this, and even this is not a good idea. But we'll see that later. How do we solve it? But this is how you do it. And we know that from debugging, it will check each condition. So even if I apply a debugger here, the moment you run this, it will check for each value. So even if you type 2, which is matching here, it will still go all over the if. So it will check this, it will check this, it will check this, it will check this as well. Now we don't want that. Now in that scenario, we can use else, but then we can only use else once, right? So if you remember, if we have used if here, and then you can use else only once. So what if I want to use else for this first if everywhere? If this if is true, then we don't have to execute all the other conditions. In that scenario, you can use something called else if. Now, in C, we use else if. In Java, we use else if. In C#, I think we use else if. In Python, we use elif. It's saving some characters. That's it. So we can use elif here. And I will talk about what elif is once I change all the ifs to elifs. Not the first one, but others. First need to be if. You can't directly use elif at the start because else makes sense when you have if, right? So what we have here is we got if, then for this if, we got multiple else if or elifs. The last one can be else is because if none of them is matching, we can simply say else. So we can have this syntax. We can have if, else if, and else, and in between we can have multiple else if. It's just that if can be only one, else can be only one, elif can be any number of times in between. Now how exactly this is working, again we can check that from debugger. So I will just click here, and sometime my VS Code is giving issues with the debugger. I hope this time it will work, otherwise I have to do the dry run. And okay, there's no problem, we can do it now. So it will first check if this is matching. No, it will jump to the next part. Is this matching? Yes, it will go to, it will print 2, and once it is completing its job, it will directly come out of the if block, and you can see it is just came out. But let's say if the number is 6, now in this case it will jump all over. So Python debugger, okay, I'll just launch from here. So now if I say next, it will check not matching, check not matching. So it will check all the else if, not matching, and then it will jump to else. Okay, so that's how else if or elif works. Now, of course, you can have nested stuff here. Maybe you can check if so let's say if I have one more variable here, which is salary, and salary is, let's say, 5, and this can be a Bitcoin, as I mentioned. So this can be Bitcoin, dollars, doesn't matter. So if the salary is less than 5, or maybe the salary is greater than or equal to 5, in that scenario, I want to print 3. Otherwise, when you get less salary, you can mess up the stuff. You can print 3, whatever you want. So we have not done that before, right? Okay, we have done that salary here. Okay, cool. So we can do the same thing here. So we can print 3, or we can print 3 if your salary is less than 5. So you can have nested if else here as well. So you get flexibility, whatever you want to do. So yeah, that's how you basically work with else if. We'll talk about match. Now, if you go back to 1960s, a lot of languages came into picture. We got B, we got C language. And then based on those languages, we got new languages. We got C++ in 1983. But when Python was under development in 1991 or 1990s, basically, they missed one thing from other languages. And it made sense because when you look at those languages, especially with C, we got if else, we got else if, which we have talked about. But then they also have something called switch. Now, switch is a great way to do things which we have done. So if you look at the code, whatever we have done here, let me remove this part and just print 3. Now, this can be done with the help of switch case as well, which is there in the other languages. So instead of using if else, we can use switch. Now, this is how it looks like in C language if you use switch for the same thing. But there's one problem. Everywhere if you see there's a break. And that was a concern. And in Java also, they carried the same thing. But later on, they removed it. Now, we don't need to use break in switch in Java. But C still exists. Now, Python says, okay, there's a problem. Why do we use a break here? And maybe, I'm not sure why they left it, but switch was not a part of Python language. And it's a part of major languages. And this changed in one of the versions, which is 3.10. And now we can use switch, but with a different name. And the name is match. Okay, let's use that. So I will just copy the same stuff because we are going to use this. And let's create a new file called matchdemo.py, and here I'm going to type it. Of course, we need a num variable as well, so we got num is equal to 3, and I want to do the same thing but with the help of match. Now, how do we do it? It's quite simple actually. So instead of this syntax, what we do is we say match and we use a variable which is num. Now the syntax is match. Okay, that's what you have to use, and then the variable. Now, inside this, instead of specifying the condition, we don't have to manually check if the numbers are matching. You can use a case here. So if the case is 1, I will just give a tab because now this case is a part of the match. So you will say match num. Then you compare with the first case. If the case is 1, it will print 1. Then if the case is 2, then it will print 2. Then if the case is 3, it will print 3. And likewise, I will just change everything else here. So this is case 5. Okay, now we don't have else case. So instead of this, we need to use something else. So you have to say case underscore. Now this defines the else part. Okay, and we can say this is incorrect. Now, if you look at this syntax, which is better than what we have done here, because in this, we are checking for the values manually. And here, because see, ultimately, if you just want to match the value, we can use something like this. And this looks much better. And if I remove the extra spaces in between, it will be less lines of code, if that makes sense. So we can use something called match. So instead of using else if, we can use match, which looks better. Now, this is good for matching, but if you want to check for conditions and stuff, we can still use if else. So yeah, that's match for you, but then we're not running this yet. So I will just say Python match underscore demo.py. And if I clear this, let's run this once again. So you can see we got 3, but if I say value is 6 and we don't have 6, so it should print incorrect. So things are working out. Okay, and this is the better syntax compared to what you have in C, as you can see on the screen. So yeah, that's how you use match Now it's time to move towards loops. Now see, whenever you want to repeat certain things, you can do that with the help of loop. Yes, you can do that using functions. You can define a function, you can call the function more time. But let's say if you have a code ready and then a particular code need to run multiple times, maybe for iteration, maybe if you want to run it for 10 times or 20 times, or maybe you have a collection of values and you want to iterate between the values. Maybe you got a file and you want to read the characters of the file one by one. Or maybe you are downloading something from the internet bit by bit. How will you do those things? And this is where you have to repeat the statements. And you can do that with the help of loops. We got multiple options in other languages as well. So the common one are while, do while, and for. In Python, while works, do while will check, and for loop works. Okay, so let's start with the while loop. So I'm going to close all the other windows because we have talked about this stuff. And now it's time to create a new file. And I'm going to say this is while demo.py. And in this, let's start coding. So what we're trying to do here is, let's say we have a statement, and this can be multiple statement, not just one. And I forgot to do one thing. I need to keep my Copilot on snooze for some time. And here, let's try to print, let's say, hello world. Now, if you want to print this multiple times, how will you do it? It's very simple. You can write this statement. I can just copy and paste it here. And I can do that 2 times. Let's say if I want to do 10 times, then I have to type the same statement 10 times. What if I want to do that 1 billion times? I can do it. I am that strong and that consistent. But, you know, it will take a lot of years to do that. But I don't want to waste my years doing that. So what I will do is, instead of typing it, I will just ask Python, hey, can you repeat this thing multiple times? Python will say, okay, I will do it. So tell me till when you want to do it. So you can say while it is true, because while is a keyword, which is a loop basically, which checks for the condition. And whenever it sees the condition is true, it will execute the block. Okay, here we just have one statement. You can have multiple statements. It will execute all the statement inside the while loop. And now if you want to check if this is working or not, I will just say Python while underscore demo.py. And if I say enter, it is printing hello world multiple times and it is not stopping. Okay, it is printing continuously. I don't know if you eyes can say this. There is a blinking on the right hand side and also blinking here. It is continuously printing hello world. And if I want to show you my task manager, it's consuming a lot of power. So this amount of power for the while loop example, if I show you by stopping it, just remember 30 is the consistent one, right? Or 2730. But if I close this, look at the amount of CPU now it is consuming. Okay, so it was continuously doing it using the CPU power. And that's why there are certain bugs in the application because of which entire system, it hangs, by the way, your application, whichever you're using. And then it is basically consuming a lot of your CPU power. This is one of the problem for that. So true is not a good option. We can say false, but then it will not execute anything. So what we should do here? So what we can do is we can put a condition by saying, okay, let's say I want to do this for 5 times. And if I do it for 5 times, you need a counter. 1, 2, 3, 4, 5. And to run the counter, we need a variable. Now, you can use any variable name, but in programming, basically, when you need a counter, you go with I, J, K, all these variable names. Any variable name works, but these are famous one. So let's say I'm counting from 1. So I'll start from 1. Okay, 1 time hello world, 2 time hello world, 3 time hello world. And you can check the condition here. So you can say if I is less than equal to 5. So if the value of I is less than 5, print it. So that means somewhere we have to change the value of I. If you don't do this, let me just run this once again. It will still go in that loop. Continuously it is printing it. There's no stopping for it. So we have to mention that, hey, I have defined I is equal to 1. That's the initial value. And I'm checking for the condition as well. But somewhere we have to increment it. And that should be a part of a while loop itself inside if you do it. So every time you print hello world, you can say, okay, let me increment the value of I by 1. Now when you do this, let's run this. And yeah, you can see we got hello world 5 times. Now, before we run this step by step, because I know you want to see what's happening, how it is running. And we have seen debugging mode before. But before I do that, outside the while loop, let's say I'm going to print the value of I. Now you have to guess what is the value of I? Whenever you see the space to write this, or maybe in your mind, what is the value of I? Now, if you're thinking the value of I would be 5, because that's where we are going, right? This increment will work till 5. But if you run this, you will get 6. That's weird, right? It should be 5. And to understand this, let's do the debugging. And if you were thinking 6, good job, you're there. So let me just add a breakpoint here, and let's do this debugging here. So I will just run a Python debugger, and it is there. Now, if you can see, the value of I is 1. Here also it is 1. If I step over, it will print hello world. Look at the console, it's empty at this point. I'll just move this code a bit up so that you can see that properly. And if I run this, it will print hello world once. And now it will increment the value of I. It becomes 2. It will check if 2 is less than 5. Yes, it will go inside. It will print hello world. It will make the value of I as 3. It will go up. It will check, okay, 3 is less than 5. Yes, it will go inside. It will print hello world. It will increment the value of I to 4. 4 is less than 5. Yes, it will print hello world. It will say, okay, I plus equal to 1, increment the value of I to 5, and then I is 5 now. Is 5 less than 5? No, but we have also mentioned equal to here. So 5 is equal to 5, and it will go inside. It will print hello world. So 5 times hello world printed, and it will increment the value of I. Okay, I became 6. And then it will check, okay, 6 is less than equal to 5. No, false. This is where while loop says, okay, my job is done. I got false. I can go home now. And then it will jump out of the loop, and it will print the value of I, which is 6. That's simple. Okay, that's how basically your while loop works. Now let's try to work with nested loop. We have done that nested part in if. Can we do it here? But for that, I need a good example. Okay, so let's say I want to print this thing on the screen. I want to print Telusko. Okay, so instead of printing hello world here, it should be Telusko. And I also want to print rocks. Okay, something like this. Telusko rocks, not once. Okay, Telusko rocks I want to print multiple times. Here I'm saying 2. Let's say if I want to print 4 times, then it's easy, right? You can just write this 4 times. But what if I want to do that 10 times? Then I have to write that 10 times. What if I want to print rocks 100 times? Not a good idea, right? Not printing 100 times there. So since you want to do certain things multiple times, can you do it? So how do we do it? Now what I'm going to do is I'm going to print Telusko and rocks in a different line. So I'm going to pick up this. In fact, first of all, let's run this to see, are we even getting Telusko rocks multiple times? Yeah, we are getting this multiple times. But as I mentioned, I want to make this as dynamic. This is static at this point. It will only print 2 times. What if I want to do that 4 times, 10 times? So what I can do is I can just take this out from here, and it was a cut. And let me print it down somewhere. We'll go step by step. And let's paste it here. And now let's try to run. Let's see what happens. Okay, clear spelling is wrong. And now if I run this, okay, you can see it is printing Telusko. It is printing rocks on the new line. But I don't want rocks on the new line. What you can do is, see, by default, when you talk about print, when you click on print here to see the definition of print, and let's see what print is doing here. So if you click on print, print has something called end. Okay, so by default there's one of the parameter of print which is end, and by default the value is /n. Okay, remember this. By default value for end is /n, which means even if you don't mention that, of course you can mention that if you want, but by default it is end. And if I say here comma, so by default there's a parameter which is passing which is end, and by default it is /n, and that's why it is printing on new line. And it's here also, even if you don't mention that. It's like a Johnson, it's there, even if you don't mention. So what if I change that /n with a blank thing? The moment you do that, it will change its ending. After printing, it will stay on the same line. So after printing the Telusko, it will stay on the same line. It will not go on new line. Okay, so we have solved one problem. Next, I don't want to print rocks 2 times. I want to print rocks only once. Here, so if it will print only once, but now I want to print rocks 5 times. So I want to repeat this particular statement 5 times. So what you can do is you can write while here, while, okay, but now I can't use I have to use another variable, and now you can guess it. So we can use I, j, k, and again, you can use any variable, but normally for loops, it is easier to read also. So let's use j, and j less than equal to, now how many times I want to print? I want to print 4 times. So let's stick to 4 and give a colon, and this should be a part of it inside. Okay, so this print, which is rocks, is a part of inner while loop. this Telusko printing is a part of outer while loop. So we can say outer loop, inner loop for simplicity. And it is giving some warning here. It says j is not defined. Okay, no problem. I will just define it here. So I will say j is equal to 1, problem solved. And now let's try if this works. I will just run this and something went wrong. Something went wrong. It is not stopping. You know why it's not stopping? It's because we are checking the condition for I and then we are also incrementing it, right? So somewhere it will increment, it will change the value of I. For j, nowhere we are changing the value. So we missed that. So we'll say j plus equal to 1. Now it is incrementing. So it should not give the issue which it was giving before. It worked, but not in a way we wanted. So what went wrong here? For this Telusko, it is printing rocks and then this rocks on new line. Okay, new line, that's the issue, is it? Let's solve it. So I will say blank. Just to maintain the uniformity, I will just give a space here. No compulsion, but looks good. And now if you run this, okay, so things are working. You can see it says Telusko, rocks, 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 and then Telusko, Telusko, Telusko. You know, after every Telusko, like this, it should be on the new line. Okay, we'll solve that. So how do we do it? So before you go for printing the next Telusko here, after this, I will just print a blank thing so that it will come on the new line, right? So before you print the next Telusko, right, I want to come on the new line. That's what I wanted here. Let's run this. Okay, this problem is solved. So we got Telusko on new lines. That's one thing we wanted to do. And we wanted to print that 5 times. 1, 2, 3, 4, 5. This is perfect. Rocks 4 times, but it is only doing for one Telusko, what they have done wrong. Now let's understand what is happening here by debugging. So I will just add a debugger here and let's do the debugging. Okay, let's go step by step. The value of I is 1, j is 1. Perfect. Let's go to the next one. It's going to print Telusko and it's done here. In fact, let me scroll up a bit so that I can pull that there. I should have cleared the things before doing it. But anyway, you can check that. So it is printing the Telusko. Perfect. And if I go to here, it is checking the j value is 1. And then it is checking 1 is less than 4. Yes. It's going to print rocks. And you can see that on the screen on the same line because we are not saying next line. Then it will go next. It will iterate to the same loop because first it will complete the inner loop. Then it will go for the outer loop. So it will check if j is 2. Yes. 2 is less than 4. Yes. It will print rock and rocks that came. J value become 3, true, print rocks, j value become 4, still true, rocks, and j value became 5 now, and it will say false. It is not going to print rocks. It will come out of the inner while loop, which is this one, and now it will jump outside and it will increment the value of I, which was 1. Now the I will become 2. Because of course you have to print Telusko as well, right? That's the outer loop part. Then it will come on new line because we want, before you go for the Telusko printing, you have to come on new line. And you can see that cursor went down. And now the value of I is 2. It will print the Telusko. It will go on the while loop, the inner while loop. But that's the problem. The value of j is 5. It will not go inside the inner loop. And that's why it's not printing rocks, rocks, rocks. It will simply keep printing the Telusko because the j value is 5. So this declaration which we did outside for j, it should be inside the while loop. So that every time you print Telusko, you get a new value for j. Okay. And this should work now. Let me just stop this and run it normally, but not from here. I'll switch to my PowerShell, clear this, and let's run this. And you can say it is working. Where to assign the value, where to increment, that is important. So remember, this is the inner loop, and this is a declaration for that. This is a loop, and this is a declaration for that. That's how basically your while loop works. Now, if you're thinking, okay, why we are resetting the value of j again, we have talked about it. But in case if you're confused, let's take an example of days and hours. So every hour you change your timing, right? So if this is, let's say 5 p.m., then it becomes 6 p.m., 7 p.m., 8 p.m. But if you start from the morning for a particular day, so let's say today is date 1st, and then you're starting from 0th hour, then 1 hour, 2 hour, day is not changing, day is still 1. And then once you complete the entire cycle of hours, once it reaches to 23rd hour, and then it goes to the 0th hour again, the day changes. But the time will reset. Again, it will start from 0. Next day, again, it will start from 0. That's what is happening here. So every time your hours complete the cycle, the day changes and hour get reset. If that makes sense. So that's how you basically use the nested while loop. See you in the next part. It's time to move towards another loop. Now, if you remember, we have talked about 3 loops in programming. In fact, there are 4, and maybe there are many in other languages, but the languages which I have explored, we got while loop, do while loop, for loop, and until loop. Now, in Python, just to keep it very simple, they went for 2 loops. One is while loop and one is for loop. We have talked about while loop. It's time to focus on the for loop. Now, why we don't have other loops is because if we talk about until loop, I think it's only in shell, not in other languages which I remember. Might be, not sure. But if you talk about do while loop, it's very similar to while loop, right? So in while loop, basically you check the condition before, then you execute the block. In do while loop, you check for the condition later. Now, both does almost the same thing with one change, and you can simulate the thing which you can do in do while loop using while loop. So Python said, let's keep it simple. Let's stick to 2. One is while and one is for. And we know now how while works. Let's see what advantage you get using for loop. So I'm going to create a new file. I don't know why I clicked on extensions. Happens. I will just make sure I name it as for demo.py. And also, since I'm doing this after some time, I need to snooze this Copilot. Okay, now how do we use for loop and what's the advantage? And to do that, first of all, let's use a while loop to do certain things, and then let's try that with for loop. What I'm going to do is I'm going to create a list here, and let's name this list as data. And in this list, I'm going to have some values. Let's say 2. Let's say my name Naveen, and let's say we got 4.5, some random values. I'm not sure why I'm going for this random values, but doesn't matter, right? Things should work out. That's important. So Python, so Telusko and Python. So we got these values. Now I want to print these values. Of course, you can simply print them with the help of just data, and this should work out, right? So if I try to say run this Python for demo.py, and this is working. But what if you want to print these values one by one? And we have done that before. You can use the index number. So you can say data of 0. And then in the next line, you can say data of 1. So it will print the values one by one. Here, we are just printing first value. That's why you got only one value. But what if I want to print all, but I don't want to print this multiple times? I don't want to write print statement multiple times. And we know if you want to do the same thing multiple times, you can use loops. I'm going to use a while loop here. So let's stay while, and we need a counter because we have to start from the first position to the last position. So how many values we have? 1, 2, 3, 4, 5, 6. So I have to start with the first value. Now, I'll be using a counter which is I, but it should start with 0 because the indexing starts at 0. And then I have to end at 5 is because 0, 1, 2, 3, 4, 5, right? So even if you got 6 values, you have to stop at 5. So I can say I less than equal to 5, okay, and then I'll just put that in this, and let's make this I. One more thing, we need to also make sure that you increment the value of I, otherwise it will just go into infinite loop, printing the first value repeatedly, and you can try it out on your machine. I don't want to give that pressure to my CPU again to run infinite loop. I care about my machine. So let's run this, and you can see it will print everything, okay, as simple as that. So this is how loops can help you. Okay, we can do one more change here. Instead of having 5 is because what if your size of this list is 100, or maybe you don't even know the length of it. It is getting passed by the user or getting filed from the internet, or maybe it's coming from the database. You don't know. So in that scenario, what you can do is you can say n is equal to, once you got the data, just find the length of it. Let's make it dynamic and let's say n. So nowhere we are specifying the size of it. So in case if it is increasing in future, it will just adjust to it. And now let's run this. You will get the same output, but we got an error here. So what is the issue? It says it is going index out of bound. Oh, okay. You know what happened? The length is 6, right? And we should have stopped it before n. So if it is the length is 6, we have to stop at 5. That was the issue. Let's run this and solve. This is how you can do it with while loop. Now, what if you want to do the same thing with for loop? Let's see how do we do it. First of all, what's the drawback of while loop? See, we are initializing the value. We are finding the length here. Then we are incrementing it here. In fact, we are also checking for the condition here. So many things, right? So if I comment this part and let's try with for loop here. So we can use for, that's how you do it, syntax. Now, for says, okay, my job here is to work with the collections or range or like list. So it will try to go to that particular collection and say, okay, you got 10 values here or any number of values. I will give you the values one by one, and you as a developer can do whatever you want with that value. So I will say for value, again, you can name this variable anything. This is just a variable name. And for value in data, that's the syntax which you have to use. The variable which will hold one value at a time, and the data is your collection or your list or your range or whatever you have. And then you can print it on whatever you want to do. I'm just going to print the value, okay? And that's it. Look at the number of lines here, just 2 lines. And this is, you can count it, more than 5. So let's run this and it works, okay? Now this is where for loop says, I'm there, don't worry. But then this will work only when you have a list of values or a collection or a range. While loop says, if whenever you want to do with certain values, maybe you want to get it from a file, you want to read characters one by one, while loop works here, because we have to also specify condition. There's no way you can pass a condition here. Of course, you can do that inside the for loop, but not in this line, okay? That's how you use for loop, and let's see how it is working. So I'm going to debug this to see how it is fetching the value, how it is printing one by one. So let's do the debugging here, and let's hop over. So it is picking the first value, which is 2, and that's the value you got, and that's what it is printing on the console. Then it goes for the next value of the data, which is Naveen, and you can see value is Naveen now. And then one by one, it will just jump to the next value, 4.5, then 8, then Telusko, then Python, and it will give you those values. Beautiful, right? One more thing you can do here is, instead of having a data like this, what if you want to print 10 values from 0 to 9? In that case, you can use something called range. We have talked about range before. So we can use range here. Now what range will give you the values from 0 to 9, and then value will have one value at a time from the range. 0, 1, 2, 3. Let me remove the breakpoint. Let me stick to the PowerShell, and let's run it from here. And you can see we got all the values from 0 to 9. So yeah, that's how you use for loop in Python. Now let's talk about break and continue. Okay, now that sounds weird, but let's try that. So let's say if I want to print this, and we are doing it, right? So when you want to say you have a range here, and I'm printing one by one value here. Let's say you want to skip certain elements. So of course, when this for loop runs, it is going to print everything. I don't want to print, okay, let me see the output first. I don't want to print the values divided by 3. So like 0, 3, 6, and 9. I want to skip them. There are 2 ways of doing it. One, you can check for the value. If the value mod 3, if it is not equal to 0, in that case, I want to print the values. That means it will only print the values which are not divisible by 3. And if I run this, you can see it is skipping all the values which is divisible by 3. 0 gone, 3 gone, 6 gone, 9 gone. Now, this is one way. But what we are doing is we are printing this. So we have this statement which might be very important to you in the if block. Okay, this is one way. The another way is, what if you want to keep it outside somewhere here, and then still you want to do it? Now what you can do is, instead of checking for not equal to 3, let's check for equal to 3. I mean the values which are divisible by 3. And I want to skip the remaining statements and go for the next iteration. So I can simply say continue. Now what is going to happen here is, when the value is 0, it is divisible, and then it will simply continue. Continue means it will skip the remaining statements here and go for the next value in the range, which is 1 in this case. And I think we should do that while, first of all, let's run this, and you can see that we got the same output. But now I want to do that with debugger, and I will just put a debugger here. And let's try now. Let's see the range. So the value should be, data is not important to the top now. I can just hop over. The value is 0, and that is divisible by 3. Continue. If you observe, it is skipping the print. It's not going to print when I say step over. And now the value is 1. The condition is false. It will print the value, and then continue. The value becomes 2. it will print the value. When the value becomes 3, condition is true, it will continue and it will skip print. That's how continue works. So whenever you want to skip certain things, or whenever you want to skip the remaining part of a for loop, for block, and continue with the next iteration, you can use continue. Okay, that's how continue works. In fact, before we go for the next one, I want to remove this data part and stop this. And let's talk about break now. Now, break works in a different way than continue. Let me just remove this part for time. Let's comment this. And let's try to, okay, I have to go back to my PowerShell, the first window. Let's run this, and you can see it is printing all. Let's say I want to print the first 5 values before 5. I want to print till 4. In that case, what you can do is you can check for the condition. If the value is not equal to 5 or equal to 5, let's say equal to 5. In that case, I want to stop the loop. Okay, now how do we do it? So let me remove this now. So how do we stop a loop? I don't want to continue the loop after 5. In that case, you can simply say break. Break will simply break the loop and come out. So now you might be confused between continue and break. No, it's very different. Continue will continue with the next iteration. Break will simply break it. Break the loop and continue with the other part. Example, if I just come back here and say print by and see what happens. So let's run this, and you can see it is stopping at 4. That means the loop has ended and it will go to by. And if you want to see this in a debug mode, let's run this. And now step over, the value is 0, it will print. The value is 1, it will print. The value is 2, it will print. Value is 3, it will print. Value 4 is print. The value becomes 5 now, and it will break, you can see, and it will directly jump out and prints by. Okay, so that's the difference. Cool. So I hope it makes sense now. So that's it from break and continue. Now let's say you want to store multiple values. So if you have, let's say, 2 values or 4 values, we can create variables, right? So let's say you got 4 values, you got variable A, B, C, D, and then you're able to store it. But what if you want to store a lot of values in one place? How will you do it? Then you will say, hey, we have talked about it. We have talked about list, we have talked about tuple, and we can do those things there. So we can store all the values or multiple values in a list. But here's a problem. When you talk about list supports multiple type of data. So you can have integers, you can have string, you can have characters. But you will say, hey, that's an advantage, right? See, that's an advantage. Yes, you can store different type of data in one place. But when you perform operation on that data, so let's say if you want to work with integers, you perform arithmetic operations. When you work with string, maybe you want to fetch a particular character, or you want to slice the characters or string. And different type of data will have different operations. But if you have everything in one list, what operation you're going to perform? So that's a problem. Second is when you work with list and when you have multiple values, all these values are scattered. They're not stored at one place or not in sequence. And whenever you want to perform operations which is time consuming, the major part will be going in searching for the values here there. And to solve this problem, we got a concept called array. Now, array is not something new to Python. It's there in other languages as well. But Python tried to make it simple. If you want to use array, if you want to do some complex operations with arrays, or if you want 2-dimensional array or something very complex, that's where you can use a library in Python called NumPy. And that's why if you have heard about machine learning and AI, they do talk about NumPy in Python. But we are not doing that now. We are focusing only on inbuilt array. So how do we create that? First of all, let me create a file. I will name this as array-demo.py. And if you want to use array, as I mentioned before, it's a module. So as a module, you have to basically import it first. So I can simply say import array, but then array has a lot of stuff inside it which I want to use in this code. So I'm going to get everything from there. So I will say from array import. I can import array or I can import everything from it. And I need to disable my copilot or at least snooze for it for some time. And now if you jump to array, you can see it has a lot of things. First of all, it's a module, and don't get scared by looking at everything, and we are not going to discuss everything here. But let me give you a thing. So basically, you can see we have types here. Now, the first problem I was talking about, list support different type of data. in one list, but in array, you can create array of different types, but one array will have only one type. And you have to define that type at the start. So you can define a type like this. You can say I want characters because B represents byte, which take one character. You can say H for short. You can say I for integer, L for long. Then we also got F for float values, F or D. Now here, if we talk about this small I, it is for signed integer. Capital I is for unsigned integer. So if you want to store negative values, you use I. If you want to use the positive values, you can use capital I. So when I say small negative, we can also have negative and positive because you will get the signed integers. So those are the types we have to mention. Next, with the array, you can perform different operations. So let's say you can perform, you can create a new array. Then you can use append to add value at the end. You can also use buffer info to get the size of the array. Then we have count for counting. Then we can insert the value, we can pop the value, we can remove the value. We can convert the array into a list. So we got so many options here to work with. So let's do that. In fact, we are not going to use all, but let's see what you can do. So let me create an array here, and I can say ARR1, that's my array here, equal to. Now, how do we create an array? Of course, I want multiple values. I can just put that in a square bracket. So let's say the values are this, some random values. Now, when you have these values, I want to know the type of it. So I can say print type, and I can print the type of ARR1. And what do you think? If I run this, what will be the type? Is it array or will it be list? Now, why I'm saying is list because we have done this before. So if I say demo.py, it is list, but I want an array, right? Now, we don't have any special symbol for the array, but array is a module. So it has some functions using which you can create this array. So the function or the constructor, again, we'll talk about constructor later, but we got this array here. Just pass the list and your job is done. Let's see if it is really working. No, there's a problem here. The problem is it says array argument 1 must be Unicode character, not a list. Because we are passing a list here. What it's expecting as a first argument is the Unicode character. Now you will say, hey, what's that Unicode character? Remember that I, B, H we talked about? That thing we have to mention here. And this will define what type of data you're going to have in this array. Now you can't have any other type here. So if you say 5.5, and if you run this, it will not feel good. It will say float object cannot be interpreted as integer. So you have to make sure that everything is integer here. And with that, no problem. And the type is array. Nice. I don't want to print the type now. I want to print the values of it. And we can do that easily. So I can just remove the type and I can just render this. And you can see it is printing array. Then it is printing the type of it, which is integer. And then it is printing the values. Cool. So this array is working. But you know what? I want to print only the values here. One thing you can do, you can convert this into a list and then you can print it. So that's something you can do. And this will print only the values in the list format. But what if you want to print this one by one? In that case, remember when you have a collection and if you want to fetch value one by one, we can use loops. And the best loop to do that is a for loop. So I will say for n in AR1 and we can print the value n like this. Okay, now what will happen is it will print the value one by one. As simple as that. Cool, right? Okay, this is working. What else we can do here? So we got other operations as well, which we can do. Maybe I want to print the buffer info of this. So I can say print and ARR1 dot buffer info, and let's see what it prints, and then we'll discuss what it is doing. So you can see this is your address and this is your size. Okay, that's what you can get in the buffer info. So yeah, that's it from this. So now we know how to use arrays in Python. So basically we can import the array and then we can work with it. So we can create the object of it, we can get the information about it, the buffer size, and we can print the value. But let's say I want to explore more functions or methods inside this array. How do we do it? And what are those functions? So let's try it out. So before you print, in fact, I don't want to print the buffer info anymore. And let's take ARR1. And if I say dot, you can see we have a lot of things inside this. We got something called append. Let's try what append does. And in this, I'm going to append a value, let's say 77. Again, I have to snooze my Copilot for some time. So I'm appending 77 and I'm trying to print the values here. So what will happen? So let's go back to the terminal, and if I try to run this, so it will print all the values of the array, and you can see at the end we got 77. So append basically adds the element at the end. Okay, so apart from append, what else we can do? So let's try to reverse the value. So I will say arr1 dot, and there's a function called reverse, not remove, reverse, and let's see what this one do. I'll just clear this and run, and you can see we got the same values, but then reverse order. So the 66 which we have added at the end is the first one, so it is reversing the entire array. So likewise we can use multiple functions, and I want you to explore them, but what I want to do now is very simple stuff. Let's say I want to create another array with the same value. And you'll be saying, hey, that's simple, right? We have done that before with normal variables. What we can do is we can create a new array like arr2, and then we can get the value from arr1. Our job is done. And we can also print this value. So instead of using a loop now, I'm simply going to print this by passing the value of arr1 and by passing the value of arr2. So it should print the same value. That's what I'm expecting here, or maybe an error. Let's see. Run, there's no error, and you got two output, and both the values are similar, or not just similar, they are same. So they are the same type, they got the same values. That's perfect. But the question is, do we have two array, or we have two variables referring to the same array? We can find out that. What we can do is, after we do that operation of assigning here, I can simply come back here and change the value of one of the array. So let's try with this. I'm going to replace this 55 with 54, and that's at the index number 2, and I'm going to set that value as 54. Now it is going to change the arr1 for sure. What about arr2? So let's run this, and you can see for the first array it is 54. That's what we wanted. But for the second array as well, we are changing it. That means we don't have two different arrays. We got the same array. So we just have one array and two variables are referring it. So that means we are not copying the array. How do we copy it? I want to achieve that copying part. So what I can do is I can just remove this and create a new array. That will solve our problem. So if I go back here and run this, first of all, it needs at least one argument. It needs a type. So I will specify the type as I. Now it should not be an issue. Run. So the first array has the value, second array, we don't have any value there because we are not assigning it here. So I want the value coming from the first array. Of course, I can copy paste it here, but then that's not copying the array. That's simply creating a new array by using the same values. That's hard coded. What I want to do is whatever value we have in the first array, we want in the second array. So what you can do is you can take the array 1, but then array 1 is an array. We have to pass the list. So we can convert that into a list. So I can say arr1 dot, do we have an option of, yeah. So there's a function called toList which we can use. So it will convert, I mean, not convert, but it will take the value from the array and fetch the list from it. And that's, as you can see, it's a function called toList which returns a list. Okay. Hopefully this will work, provided I enter the correct spelling for clear. Let's run this, and now you can see we got two different arrays. How do I know this? The first array values changed. The second array value is not changed. That means, yes, we have two arrays here. That's perfect. What about the type here? I'm hard coding the type. How do I know what's the type we have in the first array? I mean, you can see it here, but let's say you are getting this value from somewhere else, from the network or somewhere. How will you do it? Not the network, because the network you will get JSON data, but you got the point, right? You're getting this value from somewhere else. In that case, you can get the type as well. So what you can do is you can use arr1 and you can get something called a type code. Now using type code, it will give you the type of the array, which is integer in this case, and we don't have to hard code the value. And that perfectly works. Now this is one way of doing it. Now you will be saying, okay, why one way? Is it not the best way? It is one way, not the best way. Why is because you are creating a new array. Of course, you are going to use that extra memory, and then you will say, of course, when you create two different arrays, it will take extra memory. But think in this sense. When you convert this into a list, don't you think converting into a list will create a new list, which itself will take some memory in the backend? Why we are wasting that memory? So instead of using this statement here, what we can do is we can use something called a generator expression. Now what it does is, so I will show you the code first and then I will explain what is happening. Now this is the expression which you just have to put in the round brackets. Now what we have done here, it's very simple actually. We have talked about for n in ARR1. So what it will do is it will iterate in the ARR1. It will get one value which is in the n, and you can do whatever you want with it. In this case, what we are doing is we are simply saying take that value n, and this n will represent one value at a time, and it will add that to the ARR2. Now, since you are copying one by one, you're not creating the extra list which was occupying some space. Okay, so this is more memory efficient. Yes, it will consume more operations, but memory efficient and not that much of operations. So it sounds like a good option there. So yeah, this is more functions which you have. So we have talked about append. In fact, I would encourage you to try out one example where you got an empty array, and we know how to get empty array now. You just have to pass the type, don't pass the values, and then ask for the value from the user. And whatever user enters the value, just add that in the array. Perfect, right? Or maybe you can ask for the size as well in the start. So you can say, okay, how many values you want to add? If a user says, I want to add 10 values, run a loop, which goes from 0 to 9 or 10 values, and then add those values and see how it works. Okay, so I'm excited to see your code. So yeah, that's about array and its functions. And now it's time to go back to functions. Yes, we have talked about functions. We know how to create a function. We know how to pass arguments in the function, and we know how to call a function. And now it's time to talk about the arguments when you work with the functions. I mean, we can argue on that. Okay, again, a poor joke. Doesn't matter. So let's create a new file, and I will say this is functarg.py. Name of the file doesn't matter. And what I'm going to do here is I'm going to create a simple function, and the same function which we have talked about before. So I'm going to create a function called add, and of course this is going to add two numbers. So let's say the num1 and num2. So we got these two variables, and in this I don't want to do anything fancy. I just want to add them. So we can return num1 plus num2. Our job is done. And also we need to call it. If you don't call it, it will not work. So let's say it will return something. I'm going to put that in result, and let's call that function, and let's pass two values. Let's say 4, 5, and we know it's going to return 9 if the operation is correct. And let me just print it. Simple stuff, nothing fancy. And let's go back here and run this. So it's functarg.py, and you got the value which is 9. Simple stuff, right? Now what extra we are going to look at here? See, this is your parameters, right? And you're passing some arguments here. So you're passing 4 and 5, and this goes here, and then you are basically adding them, and then you are getting a response. So we can do few things here. The first thing is, what if I'm not passing any value? I mean, I'm passing 4, I'm not passing 5. Now will this work? Now there's no compile time issue. I mean, there is, but then the IDE is not suggesting anything. But the moment you try to run this, it will give you an error. It says add missing one required positional argument, which is num2. So it says you are passing num1, good job, but where's num2? So we have to pass that as well. Now, if a function accepts two parameters, you have to pass them. If you don't pass it, it will complain. So what I can do is, I can pass the value, or we can assign a default value to num2, something like this. If you say the default value for num2 is 0, if you don't pass a value for num2, the default it will take is 0. Okay, and yes, that is possible in Python, and it works. You can see we got 4. So that's what you're passing, and this will be added with 0, and that's what you got. Now this thing which we have done here is called a default arguments. You can have this default value for num1 as well. You can set it to 0. Now both have default values, and beauty is you don't have to pass values now. You can pass 0 values, you can pass 1 value, you can pass 2 values, and it will not complain. So if you don't pass a value here, if you run this, it will give you 0. But let's say if you pass 1 value, which is 4, it will give you 4. And if you pass 2 values here, which is 4, 5, and if you run this with this, you will get 9. And that's the beauty. But yes, if you pass more values than expected, then it will say, hey, what you doing? Something like this. It will say, we wanted 2, and you're giving me 3. You're very generous, but then we don't want it. So this is the default arguments. If you don't specify the value, it will take the default values. But let's say if you're passing 3 values, then what? If you're passing 4 values, then what? Now in this scenario, if you want this to work, what you can do is you can create one more function with the same name add, but it will accept 4 values. Something like this. You can just take this and put it here. So we got two functions, but then you need to specify num3 and num4. So this is how you specify the values. And there's one more thing. If you specify the default values for the first values, you have to also specify for the upcoming value. Otherwise, it will get confused if you're passing two values for which variable those values are. So what I'm going to do is I'm going to remove the default values from here, and now it will not complain. So when you pass two values, it will go for the first one. If you pass four values, it will go for the second one. This is not the default arguments. We're not specifying anything. And that's the concern. Of course, we are not adding them. We can simply say plus num3 plus num4, and that will work. But there's a problem with this. The problem is with 4 values, it will work. For 5 values, then it will give you issue again. And then we'll say, okay, we don't have any function which takes 5 parameters or arguments. Okay, so we have to create one more. Then what if you pass 10 values? What if you pass 100 values? So those many methods or functions you have to create. I don't want to do that. What I want to do is, it doesn't matter how many values you pass. It should work with single function. Something like this. I will remove this function now. Let me remove the default values. But before I do that, I will just have that backup here and comment this. Now we are not working with default values. What we are working with is variable length arguments. Okay. And this will work. No, we have to make some changes. So I will remove this default values first of all. And now it doesn't matter how many value you pass, you need to accept it. So let's say the first value is fixed, right? When you add two numbers, the first value is always fixed. The second parameter, this value can change. It can be one value, it can be 2, it can be 10, it can be 100, it can be thousands. How do you accept it? In that scenario, we can use a concept of variable length argument. So what you do is you just use a star with a variable, which means it will take this value as a tuple. Okay, so this 4 will go in num1. Remaining values will become a tuple and go to num2. Fancy stuff, right? And I know you don't trust me. First of all, this operation will not work. So I will return 0 at this point. But I want to show you something. I will just print num1 and I'm going to print num2 to show you how those things look like. So clear, run, and you can see the first value is 4. The next 3 values are in the tuple. Now, once you got the tuple, you can simply fetch the value, run a loop and add them. How? Let me show you. Let me use a variable called sum, which will have a default value as num1 because that's the value you're anyway sending. Now for the num2, to add that to the sum, I can use a loop and I can say n in num2 because that's a tuple now. So it will give you one value at a time, which will go into the n. And then you can simply sum it up. So you can say sum, you can say plus equal to n, and that should solve the problem. Or you can say sum is equal to sum plus n. Your choice if you don't want to use the shorthand here. And return sum. Okay, it's so simple. Now the logic is not important. If you're getting confused here how that logic works, doesn't matter. You can try it out. What's important for this particular section is we can pass multiple values that will go in num2 as a tuple, and then you can do whatever you want with that tuple. Okay, but still we need to run this. Let's run this, and you got 22. We can actually verify. So this is 9 plus 6. This is 15. 15 plus 7, 22. Perfectly works. Now this is called a variable length arguments. So we have talked about two things, the default arguments and variable length arguments. Now we have to talk about more things. Let's start with that. Now to talk about those things, I'm going to comment the entire part. I don't want to work with default values and variable length arguments and not even add. Let's work with some other example. Let me get a function called person. Now we are representing a person and you want certain information about the person from the user because that's what you're going to print, or maybe you want to save it to database, your choice. Now what values I want? Let's say 2 values. One is age and one is name. So name and age for the person, and we're not going to do anything fancy. I'm just going to print it with a string. So I can say name colon, and I'm going to print name. Then I'm going to print the age as well. Give a colon, give a comma, and say age. So we have this function called person, and then we have name, age, and that is there. Now I want to call this as well. So I will say person, and logically you have to pass two things. You have to pass a name. I'm going to pass my name, and I'm going to pass the age. That's not my age, but that works. So let me create this, run, and you can see it says Naveen and 30. That perfectly works. But then why we are working with this example is because what if you don't pass the age? Then it will give you some bad words. It will say, what you doing? Where's the age? Then you know how to solve it. You know, maybe you're doing it for the ticket booking of a movie where only adults can attend. So 18 plus movie or A-rated movies. In that case, you can assume the default value for the age is 18 if a user is not passing it. If you're passing it, then of course it will replace with a new value. So if I don't pass the value, I'm going to get 18. That perfectly works. But we have talked about it, so why to discuss now? What extra I'm going to talk about is this. What if I make a mistake and I'm passing the age first and then the name? Now, there's nowhere we are mentioning what type of data we're accepting. So 30 goes to name, Naveen goes to age, and your Python will say, that's okay. I can understand what you're trying to say, but I'm going to assume what you're going to say. So if you're saying 30, that should be the first variable. If you're saying name, that goes into age variable, and you can't complain. It's your mistake. Then you will say, hey, I know it. It's there. First is name, then is age. Then why I'm making a mistake there? It's because maybe this particular function is not there in your file. You are importing a module somewhere, and in that module, person function is defined there. How will you know the code? Okay, and okay, there's one way actually. When you use IDEs, it will give you suggestion. So if you say control space, you can say person, or you can just click here. It will give you, there are two variables, name and age. You can know the sequence. But mistakes can happen from anywhere, right? So this is the bug, Name should not be 30 and age should not be Naveen. Now, if you want to remove this bug, what you can do is you can use something called a keyword argument, where you can mention the first variable which I'm passing is age. The second variable which I'm passing is name. Now you are specifying that the 30 is age, Naveen is name. Then Python will say, okay, I'm going to look at the person and I'm going to hit a particular variable with the value. So age will be hit by 30 and name will be hit by Naveen. Let's see if that works, and that works. Now this thing here is called keyword arguments. Simple stuff, right? Okay, now this thing we know. So we have talked about default arguments. We have talked about variable length arguments. We have talked about keyword arguments. But what if you want to talk about keyword variable length arguments? And then you will say why we are doing that. So let's say I'm passing this to, and I'm accepting this to. That perfectly works. But what if I'm passing extra values? Something like this. Let's say I'm passing name and then I'm passing age, which is, let's say, 30 in this case. I'm going to pass the location as well. And I'm going to say Pune. And I'm going to pass, let's say, one more thing, the favorite technology, which I love. And since we are learning Python, I have to say Python. I don't have a choice. So I'm passing all these values. Now, we don't have those variables here. We only got name and age. And if we try to work with this, it will say, what you doing? We just wanted to, we are passing multiple, and there's a keyword argument called location. I don't find it anywhere in the definition. So how do you accept it? One of the analogy you can assume is, or you can imagine, is pizza. So when you order pizza online, basically you mention your name, and that's compulsory. But apart from it, of course, you are ordering pizza, so they have to give a pizza. But on that pizza, you can mention the toppings, what you want. And there can be one topping or no topping or multiple toppings, 10, 12, 30, your choice. When you go to Subway, you say, I want all. So if you pass all those values, how will you accept it here? And that's where you can use something called a keyword variable length arguments, or we can say keyword length arguments. Now, how do you accept it? So first of all, let's remove the variable name age. We can use something called w length arguments, if that works, whatever variable name. And then at the start, we have to give 2 stars. Now you will say, why 2 stars? Why not 1 star? Because that is already for the variable length arguments. This is 2 star. We can also do that with single star, right? We can pass multiple values. See, the problem is when you pass multiple values, when you perform the operation, you should know what that value represents. In this case, I'm specifying this keyword for that, right? So we are specifying this is age, this is location, this is tech. And if you use single star, you can't do that. You can't get the key for it. So these are the keys and these are the values. And the moment you say key values, we remember one thing, dictionary, right? So when you use 2 star, it creates a dictionary for you. Now I can't print age, but if I try to print the keyword length arguments, let's see what happens. So run, and you got name because that's compulsory for the pizza ordering. But the other thing is a dictionary here. Now, how do you fetch the values? You have dictionary, you can print value one by one. You can use a for loop. It's just that we need 2 things. One is a key and a value. So I will say k comma v in keyword length arguments. And from them, I want to get the items. Now, once you get the items and one value you get in the key and in a value pair, you can print it. First, I will print k, then I'll give a comma. In this, I'm going to put a colon so that I can differentiate between key value, and I'm going to say v. So it will print name, and then it will print this particular things. Let's see if that works. Run, and it worked. Okay, so you can play with arguments of a function and you can pass multiple things. So yeah, that's about this particular video. In this video, we'll talk about global and local variables. So we have talked about variables before. We normally use them to store data, but now we have to introduce this concept where we can have a local variable and we can also have a global variable. But then what's the difference and why do we need it? So let's create one file here to understand. So let's name this as global demo.py, and this is our file. Let's create a variable. Now, of course, you can use any variable name, and variable name should make sense. But since we are into this learning process, variable like a will do. Now let's say the variable value here is 10, and I think I have to snooze my Copilot. So the value for a is 10, and now afterwards if I try to print it, of course this will work. And if this is not working, we have to stop learning Python. So I will say Python global demo.py, and you can see we got the output as 10. That's perfect. Now what I want to do here is I want to change the value of this a. So this is a variable. I can change the value, and that's the benefit you get from the variables, right? Now I don't want to change that outside. I want to change that inside a function. So let's define a function which will do something, and that's why we'll name this something. And how do you change it? Now first of all, let me try to print the value of a inside the function as well. And of course we need to call the function, otherwise it will not work. It will not print a value inside. So we are creating a function, we are calling the function, and inside this we are printing the value of a. But also I want to write something so that I can differentiate between this particular print and this particular print. So we are writing inside. So here it should be outside. So I will say outside, and looks cool. So now you tell me in your mind, of course, will this print or will this work? Can we use the variable created outside the function, and can we use that inside the function? Here this will work for sure because we have done that before, but what about the function? Let's try it out. So I will just clear this and run. It is working. Okay, I forgot to add a colon. It should look good, right? Clear, run. So now it is printing both. That means this is working, that is working. So inside the function, you can use the variable which is created outside. But what if you create this function or you create this variable inside? So somewhere here, you say a equal to, let's say 15. Can you use it here? Now your IDE says there's no problem. There's no warning here. But if you can see there's a warning, there's a yellow line goes there or a sine wave goes there, which says a is not defined. That's weird. We have defined it, but we have defined it inside a function and we are trying to access it outside the function. That's the real problem. Now this is similar to what you have, let's say when you have a house, it's your house, it's your private property. And whatever things you have inside your house, it's your things, right? But the things which is outside, let's say in the park, there's a bench, you went on a beach, there's a sand there. Now all these things are public. So if you go to a beach and grab a sand, no one will say anything, right? But yeah, if you are on a beach and if you see a phone there, don't pick it up. That belongs to someone. But sand is okay. The garbage on the beach is okay. You're supposed to clean that up. But the things inside your house, if someone from the outside comes to your house and say, okay, I want to grab this, not allowed. Because that's a private variable or the local variable. So this thing here is a local variable. And in fact, not just IDE, if you talk to the interpreter, even that will say, what you doing? And you can't access that. It's not defined. It's not defined outside, it's defined inside. You can't access it here. So we have to declare the variable or define the variable on both the side, outside and inside, so that you can use it. Inside is optional. You can use it the outside one. But now, if you observe, the moment I ran it, we can see the value. Inside value is 15. Outside value is 10. That means they're not pointing to the same variable. We are actually creating two different variables. Cool. So that makes sense, right? Because you are creating this variable. This is a global variable here. So we can say this is a global variable. And what you created inside here, this is the local variable because this is created inside the function. So we got two variables. But what if I want to change the value of a which is created outside. Now I want to change that inside the function because this is not working. This is creating a new variable. Now how do you use the outside one? And this is where you have to find a way to access the global variables. And for this, thanks to Python, we got this inbuilt function called globals. So let me show you what global looks like. So this is globals function. Okay. Now this function basically returns the dictionary. But what it returns in the dictionary format? It returns the dictionary containing the current scope's global variable. Okay, variables, not just one. So if you have multiple variables, it will return all the variables to you. So if I create a variable B, variable C, all the variables, you will get it here. And not just variables, you will get something extra. And we will get to know that by printing it. So we are printing in this format. So this is a dictionary. You can also print this in the format of, key value pair, by running a loop, but I just want to keep it simple. I'm just going to print it as it is. So I will just clear the screen, run. And if you observe a lot of things here, this is the entire dictionary which you have. Now this is your key, the first key, and this is a value. We have not talked about this name yet. We'll talk about that later. Then we got doc, which is none. We got a package, which is a key. This is a value. This is a key. This is a value. And so on. And we have not created them. This is what Python gives you. There's one more dictionary, which is file, or one more key, which is file. And you got the value, which is your file name. Then you got the key, which is cached. It says none. That's the value. And then comes interesting part, which is this. A is a key. 10 is the value. That's the global variable. But we also got something as a key, and the function something at this location as a value. Now we don't have to do anything with the function. We are concerned only about this particular thing. Okay, so you can use this. Now instead of printing the entire dictionary, I can fetch one value, which is A. And this is treating that key as a string. So you can see it is in single quote. So I can fetch the value here. Let me clear it, run, and you can see it is printing 10. So this is 10 because of this statement here. So whatever value you have for the global variable, you are printing it. I just don't want to print it. I want to assign the value. So what you can do is you can just remove this. I don't want to print it. I want to assign it. So you can say globals of A, and then you can assign a value which is, let's say, 20 in this case. Okay. Now what you're doing is you are changing the value of a global variable which was 10 initially. Now you are making it 20. But will this work? That's what we want to check. So clear, run, and you can see the global variable, which is outside, is printing 20. The inside is still 15. We are not impacting it. Okay, it's just the outside which we are changing. Now, if you are not sure, let's declare it outside. Let's define it before you set the global variable so that we'll know. And I forgot to put this part as well. So now we are defining it here. Then we are changing the value for the global variable. Then we are printing. So the sequence should not matter. And you can see inside is 15, outside is 20. Now this is the concept of global variable and local variable because we are going to use it after some time. And that's why we talked about global and local. And now it's time to talk about Factorial. And you'll be saying, hey Naveen, we are here to learn coding. And now why we are talking about maths? See, the thing is, when you work with Factorial, there are a lot of concepts which covers, and also it helps you to think logically because that's your first place where you are thinking. Not the biggest code, but you have to think there. Also, in future, we are going to look at recursion, and Factor is a one way where you can use recursion properly for a beginner. Okay, so let's get to the Factorial, and here I'm going to create a new file, and I will name this as factdemo.py, and that's the file. Now you will be saying, okay, but we don't know what Factorial is. It's actually very simple. It's one of the easiest thing in maths. Don't tell that to a kid who is into school, but because I was struggling with it. Anyway, the point is when you say factorial, it's very simple. When you say, if I ask you, hey, what's the factorial of 5? You can calculate by saying, okay, factorial of 5 is 5 into 4 into 3 into 2 into 1. If you can do that, if you can multiply, you got the answer. So it's not the factorial, it's more about multiplication. But yeah, so factorial is this, 5 into 4 into 3 into 2 into 1. Or if you want to make it in a proper sequence in the ascending order, you can say 1 into 2 into 3 into 4 into 5. Whatever you do, you will get the same output. So the complex logic here is just to run a loop and multiply the numbers from 1 to the number which you mentioned. So we will go in a function way. So let's create a function called fact, and I think I have to disable my copilot. Okay, so we got a function fact, and of course we need to call it somewhere, so we'll call it here fact by passing a value. Let's say I want to find the factorial of 5, and once it returns a value, I will store that in a result, and this is a result. I want to print it somewhere, so I will say result. Simple stuff, but unfortunately we don't have this fact function defined properly, and you can see we are getting an error here. Now one way, if you want to bypass this error, you can write a keyword called pass. So let's say if you create a function, and in that function you don't know what code you have to write now, if you want to ignore errors and stuff, you can write pass and it will not give you error, because you're saying that, hey, I'm getting a function, I don't know what to write there, just say pass. Okay, that's a keyword in Python, by the way. But here I know what to type. So basically, whatever number you're passing, you just have to accept that number. So I'm accepting it here, or not as a number, in a variable. I will say num. And once you got that number, let's return a variable called res, if that makes sense, for the result. Because I'm already using result here, so I don't want to confuse you with the same name. Let's say res. And initially, the value for res will be 1. Okay, it doesn't matter what you pass. It will always return 1. And if you don't trust me, I will just run this. I will say fact demo.py. I don't know why I have this file open. Let's run, and you can see it will return 1. But that's not the correct answer. We have to do that calculation here. So what we have to do now is, if a user says, hey, I want to find the factorial of 5, which went into num, I have to say 5 into 4 into 3 into 2 into 1. Run a loop and just multiply. Or you can say 1 into 2 into 3 into 4 into 5, your choice. So I'm going to use a loop here, and I'm going to use a variable I, and we are going to use a range here because I want to go from 1 to 5, or 5 to 1, your choice. Let's go to 1 to 5, and we'll start from 1, we'll end at 5. But if I say num, it will end at 4, because that's how range works. Range goes from the first value to the second last value. I want to include the last value, so I'll say num plus 1 and give a colon. So now we are going from 1 to 5. And every time you do that, you just have to multiply that with res, or not 1. You have to multiply that with I. I think your job is done. It's so simple. I don't know why I said complex at the start, because it's complex for the school-going kids. I mean, not the current kids, because they are way smarter than what we were, depending upon who is watching this video. But you got the point. Let's run this, and you can see we got 120. And you can verify that by manually multiplying it, or go to Google and search for what's the factorial of 5. And you will get the answer. You can do it for a bigger number, let's say 12, and this should work, and you got a bigger number. And if you go beyond that, God bless your machine, if that is possible. Oh, okay. I'm not sure if this is correct. And this is where you go to Google and search factorial. I'm not showing you the screen. I'm just first checking if it is correct. Factorial of 20. Yeah, looks like a right number. I'm going to share that with you. So yeah, we are right. The number looks close. Okay. But let's say if you say 30, I want to see where it breaks. Still doing it strong. Python is able to handle that properly, and we are testing the ultimate thing now. Still doing it. I don't know if it is correct. Factorial of 1000. I don't know why I'm having this fun. Okay, when this failed, I think. So value is 4, 2, 3. Yeah, so 4023. That's how we are starting. So it looks good. Python is doing well. So this is what you can do with the factorial and simple code. Now, in the upcoming videos, we're going to talk about recursion and stuff, and we can do factorial with recursion as well. Why I'm saying this is because when you go to Google and search for, give me a factorial code in Python, they might give you recursion code. This is one way. The second way is recursion. Recursion is a function calling itself. So when you create a function called hello, and if hello calls hello, that's recursion. I know that sounds weird. Why someone will do that? That will make sense once we see an example like factorial using a recursion. But here, let's understand what is recursion with a code. So what I'm going to do is I'm going to create a new file, and we'll name this as recursion.py. And in this file, I'm going to create a very simple function. Let's say def and greet function. And in this, I'm not going to do anything fancy. Just say print, and I forgot to disable my copilot. So print, and I'm going to print hello. So we got this function and I'm going to print hello. Now I'm not going to call it. Okay, intentionally I'm not going to call it. I'm just going to run this. So I will say recursion. So we got a function I'm not even calling once. Let's see what happens. It is not printing anything because we're not calling it. Let's call it. Where should I call it? So outside the function, I'm going to say greet, call this function. And now, okay, I'm running a wrong file. So it is Python recursion.py, enter. And now you can see we got hello. I don't know what file I've run before, but anyway, you could have got the same output. So now you can see it is printing hello. That's cool. But what if after this printing, I'm going to call greet once more. So I'm going to clear this, and I think I was running fact before, but let's run recursion and let's see what happens. So what I'm doing is I'm calling this function greet again. And the moment you do that, okay, so we got errors, but ignore the errors. Let's go up. And you can see it has printed hello multiple times. I'm scrolling, okay? If you're thinking this is a static output, no, I'm scrolling, I'm just going up. And if I go on the top, I still can see hello. So I don't know if you can see my scroll bar, I'm just moving up and down. So we got a lot of hellos there. So what is happening is when you call this function for the first time, greet will print hello, and then it will call greet again. Then greet is getting executed. It is printing hello. It's calling itself again. This concept of calling the function or function calling itself is called recursion. Now, I know you are not trusting me, and we also got errors here. So it says previous line repeated 996 more times, and recursion error, maximum recursion depth exceeded. That means there's a limit also. You can't simply keep calling this function and then it goes for the infinite. Nothing wrong in that sense if you intentionally want to do it. But let's say if you make a mistake, and by mistake you wrote a function and then in between you called itself and you forgot about it, and then you gave it to the user, and user has clicked a button which is calling this function, and just imagine the function calling itself, because every function call will consume the memory, it will consume the CPU power, and it is going infinite, which will result in crashing the application or maybe the system. If you want to do it intentionally, like if you want to build a virus, please do that. But by default, Python says, hey, hold on, I know people will make mistake. They might write the same code, or they might call the same function their own function. So I have to set a limit, and the default limit is 1000. How do I know it? You can get it from inbuilt functions. So we got a sys module. In this sys module, there is a function. So if you say sys.get recursion limit, this will basically return the limit. And if you want to know it, you can just print it, and this is how you do it. Just make sure that you comment greet before you do that, because greet will print hello multiple times and you can't even see this limit. So now I'm going to run it, and you can see it says 1000. So by default, the limit is 1000. But can you change this limit? We can. So we can say sys.set recursion limit, and you can set the limit to whatever number you want. Let's say 3000. Okay, or maybe 10,000. I'm not sure. I've never tested 10,000. I went only for 3000 max. Let's see if that works. Let's clear this and run. So yeah, so the new limit is 10,000. That's great. You can see we got 4 zeros, not 3. But then if I call greet, let's see where it stops now. Run. It is printing hello multiple times, and it covered printing 10,000 or calling the function greet 10,000 times. Okay, I should appreciate my machine now. It's very fast. Okay, but you can see it's saying that previous line repeated this number of times. So 4 here, but we got 9,996 times. So you can increase the limit however you want. Let's try. Since we are trying, I just want to see the limit of the system. Okay, it's taking some time now. Okay, so 1 lakh is a big number. It's taking some time, but it has done it. Okay, but the point is you can run this. You can call the function by itself, and that is called recursion. But let's say if you want to see this in a slow motion, can we do that? We can. So to do that in the slow motion, what you can do is you can use a sleep method. So after printing hello, you can say sleep, and let's say I want to sleep it for 20 milliseconds. So I can say 0.02 seconds, which is 20 milliseconds if my maths is not wrong. And since if you want to use sleep, you have to use it from the time module. So from time import sleep. Okay. And now let's see if that works. Run. And you can see it is printing hello slowly. Not that slowly, which we expected, but it is doing it. I will stop it because it's one lag time. I don't want to waste your time watching it. I want to do one more thing. Every time I print hello, I want to print the count, what's the current count of the hello. Okay, you can do that by creating a variable outside. So you can say count is equal to 1. And if you want to use that variable inside, of course, you can say count, but let's see. I think it will say hello, 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 hello 1, hello 2. Yeah, hello 1. It will print hello 1. Why I say 2? I just have to also increment it. But since you are changing it, it will not change it. We have talked about global and local variable. It will create, I think it will create issue. Run. No, it's not able to access that because you are also declaring it here and you want to use a global variable. So we have not seen one keyword, which is global. We have talked about globals, which will give you the access of the global variables. But if you want to specify that this count is not a local variable, it's a global variable, just redeclare that with the help of global count. Now it will treat this count as a global variable. It will not create a new local variable. Let's see, run, and you can see it is printing hello with the count. And that's, my friend, is recursion. So what is recursion in short? A function calling itself. And I know you're waiting to complete that 1 lakh, and I will not give you that happiness. So we have talked about recursion, we have talked about factorial, and now it's time to combine them. I mean, not the files, but the concept. See, when we worked with factorial, of course, we know the formula now. It's 5 into 4 into 3 into 2 into 1 for the 5 factorial, right? And we can do that with the help of for loop. But then we have also seen we can use recursion. Now you will say, how can we do factorial with recursion? Now imagine this. So let's say if you ask me, hey, what's the factorial of 5? Now I have two formulas. One formula is I can say 5 into 4 into 3 into 2 into 1. I will just multiply them and I will give you the answer, which is 120. Or I can do something like this. Now if you ask me, hey, what's 5 factorial? Now I'll think, okay, 5 factorial is actually 5 into 4 factorial. Think about this. What is 4 factorial? It's 4 into 3 into 2 into 1, which is already part of 5 factorial, right? So can I just merge that 4 into 3 into 2 into 1 as 4 factorial? I can. And that's 5 into 4 factorial. And you will say, okay, but what's the use of that? The use is when you ask me about 5 factorial or you can say factorial of 5, I can ask someone else, I can do 5 into 4 factorial. You give me the factorial of 4. And actually, I'm not talking to someone else. I'm talking to myself. Okay, so when you ask me factorial of 5, I'm asking factorial of 4. Now that me says, okay, 4 factorial is what? 4 factorial is 4 into 3 factorial. Now, that me is dependent on other me by saying, okay, you give me 3 factorial. And that me will say, okay, 3 into 2 factorial. It's actually, I will need help with the 2 factorial. Now that goes to someone else. And that person says, that me says, 2 factorial is 2 into 1 factorial. And we know 1 factorial is 1. So 2 factorial knows now it's 1. So 2 into 1 is 2. Then 3 factorial says, okay, I got the value from you, which is 2. So it's 3 into 2 is 6. Now 3 factorial says the answer is 6. The 4 factorial says, okay, it's 4 into 3 factorial. 3 factorial is 6. So 4 into 6 is 24. And then 4 factorial says it's 24. Now factorial 5, which is actual me, says, okay, 5 into 24 is 120. And you got 120. That's, my friend, is recursion. Okay, but how do we do it? In the code. So let's try. So let me create a new file, which is recursion.py, and in this I need to disable my snooze my copilot. Okay, so what we're going to do is, see, certain things are confirmed. So if I just copy this code and put it here, the only thing which you want to change is the logic. Everything remains same. The function name remains same. The values which you're sending remain same. Let's not send 1000 because I want to know the value. Let's stick to 5. This should return a result, and that's what you're going to print here. And by default, let me say return 1 so that you will not see any error there. But then how we are going to achieve that? It's very simple actually. Instead of returning 1, someone says, I want the factorial of 5. You can say, okay, a factorial of 5 is actually 5 into factorial of 4. Simple, right? If you can do that, your job is done. But this is not the solid numbers. We can just say num. And here we can say num minus 1, because if you're passing 5 You want to find the factorial of 4, so it is num minus 1. Now you will say, okay, but that's for 5 into 4 factorial. How will you get 4 factorial? See, here we are calling the same function by passing 4. Now this function will be called again with the value 4, and that will say, okay, 4 into factorial of 3. Now it will call this function again by passing 3 here, which is 3 into factorial of 2. Now this goes again here as 2, so that's 2 into factorial of 1. And this goes here again by saying 1, and now we don't have to do that 1 into 0 factorial. What you can do is, in that case, check if num is equal to 1. In that case, return 1. Your job is done. So this is the end limit. So more you call, it will go till 1 and then it will stop. Now it will not stop, it will go back, right? So remember that me who was responsible to do for factorial of 1 will return it to the factorial of 2, which will return it to factorial of 3, which will return it to factorial of 4, and to factorial of 5. First, we'll see the output, and then we'll do that in the debug mode to see if it is actually working or not. So I'm going to run this. I'm going to say Python fact recursion.py, enter, and you can see we got 120. But then let's do that in the debug mode. I will just click here, and I want to start the debugging now. So I will say debug the Python file. Yeah, so debugging started. So it started from here, but I want to get into this function of fact. So I will just say step into. Now we went into fact. Now certain things you have to observe here. One is a local variable, which is num, which is 5. Then we got a call stack. Okay, so every time you call a function, it goes into call stack, and this is the function which you have, which is fact, which is called once. But now if I again say step into, so you can see the value of num is not 1, it is 5. So it skipped this if. It went here, and now it says the value of num is 5. So 5 into factorial of 4. Now when you say step into, observe multiple things here on the left hand side in the call stack and in the code here as well. So when I do that, by mistake I clicked on step O. I wanted to get into step into. No issue. I will just do that once again. My bad. So let's say step into, and now if you observe, now we got 2 fact calls. One for the fact of 5, this is fact of 4, and the current stack. So if you see here, if I click here, it says the value of num is 5. If I click here, the value of num is 4. And if I say step into again, the value of num is 4. Now it will say 4 into factorial of 3. If I do step into, the call stack is increasing now. We got 3 functions. So this function here with the value num of 5 is dependent on 4, is dependent upon 3. When 3 returns something, it will go to 4. But we still have few more calls to do. Let's do that. Now it will again go for num of 2. We can see the call stack is 5 now. And if I say step into, so it will say 2 into factorial of 1. And as soon as you get num of 1, it will return 1. But look at the call stack. We got 5 functions there. Okay. And this is dependent upon this one. This is dependent upon this one. This is dependent upon this one. This will depend upon this one. When you return from here, it will go here. When you return from here, it will go here. When you return from here, it will go here. When you return from here, it will go here. And then this will print on the console. After that. So let's do that. So let's be in that stack. And now if I say step into, so it will return 1. Now you can see the stack has reduced. 1 went. Now we are focusing on fact of 2. So fact of 1 returned 1. So now the num is 2. Now see the changes. The 2 factorial says 2. The num is 3. It will multiply. That's the operation we have. And then it became 6 because 3 into 2 was 6. Now it is 6. It will multiply by 4. So 4 into 6 is 24. And that's what you will see there, right? And then 5 into 24, which is 120. That's what you will see there. And this is what it returns at the end, which you are printing, and that's why the result is 120, and that's why on the screen you will see 120. That's recursion and factorial, and that's fun. We'll talk about a very high level concept or highly complex concept name called higher order function, but the name is complex, not the concept. So basically when you talk about functions, and we have worked with function before, we can get a function, we can call the function, we can pass the arguments to the functions. And then when you talk about those arguments, till now we have worked with, you can pass variables, you can pass objects like list or other things. But what if you can pass a function to a function? Is that possible? If it is possible, it is called a higher order function. Just a complex name. and you will get to know more about it once we start coding. But before I do that, let's get back to one of the function code which we have done before, where we have worked with, let's say, person, where we are accepting multiple values. So this are the variables, right? This is a variable, this is an object. But what I'm saying is, in higher order function, you can call person I as a higher order function if it is accepting a function as a parameter. Okay, so let's do that. So what I'm going to do is I'm going to create a new file, and I will say higher order func.py. And here, let's create functions. So let's do a build up by saying I'm creating a function called square, a very simple function which will take a variable or the parameter, and you will do something with it. Maybe you will just multiply that to find a square, and that's how you find the square of a number. We can do the same thing for the cube. Let's say I got cube here, and then we got num. And then how do you find a cube? So of course, this video is not about finding a square or a cube. That's just an example, but this is how you do it. What's more important is, let's say I got a value with me, and that value is 5, and I want to find a square of it, and I want to save that in a result. So it's very simple. You call a function like square and pass the value, your job is done. And you can also print the result if you want, not property, print, and here we can pass the result. So simple, right? So let's go back here and run this. So I will say higher order function.py, and we got an error. It says there's no such file. Okay, I think I made a mistake. So it's not dot, it's underscore. And it says none. That's weird. Why it says none? We are passing a value and we are not returning it. My bad. So I was so much into talking about it, I forgot to write about it. Let's run this, and you can see we got 25. That's perfect. This is a perfect way of doing it. A very good way of doing it, where if whatever function you want to call, just call the function, pass the value, right? But since I want to show you how higher order function work, we'll change this example. Now what I want to do is, so let's say instead of using a function name as square, I want to use a function name as operate. Okay, very simple function name, but you will say, hey, we don't have that function created. Yes, we don't have it. Let's create one. So this is a function which is operate, in which you are passing a value, so I'm going to accept it. Now based on what operation you want to do, maybe you want to find a square, maybe you want to find a cube, that thing you can do it from here. Simple, right? But then which operation you want to do? And that's what you have to specify here. So in the operate, pass the value, also pass what operation or what function you want to do. And I would say operation. Again, name doesn't matter. This can be any name. This can be ABC or PQR. Doesn't matter. I'm just using some logical name finally. So we got an operation as a function here. So we are passing that as a function, and we have to accept operation. This is just to show, but we don't have any operation function, so we'll pass square. So we are passing a square which will go into the operation. Okay, and this is what I was talking about. This a function. So we are calling a function by passing a function, right? Square is a function. And that function goes into the operation, and now you can do whatever you want to do with it. So you can say return operation, and you can pass num. And now you will say, hey, that's a variable. How you are making it a function? No, my friend, that thing here is a function. You're passing a function, right? So this operation which you're receiving here is a function which represents the square function. So behind this it is square. I will just also write it here somewhere. It is calling something like this. It's saying square of num. Okay, so when you're passing square, which goes into the operation, and you can use that function now to call it. Okay, so this operate here is a higher order function, is because this is accepting another function. Okay, now you will say, how's that possible? If you're coming from C, C++, Java, this might be new to you. If this is your first language, welcome to the functional programming, my friend. So basically what happens is, when you talk about C, it's a procedure-oriented programming. C++, kind of object-oriented programming. Java is purely object-oriented programming. And in C, we work with procedures, right? In Java, we work with objects. Now for Java, objects are the first class citizens, right? Where everything is an object. Doesn't matter what you do, you have to work with the object. Python, on the other hand, is a functional programming. So function becomes the first class citizens. So you can do whatever you want with a function. You can call the function, you can create the function, you can call the function, you can pass the function as an argument to the function. Okay, and that's what make it as a functional programming. Also, behind the scene, all the functions are objects. Okay, so anyway, you're passing the object, but the styling of it is function. Okay, and that's why it's called a functional programming. So this operate here is a higher order function because you're accepting and passing the function there. But what if you pass a cube here? Okay, first of all, let's run this by making these changes. I think we have not ran it. It works. Amazing. And if you say cube here, let's see if that works with the cube. Run and it works. Okay, so you just pass the value and the function and that works. Okay, now we can also make this example bit complex if you want. Something like this. Let's say I don't have one value. You got nums in which you are passing multiple values. Let's say 5, 6, 7, and you're passing multiple values, num. So this num is no more a simple variable, it's a list, and you can't simply do this operation. Let's remove that. Also, I don't want to return anything. I just want operate to do this stuff and print it there itself. So here I'm accepting a list. I'm also accepting the function, and I can just work with it. Now, since we have a list, let's use a loop to fetch the values. And on each value, I want to perform the operation, which I will save that in the result. I can say operation and pass the I. Now, this operation function is dependent upon what you're passing here. So when you pass cube, this will be cube. If you pass square, this will be square. If you pass some other function, let's say add, this will be add. Whatever function you pass. Okay, there's no restriction here, provided that function except one value. Okay, so once you get the result, you can do whatever you want. At this point, I'm just printing it, nothing fancy. Okay, and let's see if that works. Let's clear it, run it, and you can see we got the cube of all the numbers 5, 6, 7. 5 is 125 for sure. 343 looks cool. That's what I remember from my school time. This is a cube of 7. 6 cube never tried, and this should be correct. Why? It will give one wrong answer. But you got the point, right? Whatever operation you want to pass here, if you say square, it will work as a square. So this operation becomes square. And this, my friend, is a higher order function, where you have a function which is accepting a function as a parameter. So that's it. See you in the next part. I think we had enough discussion on function. How do we create it? How do we call it? How do you pass parameters? In fact, we have also seen how do you pass a function to a function. And then I'm saying, let's talk more. So basically, there's a concept called anonymous function. And when I say anonymous function, it's a function without a name. And the question is, why someone will create a function without a name? So let's try it out. So what I'm going to do is I'm going to create a new file. And basically to achieve anonymous function, we use a keyword there called Lambda. So we got this file called Lambda demo. And in this file, I'm going to do one thing. So I want a result for a particular operation. So let's say the operation which I want to do is some function or func as a function. And in this, I'm going to pass a value which is 5. And now what I'm expecting from this function is to return the square of it. And we have talked about square before. So we know the formula, we know the stuff. It's just that I want to make it work. So we have to say result equal to function, or the func is a function which takes the parameter 5 or the value 5, and then it should return. And I'm going to print that stuff here. And I want to remove this space because we are going to write a lot of code. So let's have some space there. So we got this function or func as a function name, and it should work. And the answer is it will not work. So we have to create a function, right? We don't have a choice. So we'll say def func, which will take it's difficult to pronounce func every time. I don't want to mispronounce it. So I will say num, and so let's say that's a fun as a function, and I want to return num into num. Simple stuff. This will work, hopefully. So I'm going to say Python lambda demo.py, enter, and you can see we got 25. Now this is a normal function, but then there are certain scenarios where you want a function, but then that should be in a temporary basis. Maybe you don't want to use that function again. Second, if you only have one expression in a function, then why to create a function which takes 2 lines? Can we just do that in 1 line? I'm not asking you to put something like this. Again, this doesn't look good. I'm not sure if this thing even works. Never tried it. It works, but it doesn't look good. So if you want to do the same thing, there should be a better way. And there is. So what I'm going to do is I'm going to comment this. See, in a function, what is important? You will say name? Not exactly. What is important in a function is the expression or the things which you do inside a function, right? Name can be anything. And also, if you want to pass a value, that particular parameter also becomes important, right? So the value and the expression or whatever operation you're doing, that is important. Then why you are doing in 2 line? You can do that in 1 line, something like this. So let's say I'm going to create a function called fun is equal to, this is how you can create. Okay, first of all, before I talk about it, I want to show you one more thing just to build that or fill that gap in between. We have seen in the higher order function that you can pass a function like square to a function, right? So operate function is taking the square as a parameter, right? So if you can pass a function, you can also assign a function. Example, if I say square equal to fun, will it work? Yes. So fun is a function, but you can assign to a square, which also becomes a function now. And instead of using fun, you can use square. Okay, that perfectly works. And that's the proof. Okay, so you can assign a function. That's what I wanted to show you. But I will go back to fun again. And here, let's say fun is equal to, so I will just comment the above code. And here I want to say fun. Now see, what is important is the parameter and the expression, right? So what you can do is you can say, this is my parameter, and on that parameter, I want to perform some expression and my job is done. Now this expression can be anything, okay? It should return something so that you can, or maybe whatever you want to do basically. Normally we return. So you can say num into num. This is your function, okay? And you will say this is not working. I can see errors. No, basically what you have to do is to make it work, you have to use a keyword called Lambda. Okay, this is called a Lambda function, or you can say anonymous function. Why we are saying anonymous is because this part, we don't have a name to it. Then we are assigning to fun, then you get a name, but by default you don't have a name for it. And in the upcoming videos where we are going to use this, we're not going to assign it to a function. We are directly going to use it. Okay, so you will see that in the upcoming videos. But this is an anonymous function because we don't have a name for it. So this is a function where this is the parameter for the function and this is the expression for the function. And will this work? So let's run this and it works. And trust me, I have saved the file and I'm getting the output. If you still don't trust me, you can try this code by yourself. And if it is not working, it's your mistake. You have done some mistake in the code. I don't want to take the blame of anything. Okay, so this is how it's working, right? If you are still confused what kind of expression you can put here, let's go for one more example. So let's say here I'm going to say result2 is equal to, I'm going to create a add function which will take 2 parameters or 2 arguments, which is 4 and 5. And then here I'm going to print the result. So I will say result2, simple stuff. But then we don't have this function. Now the first thing which will come to your mind is, hey, Naveen, you have to create a function called add, which will take 2 parameters, let's say a and b, and then this is going to return a plus b, right? And then there's no complaint from the IDE. And also, if I run this, there's no complaint. It says it is printing 9, no problem there. But again, we are using 2 lines. Can we do that in 1 line? Let's try. So maybe I can just do that here itself. I can say add equal to Lambda, because that's we know. Now we got 2 parameters, right? So we can say a comma b. So it's not like you can only use 1 parameter. You can use multiple parameters, a comma b, colon, and then just give the expression. No return keyword, nothing, just the expression, and this will work. And that's the proof. Okay, so this, my friend, is Lambda, and this is also anonymous function. See, when you build application, we normally write business logic inside it, right? So based on what is your requirement, you write those codes. And most of the time, we work with data. And in that also, sometimes we work with huge amount of data. And from that data, maybe you want to do some operations like you don't want the entire data, you want to put a filter, and based on that, you want some data. In fact, when you use Excel, you filter based on certain conditions. Then maybe you want to transform that data from one type to some other type, or maybe from one value to other value. Example, let's say if you got an integer, maybe you want to convert that into a float. Maybe you got a string and then you convert that to a number by saying, okay, we got so many words in this string, so that's a number. Maybe you want to convert an image into numbers or text. Of course, with the help of AI, you can do that now. But you got the point, right? So basically, you convert things from one thing to other thing, or you change the value. You got a value, now you want to find the square of it. So you got 5 values, find the square of each value. Now that comes under map. And then maybe you got a lot of values and you want to find a single value out of it, maybe by adding all the values. And that comes under reduce. So we'll try to do that in this video or in the next video, depending upon how long the video becomes. So let's get started. And inside this, we are going to use Lambda, we are going to use higher order function, and we have talked about it already. So let's directly jump to that concept. So I will say filter, map, reduce. This is the file. And in this, we are going to do those things. So the first thing I want to do is, first I want the huge amount of data. Okay, when I say huge, I'm not expecting something very huge. So let's say I got these values in which we have numbers, and out of all these numbers, I want to find the even number. Now, how will you do it? See, there's an imperative way of doing this, or we have a declarative way of doing it. Imperative where you do things by yourself, the entire code. And declarative is you call some function or something which will do the things for you. So in the imperative way, we can use a loop here because I would just want to find the even numbers, right? And I want to put them in a list called evens. So we have one more list which is empty at this point, and I want to put the values there. So I will say for I in nums, from nums I want to find those values, and based on the condition, and now we know the condition of even. So for I mod 2, if it is equal to 0, in that scenario, just add that number in the even. So evens dot append, I'm going to append I. This is how you do it. And of course, at the end, you will print it or whatever you want to do with that evens. So I'm just going to print it here. And let's see what happens. So I will go back here and run this. So I will say Python. The file name is filter map reduce.py, enter, and you can see we got these values. We got 4, 2, 6, 8. Perfect. So this is one way of doing it. The another way of doing it is, instead of using a loop here, I can use an inbuilt function. So there is an inbuilt function called filter which we can use here. So I want to put that in the events list, so we don't have to declare that here. I will just remove it now. So we got events, and I can use a function which is an inbuilt function called filter, and you can see it's inbuilt. You don't get errors there, but this filter will return the filter object. Okay, we'll convert that into list after some time, but let's talk about filter now. Now filter is inbuilt. It takes two things from you. One, it takes a function, and second, it takes a iterable. Iterable basically means something where you can iterate on. Example, this nums is a list, and you can iterate on that list. 4, 2, 9, 7. You got the point, right? So that's iterable. So we can pass a list here. So filter takes two things, a function and a iterable. Now we are very clear about what the iterable will be, which is your nums, which is your list. I'm not sure what the function would be. So if you think logically here, you are trying to do filter, right? Filter will say, okay, my job here, I know it's to filter. But whenever you filter, you put some condition, right? You can't simply ask someone to filter something without telling them based on what you want to filter. And that's what it is asking you for. It says, pass me a function where you mention that logic. Okay, so that means you have to pass a function here. And I'm going to say the function name is even. Okay, now this is not an inbuilt function. This is the function which I'm going to create now. So somewhere here, let me create that function is even. But since we are creating this function or defining it, we'll say def is even. We'll give a colon. Now, is even is a function, but nowhere we have mentioned the parameters it will take. Just visually, it looks like is even is going to take the entire nums as the parameter. See, not exactly. Is even takes only one value. Now, who is responsible to call is even by passing one value? And that's the job of a filter. So when filter calls is even, it will pass only one value. But from where? It will pass that one value from nums, one by one. And that's why it was asking you for the iterable. Okay. So I'm going to pass one value. I mean, that's what filter is going to do. And my job is just to return true or false. Example, let's say if you want to get ready to go to a party, and then when you go to a wardrobe, you will see a lot of clothes there, right? 5 or 6, maybe 100. That's too much. But maybe people do have that much of clothes. I got 5. I can't even lie now. You know, I keep changing my clothes for every few videos. Anyway, the point is, when you look at your wardrobe and when you check which cloth I want to wear. And when you iterate, so those are iterables, right? When you iterate, you say false, 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 true, pick it up, right? That's what you do. So if you say true, it will pick up everything. It's like you're wearing all the clothes, but you're not Joey from Friends. So let's clean that here and run. You can see it is returning the object of filter. Why? Is because we are using filter here, which goes into even, and that's what you're printing. Filter returns the object of filter. What I want is a list from it. So you can simply pass that to a list, which will convert this filter into list. So now let's run this, and you can see we got the entire list here. Why not just even numbers? Is because we are saying true here. If you say false, it will not print any value. You can see it is blank. So based on this condition, it picks up those things. Now I want to actually put the condition here, not true and false. So for this n, I want to check if this is even or odd. If it is even, then that's true. It will pick up the value. And let's see if it works, whatever we are saying. And you can see it is printing the even number. That's cool. Perfect. So this is working. But don't you think instead of using this particular way of doing it, we should be using Lambda here, or anonymous function, because we only got a function which we are going to use here, which takes one parameter, has a expression. So instead of this, I can use Lambda here. So I can say is even equal to, we know how to use Lambda now, which takes one parameter, and this is the expression. So instead of using this, we can use this. And let's see if this works with the new way of doing it, and it works. Okay, so that's why we have learned Lambda first before talking about filter. Okay, but don't you think we are using is even here, so we can directly use Lambda? So I can just cut this and put it here. We don't have to write it outside. And everything is on one line. Now, this is not actually difficult. It's just unfamiliar looking at this for the first time. And that's why you say, okay, we got a list, we got a filter, we got Lambda, and so many things. But if you try to read this, it's very simple. We want a list, and we want to filter the elements. This is the logic, and these are the values from which I want to filter. Much better, right? And that's how you do the filter part. So now let's move towards map and reduce. So we'll start with map. First of all, why we will need map in this example? We can create a problem, right? So sometimes we don't solve the problem, we create them and then solve it. So the problem which we have here is, once I got the even numbers, I want to find the double of it. So something like this. So when we got 4, I want 8. 2 should be 4, 6 should be 12, and 8 should be 16. But this is what I want. And to do that, what I can do is I can say doubles. This is the list I want. And of course, this will return a list. But the function which I'm going to use is map. So before we used filter, because we were filtering, now we have to use map. Even map takes 2 parameters. One is the function, and second are the values on which it will work, or the iterable. So the values are evens, right? No, we are not doing it on nums, we are doing it on evens, because we want to double only those values which are even. But what should be the function here? It's actually simple. You will just say double it. Simple, right? But we don't have this function, so let's create one. So I will just remove all these things now. We know how that works. So let's define a function called double it. Now, how many parameters double it will take? Only one, because we are focusing on one value at a time. So here we'll say n. And what do you mean by double it? It's actually n into 2. So return n into 2. And what it will do is map will take one value from even. It will apply double it, which will double the value, and then add it to the list. Okay, so you got 4 values, you will get 4 output. Just to prove, I will say evens. And let's have one more print. And here we can have doubles. So we'll just clear this and run. So you can see we got all the evens and we got all the doubles. Perfect. So this is working, right? So you can see 4, 8, 2, 4, 6, 12, and 8, 16. But then again, instead of using this syntax, we can use Lambda. So we can directly replace this double it with Lambda, and just be with me. So we'll say Lambda. I hope you're good with this. We get n colon n into 2. Now, once you get used to it, you can write the code, right? So you don't need this thing now. And let's see if this works with that, and it works. So this is how you do filter, this is how you do map. In fact, you can write everything in one place. So you can just take out the entire stuff and replace evens. So that will become one big line, and that will be fun. But anyway, this is how you do it. But now it's time to go for reduce. Now why I need reduce here? Maybe I want to find the sum of all the doubles. So you got 8, 4, 12, 16. So if you want to double it, or if you want to sum it, it should be 40, if I'm not wrong. So 8 plus 12, 20, 4 plus 16, 20, 20. Yeah. So we need output as 40. So in that case, you will say, I want to find a sum of all the values. Now you don't need a list here. You just need a single value. So you will not say list. What you will say is reduce. And in this reduce, you have to again pass two things. But before we do that, you can see reduce, when we wrote it, we now are getting that yellow zigzag stuff. It's because the function is not defined. But then filter was defined, map was defined. Even reduce is defined, but in some other module. So we just have to import that. So I will say from func tools, this is where the reduce stays. So I will say import reduce, and now you can see there's no problem. And we have to pass two things. The second parameter we are sure, which is doubles. What about the first parameter? Now this is a function where you specify what to do with those values. How will you reduce it? In that case, you can say a function called sumIt. Now you can create that function here. So you can say sumIt, right? And you will return. But then how many parameters you are going to accept here? See, logically, when you add two numbers, you need two numbers, right? How will you add one number? And that's why if you try to add this, it will say, okay, 8 plus 4, which is 12, 12 plus 12, 24, 24 plus 16, 40. That's how it will do it. But at one time, it is taking two values. So that means sumIt will take two values, and it is going to add those two values. Simple. And let's see if that works, but we have to also print it. So I will print the total comma sum. And now let's see if this works. Let's run this, and you can see we got evens, you got doubles, and you got 40. Perfect, right? Okay, but then I don't want to use sumIt here. I want to use lambda. So let's try it. So I will say lambda, and we know lambda can take two parameters or multiple parameters. So I will say a comma b, and then a plus b. So we don't need to write this particular function. And that's how, my friend, we use filter, map, and reduce. And that's how you do it. We'll talk about inner function and also how can return a function. I'm not saying returning a value from a function. I'm saying how do you return a function. And let's see that in this video. So let's create a new file, and I'm going to say this as inner.py. Nothing very fancy. And here, let's create a function. So we can say def, and let's say it is outer. So that's my outer function. And let's create a inner function. Now, as a name suggests, inner function means a function inside another function. Something like this. So we got this outer function. And in fact, before we talk about inner function, let me print something here. And I will say in outer function. And then, of course, you have to call it, otherwise this will not work. I mean, it will work, but it will not print it. So let's go back here, and I don't know why I said clear. That's a muscle memory, I think, now. So inner.py, and you can see it says in outer function. Now after this, I'm going to create a inner function. So let's say def inner, and okay, that's an inner function now. And here also let's print something because we love printing things in inner function. So we got a statement inside the outer function. We got a statement inside the inner function. Now in the outer function, we got two parts. One is this statement and one is this function definition. Okay. Now, if I run this, what will be the output? Think about this in your mind, and I'm going to run this now. Let's run this. And it says in outer function. Okay, why it's not calling, or it is not printing in inner function? It's because we are not calling it, right? Nowhere we are calling inner. And if you observe the brightness of the text, outer is a bit bright, inner is a bit fade. It's because we are not calling it. So IDE talks to you by saying, hey, what are you doing? You're not calling it. You should call it. Now, from where we are going to call it? So we are calling outer from outside. Can we call inner from the outside? Let's try. So if I try to call inner from here, your IDE will say, inner is not defined because it's not able to find where inner is. And inner is hiding here inside the outer function. Okay, so that means you can't simply call the function which belongs to some other function directly. And even if you run this, it will give you the same thing. It will say name inner is not defined. Did you mean iter? Okay, you're not that smart, but thanks for guessing, but that's not I was planning to do. I want to call inner itself. So we can't call inner from here, but we can call inner from a scope inside outer, because outer knows about inner, right? So we can say inner and we can do it from here. Let's try now. Let's run this, and you can see it says in outer function and in inner function. So after executing this, we are executing inner, which is calling this function inner, and it is printing in inner function. Our job is done. Okay, this is something you can do. What if I want to call inner from outside? Can we do it? Let's try. In fact, we have tried that before, but this is not working. So this thing is not working. But can we do this? What if the outer returns a function? See, normally when you say outer, outer can return things to you, right? It can return objects, normal values. But can we return a function? Let's try. I will say return inner. I'm not going to call it, because when you say round brackets, I will just comment this part. I don't want to call inner there now. But when you say return inner and when you call it, it will basically execute the inner function. Inner function is not returning anything, right? So you can't return stuff like that. Let me try. There's something crazy which we typed. Okay, so you can see it is calling it, but we are not accepting it. So let's accept that in, let's say, something. And I'm not sure what this something is. I'm going to print this something to see what it prints. I'm curious now. Run, and it says none. Okay, that rhymed, not intentionally. So what we are doing is we are calling inner here, which is calling this inner, which is not returning anything. So it is none, and it returns none from here. But if you return, this was not something I wanted to do, but since we are curious, and yeah, it returns 5. But I don't want to do all those things. I just wanted to return the function as it is. And if you want to return a function, you don't put the round brackets. You simply say inner. In fact, the same thing we have discussed in the higher order function. We are not returning there, but we are passing, right? So when you passed the square, we are not mentioning round brackets there. We are mentioning the function name. Same way, we have to return with a function name, no round brackets there. And now let's see what that something represents. Now that something represents a function which belongs to the outer function, and the function name is inner. Okay, so inner belongs to outer, that's what it's saying. Okay, so that means if I say something and if I give a round brackets, we are calling a something function, but something function does not exist. Still, it calls the inner function, is because we are returning an inner function which is getting assigned to something. So when you're calling something, you're actually calling inner function. Let me repeat. It might be confusing if you're doing it for the first time. And please type this code. Don't trust me. Write this code and see how it works. Then it will make much more sense. So basically, when you return inner from outer, it returns a function. Now that function goes to something. Now something also becomes a function. And when you call something, it basically calls the inner definition, right? Which says in inner function, if that makes sense. Okay, but can you pass a value? So let's say if I want to pass a value, let's say 5 here, then of course you have to accept it here, because ultimately something is calling inner. So when you call something, it is calling inner. So we have to accept that here. And then if you want, you can also print it. So let's try, and it works. You can see it says in inner function 5. So that's inner function for you. Now, why we are talking about inner function? Normally, we don't use this that much in the actual project. Sometimes we use it when you want to restrict a particular function for a function. So let's say inner, I'm restricting it only for the outer function. So when someone wants to use outer need to do some processing, and that's where you need a function inside. That makes sense. We are going to talk about decorators as well, and this is used in decorators, and that's why we are going in that flow now. And yeah, that's how we use inner function. So we have talked about 2 things. How do you define inner function, and how do you return a function? And it's not like you can only return the inner function. You can return any function which you want. And I think we have done that in the higher order function. Let me just see. We are not doing it here, but you got the point. And now it's time to focus on decorators. So we have talked about inner functions, and we are going to use this inner function in the decorator, and that's why I kept this open. But now it's time to talk about decorators, and I will say deco.py, which is py. So now let's create the decorator. And before we do that, let's understand why we are doing this. So let's say we have this particular function here, which is called a divide. And of course, we know if you want to divide 2 numbers, we have to pass them. and then we'll return here a/b. That's how you divide two numbers. And now, of course, you have to call this, so we'll save that in a result. So we'll say divide, and we'll pass two values here, which is 4, 2, so that we'll get an easy answer to interpret. And we'll say result. And now let's go back here to run this. I will say python deco.py. And you can see we got the answer, which is 2.0. Nothing much. We just wrote a simple function, calling it, printing the result. And now I want to add a twist here. The twist is, let's say if I pass a value which is 2, 4. Now in this scenario, of course, you know, it will print 0.5. So when you run this, it will print 0.5 because it will, the numerator, which is 2, will be divided by a denominator, which is 4. And that's what you will get. What I want is, I want it to divide the bigger number by a smaller number. So it doesn't matter what input I give. Is it 4, 2 or 2, 4? It should be always 4 divided by 2. If you want to do that, what is the logic? So of course you will say go to divide and check if the first value is less than the second value. In that scenario, just swap it. Your job is done, right? Swapping will be done something like this. You can say a, b, and a, b is equal to b, a. That's how you do the swapping. And this operation will be bigger number divided by the smaller number. Doesn't matter what number you pass here. So if I make those changes, it will work. So problem solved, right? We can end the video here without decorators. But no, we need to talk about decorators. And to do that, to make that sense, let's create one more function called sub, which is for the subtraction. We'll do the same thing, which will take two parameters. It will return a minus b, right? And then we'll call it. So we'll change this to result 1. And let's have the same thing for result 2 now. And this will be result 2. This will be 2. And this will be sub, right? This is what we want. But then when you run this, it will print 2.0 because we have done those swapping there in the division. But in the subtraction, it is saying -2. And it will say -2 because you're passing 2 and 4. But I'm greedy. What I want is, doesn't matter what value you pass, the bigger number will be subtracted by the smaller number. Then you will say, it's so simple. You can just copy this and paste it here. Your job will be done. And you can see it's always the bigger number first and then the smaller number. Doesn't matter, is it sub or divide. But now, if you observe, this thing is common, right? So I want to remove this common thing and keep it somewhere else, and then specify somewhere by saying use that feature, okay? And how do you do it? And that's where we can use something called a decorator. So what we can do is we can create a decorator called greater first. This is your decorator. At this point, I will just write past there so that I don't want to define anything here. And it should not show the error anywhere. So we are creating a decorator called greater first, and yeah, that's how you create it. So you create a function and that becomes a decorator. And if you want to use that, instead of using this logic here, which I will remove now, on top of this method, the way you can use decorator is with the help of @ symbol. And you are going to see this a lot once you start using some frameworks in Python, where if you want to use those features, you use decorator and you say, okay, this is @ that particular feature. Okay, and you can do that on both the methods. You can say greater first. But then we are not doing anything in the greater first. So if you try this code, first of all, it says greater first takes 0 positional arguments, but 1 was given. That's this, which you are giving. So normally what happens is this decorator will take this function as an argument. So of course you have to pass this function so that it will not shout at you now. Let's run. And it says none type object is not callable. Okay, this need to return something. So I will say return. Okay, now let's type the code for the decorator because then it will just making the thing work, which will not work anyway. So let's do the thing now before you run this. So how do you build a decorator? Now, when you want to build a decorator, you need to return. So you can see it is expecting some return type, not the none type, right? It is returning some callable type. Now what you return is, so basically decorator takes the function, it returns the same function. Let me repeat. Decorator takes that function as a parameter and it also returns the same function as a parameter, but with some modification, whatever you want to do. So you will take that and you have to also return it, right? Now you can't simply return function. I mean, you can, but then you're not achieving anything here. So you can see you are taking that function, you're returning the same function and you got this value, default behavior. And this is where this block now, this empty space is where you have to write the logic. And to change the behavior of this function, you can create an inner function. And that's why we looked at inner function before talking about decorators. So we got the outer function, let's create inner. So we'll say def and let's create inner function. Normally you can use any name for that. You can say inner, but normally we use wrap because we are changing the behavior of it or wrapping the behavior. And this particular wrap will have the same parameter as the methods which you are going to change or the function which you're going to change. So we'll say a comma b. And then you can do stuff here. Now what stuff I want to do? The same thing which we have done earlier. Check if a is less than b, then swap the value for a and b. That's how you do it. And then you are returning this function, but I want to call this function. I want to change the behavior of it. So here you will say return. In fact, this is where you are not supposed to return the same function. You will return the wrap, and here you will return the function with a new value, which is a comma b. Now why I'm saying new values? It can be same values if they are provided in the sequence which is needed. Like if you pass 4 comma 2, it will just pass the same parameter. But if you pass 2 comma 4, it will pass 4 comma 2. Okay, this is how you create a decorator. Okay, and now let's see if this thing works the way we want. Run, and you can see it worked the way we want. It's 2 and 2. But how it is working? Let's understand that. And to understand that, I will not be using decorator like this. I'm going to use a different syntax here. So what I'm going to do is I'm going to change the behavior of sub. So I will take sub and then assign it with a greater first and pass this sub here. Okay, so what we are doing is we are taking this sub function, applying a decorator and returning the same function but with a different behavior, with a wrapper around it. Now this sub is accepted as a func here, which is as a function. And then when you call this, this will return a wrap. But then where are we calling wrap? This is where, so when you call sub or divide, this is where you are calling it. Okay, so when you call this, you're calling this wrap function by passing these two values, and based on your condition, you will do something here, and then you're calling the same function. Okay, so whatever function you call, you're passing here, you're calling the same function which will execute and return the value. That's the behavior of wrap. And yeah, but we'll do the same thing for divide. So we'll say divide is equal to greater first and will pass divide. This is the one way of doing it, and the second way of which we have done before, which is the @ Run this and it works. So you can use this way or that way. Modern way is this: you use the decorator on top of your methods to add the behavior or add the wrapper, and this is not needed then. So we can simply comment that. So let's see, after making those modifications, it still works. Now this is one of the examples. But then you can do certain more things. So when you say you can use decorator, it's not just for swapping two numbers, whatever logic you want to have. Maybe you want to maintain the log. How will you do that? So let's create one more decorator for the log. So we'll say log deco, and this is your another decorator. And when you say decorator, of course it will take a function. Of course it will have an inner function which is wrap. Name can be anything, but let's say wrap a comma b. And here let's maintain the log. So I will print what are the values you are receiving. So I can say values. I'm receiving a. I will give a comma and some space in between, and then b. You can also use formatter if you're comfortable with it. So you're printing the value. Maybe you also want to print the function name, your choice. Then I want to also know what is the result. So you can say result of this operation. So you will call the function by passing two values, and you can also print the result. Okay, why I'm getting error here? Oh, I forgot a comma here. So you can also print the result of the operation. So you can say result comma result. And since you already found the result, you can return the same result. Why to call the functions two times? Right, you're printing the result here or returning the result here, and at the end you will return the wrap, and this will maintain the log. Now after doing that, it should print the log in the console. It's not doing it. You know why? Because we are not using that decorator. So on top of your functions, you will say log deco, and if you do it only for the sub, it will work only for the sub. So this thing which you're getting here is for the sub. But if you do it for the divide now, and let's use some different values. How will you know that which is for sub, which is for divide? Let's say 8 and let's say 20. That's for the divide. And now you can see this thing is for the divide because that's a function you're calling first. You got value 8 and 20. This is the result, and you're printing the result later as well here. And then this for the sub, and this is the result, and this is what you're printing here. Normally, when you want to maintain the log, you don't do it on the console. Basically, do that in the file. Okay, now let's create one more function and let's see how that behaves. So let's say def add, and this will take two parameters a comma b, and this will going to return a plus b. And of course, we can call it here. We can say result 3 and add, which will take two values. Let's say I want to add 4 comma 7, and this will we have to also print this, and we are going to print result 3. Let's clear this and run. So you can see the last output is for the add, but then it is not doing any greater first because we don't want to check that for the add. The greater first works for the divide and sub, not for the add, but I want to maintain log for it. So you can specify which particular decorator you want. So we can say log deco, clear and run. And you can see this is for the add. Okay, these are the two values. This is the result and you're printing it here. So logging is working there. But what if we pass 3 values? So you will say plus C. And also, when you call this, you will add 3 values, let's say 5, 7, 6. Will this work now? You know why I think it will not work is because you got the definition with 3 values, but in the wrap, you are taking only 2. Let's see what it says. Run, and it is giving you an error. It says, you're calling this function wrap, which takes 2 positional parameter, but you're giving 3. Now, how will you make this work? So do you have to create a different decorator for 3 values? Then what about 5 values? What about 10 values? Now, I think we are coming back to the same problem, which was variable length arguments, and I'm not able to find the file of it here. Yeah, this one. So if you remember, when we talked about the variable length arguments here, when you pass multiple values, and if you want to accept all, so instead of using a comma b, can I simply say star args? Our job is done, right? Doesn't matter how many values you have, it will accept everything. And here, instead of printing a comma b, you can print args. And when you call the function, just pass the same args. Why to pass a and b, right? And let's try that. And it works. You can see, doesn't matter how many value you pass, it will treat them as a tuple, right? So this is how normally you define a decorator. We should be doing that same here, but then we have to change a lot of logic. I don't want to change it. I mean, I would encourage you to do that. Okay, so you do it. Make this as a variable argument and make this logic. Okay, but then before I end this video, I want to add one more thing. What if you pass a keyword length argument? You're passing 3 values, but all are normal values. But what if you pass with a key? Now, if you pass a keyword there, then this will not work. In that case, on the safer side, you can write something like this, which will accept normal values and also keyword values. Anyway, you're not going to use it, but still, why not? Just keep it there so that this will be generic for all the other functions. Doesn't matter how many parameters they accept. They are working with normal parameters or keyword parameters. It will work for everything. That's the end of decorator, and it's still working. These are decorators, the log deco and greater first. Now let's talk about modules and packages. Now if you look at the left side of the screen, you will see a lot of files there. And it's good that we have written so many files, and in the normal project, we do that. Okay, so you will say, hey, we don't have to do everything in different files. We can do that in one files. Yes, you can. So let's say if you're building a e-commerce application, maybe your own Amazon, and now you thought, okay, let me put all the features. Now, when I say features, what it means, so let's say you're working with the product. You are adding the products, you are deleting the products, you're updating the products, whatever you do with the products, whatever you do with the users, because you have to also get users on board. So adding user, deleting user, user is buying something, so you have to maintain those records as well. And for that, you'll write some functions. And you got all these functions in one file. Is it possible? Of course, you can just pick up any file from here. I'll pick up this demo.py. Okay, we don't have a lot of code here, but imagine all the functions of e-commerce are in this file. It may be 12,000 lines of code, and it's beautiful, right? You will just keep scrolling and you will see all the codes. You will be happy, but not your server. Okay, and also not your users, because maybe it will work. Maybe everything is working fine. And in future, if you want to make some changes, maybe fixing some bug, you will start searching for the function which you have to update. And then you will say, hey, Naveen, we got this amazing feature on the keyboard called Control F or Command F, using which you can search a particular function. Yes, you can. But do you want to really make that messy thing in one place and then keep searching for it, keep managing it? So that's not a good idea, right? And that's why we create different files. So different features in different files. Let's say if you're working with the product, you will have a product.py file where you will have all the features of the product. Maybe you will have users. So you'll be having a user.py file where you have all the users in functions. You got the point, right? So different feature needs different files. Now these files where you're not going to run them individually, why you will run the product.py file individually? It's just functions to work with the products. Now this kind of files where you just have functions but you don't execute them are called modules. But then you will say why you will create a file with the functions which you will not execute. I'll show you something. So what I will do is I will create a new file. So we'll talk about modules, don't worry. But before that, I want to talk about packages. See, everything is in one place and it looks beautiful in some sense, you can flex it, but then logically, all these files should be grouped in one particular folder. Not all, but let's say if I'm talking about factorial here, this should be part of one particular folder. Okay, and then maybe I can put recursion, factorial, in fact, recursion in the same folder. Maybe I can put higher order function in one particular folder, right? It is easier to manage then, right? So, and we have not created folder yet. So let's create one. So how do you create a package? So that folder is called packages. Okay, so if it is a Python file, it's a package. But we create a folder to create a package. So let's click here and I will name this as a calculator package where you will have everything related to calculator. So that's my package. Now in this package, I'm going to create a file. So this is a file and I will name this file as calc.py. Now this looks like a normal file, but I will call this as a module. Why? Let me show you. So let me get a function here, which is add. And in this, I'm going to just return a string by saying addition. I'm not going to write the actual logic because that's not the main reason for this video. This video is about having some functions. It doesn't matter is it add or any complex logic. What's important is we are creating a function inside a file and I'm not calling it. This is just a function so that someone else can use it. And when you build something like this where someone else is going to use this is your module, okay? So this file, which is calc.py, is your module. But then where we are going to use it? In this particular package, I'm going to create a new file called demo.py, and this is where I'm going to use it. Mind you, both the files, the calc.py and demo.py, are in the same package. Okay, and with that in mind, let me write the code now. What I'm going to do is I'm going to create a result variable in which I'm going to save the data coming from add function. Okay, and then at the end, I'm going to print that result. And now you will say, where is the add function? It's not in this file. And that's what your IDE is also saying. Hey, you know what you're doing? Add is not defined anywhere. And then you will be saying, I'm a developer. I know I've created that file or that function inside calc.py. Why you're not able to find it? And they'll say, you're so dumb, Python. Why you're not able to find this file add or this function add in calc.py? If you think Python is dumb, think in this way. So let's say Python is smart. Python says, okay, you just write the function name. I will search all the files and I will find add. If Python is able to do that, and it's not a complex thing to search a function in a file, the problem is, what if you got more add functions in some other file? Maybe you're adding a user and that function name is also add. Maybe you are adding a product. Even that function name is add. Which add you're referring to? Is it calc? Is it product? Is it user? Okay, and then you will mess up everything. And that's why Python says, let me not search about it. You do it. Okay, you specify which module you're talking about. So how do you mention the module? So then you can say, before add, you can say, hey, I'm talking about calc. Now it will say, okay, I should be able to find add, but I'm not able to find calc itself. So calc is a module which you have here, which is calc.py, right? This is a file. And you don't mention .py, you just mention the name of the module, which is calc, without extension. And then it should be able to find. But it says, no, I'm not able to find it. Then what you do is you mention import calc. Now why it is not able to find it without this statement? Because calc can be an object as well. Calc can be a variable as well. So you have to be very specific that, hey, that's a module. And now you can see it says module calc. So you have to import calc and then you can do it. Now let's try. So I will just say Python and demo.py, and if I say enter, okay, now there is a problem. The problem is demo.py is here and demo.py is here, and when I ran it, demo.py, it is running, I think, this particular code, which is enter a character. Okay, no problem. I will just close this. So let's clear this confusion. The problem is, if you look at your path, you are in the root directory of the folder. So this is the first project. You can see this is the root directory. This demo.py is inside a calculator package, and for PowerShell or for your terminal, it's into a folder called calculator. So first step is go to that folder. So you have to go to calculator, and now if you say ls, it will list the files. So you can see we got demo.py, we got calc.py. Now you can run this and you can see it says addition. Okay, so now you're able to find add, which is in the calc. Now calc here is a module in which you have this function called add, and you can call it in some other file provided you say import calc and then you say calc.add. Okay, but then let's say calc has more functions here. So let's say def, we have also got sub here, which is for subtraction, and then you are returning here subtraction. Now in this case, what will happen is you are able to call add, but let's say if you call sub, will this work? Yes, it will, because it belongs to calc. And now if you run this, it will say subtraction. But here's a problem, not the actual problem, but as a developer, we are greedy. Why I have to mention calc everywhere? I'm lazy. So in that scenario, what you can do is instead of using import calc, what you can do is you can say from calc import sub. Now what will happen is you don't have to mention calc. You can simply say sub because you are importing a function as it is. So now you can call sub, there's no problem. You don't have to mention calc there, run, and it works. But will it work for add? And the answer is no. You can see you are getting an error. You know why? It's because we are saying from calc import sub. Nowhere we are saying add, and add is feeling bad about it. So what you will do is you will say, you give a comma and say add, and it works. You can see there's no problem here. Let's clear this out and run. Now it says addition. So whichever function you want to import, just mention those functions here. But if you say, hey, I want to import all the functions, then you have to use a wildcard, which is your star, by saying get all. Okay, and then it should work. But I want to add a twist here. The twist is, let me go to the demo of which we created before and which is outside this package calculator. Let's write the same code here. So delete this code, copy this demo code here. Okay, whatever file you have, not just demo, if you have some other file, copy there. And close this demo, or maybe you can just keep it open. You can see it says two problems in the file. The problem is it's not able to find calc. Now that's weird. This demo, which was in the package, was able to find calc. And logically, it should be able to find that because it's on the same package. The demo, which is here, it's outside the package. It has no idea where to find calc. Then you can say, hey, you know, that calc belonged to a calculator package. And that's why you have to use the package name dot the module name. Now, no problem. Let's run this and it works. I'm running the wrong file. Okay, example, if I come back here in the demo and say result in the double quotes and give a comma here. And now if you run this, it will still say addition, is because we are still running this file. We have to run this file. How will you run this file? Just go back to the root directory. So say cd dot dot, depending upon which OS you are working with. And now run that file and it says result addition. Simple, right? So yeah, that's about this code where we talked about module and packages. We are going to use modules a lot in the upcoming sessions, so you will get used to it. We'll talk about a special variable called name. In fact, it's underscore underscore name, then underscore underscore. Okay, now maybe you have seen this before. In fact, we have seen this before, but I don't think you will remember that. It's been a long time anyway. So what I will do is I will just comment both the code here from demo and calc. We are still using in that package of calculator. And now I want to show you something. So I'm in demo and let me print. Remember we talked about something called globals, which prints all the global variable for a file. And let's do that. So I will just run this. And before I do that, I need to move to the calculator folder. And once I'm there, I can just run this python demo.py. And this is going to print all the global values. So it is printing the name. This is what we are going to use. Apart from this, there are other things as well. But I'm more concerned about this particular variable here, which is name. So instead of printing globals, we can just print name variable and let's see what it prints. So I will just clear it, run, and you can see it prints main. Okay, so that means whenever you try to print name, the default value for that would be main, right? Okay, let's do the same thing in the calculator and let's do that now. So let's run. Okay, we're still running demo, my bad. I will just run the calc and even that is printing main. That means whenever you run a file, the default value for name is main. Okay, now let me go back to demo and let's import calc. Now what will happen is whenever you try to import a particular module, it will import all the things from the module. It will also execute the statements inside the module. So this statement is in calc, and in demo we are importing it and we are printing here as well. So that means it is going to print two statements, one this and one this one. So to differentiate, I will write here in calc and let's print the name. The same thing I'm going to do in demo, and I will say in demo and let me give a comma here. Okay, and now let's run this. So I'm going to run the calc first, and in calc we are not importing some other module, so only this particular part is going to run. So we are running it. It says in calc and then it prints main. Let's run the demo now, and when you do that, look at the output. The second statement is in demo main, and that makes sense because that's what you are printing. But what about this first statement? We are not printing it here. We are doing that in the calc, and as I mentioned before, it will execute that part. It says in calc. That's weird because when we ran calc, it was printing main, but now it is printing calc. So what is this? So the idea is whenever you run a file, so let's say if you run the calc.py file, just this file, this becomes your main file. And that's why the name is by default main. Okay. But when you import the file or the module in some other file, now when you try to print this name there, it will print the name of the module, which is calc in this case. So without the extension.py, that's your module. Okay, so things to remember, whenever you run demo, which is a file where you're printing name, it will print main, but the module in which you're printing name, it will print the module name. But when you run the calc as it is as a file, it will print it as a main. So whichever file you're running, that file variable, name variable, would be main. Now the question is why this is important, why we are even talking about it. So let's try to understand that with an example. I'm going to comment this, I'm going to comment this, I'm not going to use this anymore now. Let's go to calc and uncomment this part. So we got two functions here, and the idea of this making this module was to use it in the demo. But now because see, if you just execute calc now, it's not going to print anything because we are just defining these two functions, we are not calling anything. So here, let me call them. So I will call add, I will call sub. Okay, and now if I run this, okay, so I don't know why I'm assuming that I'm printing things here. So I should be printing it here. So print whatever add returns and print and whatever sub returns. So let's clear this and run. It says addition and subtraction, and that perfectly makes sense because we are calling them, we are printing whatever value they return. Now let me go back to demo. Inside demo, we did this thing before, so I will just uncomment that and comment the import part at this point. So we are using this particular statement for the importing, and I'm calling add, it is printing result. So what do you think should happen if I run this file and it should print result, which is addition. In fact, when I print result here, I would say in demo, and then I'm going to print result. So it should print in demo, and whatever value addition returns or add returns, which is addition, so it should print in demo addition. That's what I'm expecting. But we have discussed that whenever you import a module, it is going to execute these statements as well. So that means it's going to execute these functions. I mean, it is going to execute this statement for creating a function. It is also going to execute these two things as well. And that's why if you see the output, it will print addition, subtraction, and in demo addition. It's because we are writing this statement. So what should I do? Should I remove this statement? If I remove this statement, then there will not be an issue. So if I run demo, it's not going to print it. But then if I call calc, it's not going to print anything. But I want it to print those things when I call calc. So we have a deadlock here. Should I comment it or uncomment it? And that's where we can be a bit smart. Now how we can be smart here? We can write this particular thing, which is if name is equal to main, then only execute this statement. Okay, now what it will do is, let's try. Okay, I will show you first the output, then we'll talk about it. So let me clear it and run calc. We are getting addition, subtraction, but when I run demo, we're not getting it. So problem solved. So how it is working? See, we know whenever you run calc, the value for name would be main. It is matching, it will execute. But when you run demo, where you are importing a module, at that point, then the value for this name will not be main, it will be calc. not matching, don't execute. And that's how it works. And you are going to see that multiple times. Okay, so whenever you see name is equal to main, so the intention was if this is a main file, then only execute this part. Otherwise, use everything here as a module functions in some other file, maybe function classes or anything, which we'll see later, but you got the point. So this is how the special variable name works, and we are going to use it later. See you in the next point. So we have talked about functions a lot, and now it's moved towards up. So basically whatever we have discussed now is functional programming. So when we talk about functions, we have seen we can create functions, we can call them, of course that's normal, but then as a function, it can accept different parameters. We can pass numbers, we can pass objects, but what about functions? We have seen we can pass function to a function as a parameter. We have seen we can create a function inside a function. We have seen a function can return a function. But then all this thing comes under functional programming, right? Where function becomes a first class citizens. On the other hand, we also have a concept of object-oriented programming. And you might have guessed it right. In object-oriented programming, the most important thing is object. So whenever you build application, if functions comes to your mind first, that means your mind is still into functional programming. And if you think about objects, your mind is more towards object oriented. And the beauty is Python supports both. It supports functional programming, it supports object oriented programming. But then when we can do everything with functional programming, why do we need object oriented? See, think about this. When you build applications for real life, you're trying to solve a real life issues. And whenever you try to solve real life issues, you have to understand in real life we use everything as an object. So to solve any problem, we think about an object. Example, if I want to call someone, I need a phone. If you want to control your AC, you need a AC remote. If you want to record something, your voice, you need a mic. If you want to capture yourself, you need a camera, right? So all these things are objects. Now, if you are trying to solve real life problems where we use objects, don't you think in the virtual world where you're trying to build these applications, even at that place you need objects? And that's what you get in object-oriented programming. So whenever you want to solve a problem, the first thing which should come to your mind is object. Now that's about object-oriented, but you can also do certain things with functional programming. Both have different reasons to use. Now in object-oriented, whenever you want to represent something, that representation will be done with the help of object. Example, let's say, if I want to represent users, or if I want to represent employees, if you want to represent a human, or maybe some physical things, let's say camera or all the gadgets you have. Now, this thing in the virtual world can be represented with the help of object itself. Example, if we talk about an employee will have a name, an employee will have its designation, salary, location, home location. So all these things are the parameters for a particular employee. And also, employee has a behavior. They work, they chit chat, they gossip, they have tea. So those are the behaviors, right? Now, if you're trying to merge this, you can put everything in an object. So object has two things. Object knows something and object does something. Example, if you talk about this remote, this is a kind of remote for the light controls, but this remote has some properties, right? It's white in color. This is the size of it. It got multiple buttons here. And then it has a behavior. I can control the background lights like this. It's not able to control now. So you can see those lights can be controlled with this. This is a behavior of it. So this is an object, right? So object knows something and object does something. Now, question arises, how will you create the object? Of course, if you want to manufacture the objects, it can be a phone, it can be this kind of remotes, you have to go to a factory, right? So let's say if you go to a factory where you know they make remotes, and you go there by saying, hey, I got this new device and I want you to build the remote for this. Now they will need one thing, which is a blueprint for the remote. Okay, so without blueprint, they can't make a remote. So even if you tell them, hey, I want a remote, they want to know what exactly you want. What are the properties of the remote? What a remote can do. So you have to mention the properties and a behavior. And you can do that in that blueprint. And that blueprint is called a class. So you have to provide a class to them and they will give you the object. In the same way, if we talk about Python or any other programming language, where you can do object-oriented programming, you basically create a class which acts like a blueprint, and whatever the runtime of that particular language is, like Python, it will create objects for you. provided you give the class to them. So you give the class, they will give you the object. And not just one object. For a particular class, you can create multiple objects. And as your class changes, let's say when you got one class for the remote, you got one class for the phone, and when you give a phone class to them, they basically create the object for the phone. And not just one phone, you can have multiple phones, right? So if you want the object, you have to first create a class which acts like a blueprint. Now this class will have two things, as we discussed before. A class will have properties and a class will have a behavior. Now how do you give these properties? And that's where you can use variables. And we have talked about variables before, right? So example, if you get a class called remote, now you have to give some property, the height of this remote, the width of it, the color you want, how many buttons you need here, the size of the buttons, everything. And then you specify the behavior. Now behavior can be mentioned with the help of functions. Example, every time you click a particular button, what should happen, right? How this particular light emitter here will send the signals, right? So all these things will be done with the help of those functions. So if you want to define the properties, you will do that with the help of variables. And if you want to define the behavior, you do that with the help of functions, and you put everything in a class. Now we have a special name for these functions. So in object-oriented programming, we don't call them as functions, we call them as methods. Okay, so now if I say what is there in the class, a class will have variables and a class will have methods. But methods are functions. So you know how to get a function, you will know how to create a method. And object-oriented programming is not just limited to class and object. There are multiple things you can do in object-oriented programming, and I don't want to reveal the surprise here. Let's see those things one by one. So we'll start slow. We'll start with class, object, and then we'll move towards those concepts. And should we only focus on object-oriented programming, not functional programming? Not exactly. So in every application, you will need both, where for certain things, to represent certain things, you will need object-oriented programming. For some processing, you will need functional programming. So we'll do both. And yeah, that's about object-oriented programming. See you in the next part. So once we have talked about object-oriented programming, let's get started with the code. Now we know the most important thing in object-oriented programming is an object. And we also know if you want to create the object, you need a class. Now that class will act like a blueprint for whoever creates the object. Okay, so let's do that. But then before that, if you look at the left-hand side of the screen, there are so many things, so many files there. And even I'm getting confused which file consists what. So ideally, you should always create packages and put those things there so that you will know in which package you have which files. So at this point, I will just minimize this calculator, and we got all these extra files. I will just put all the files, and I will just say cut, create a new package, and I will say these are basics, put it there, and minimize this. Now we have two different packages. We know this was supposed to be for calculator. We got only two files there, and these are the basics, right? Now let's create a new package. In fact, I'm going to close this. Let's create a new package, and I will say this is OOP because we are focusing on object-oriented programming now. So I'll just expand this, and in this, in fact, we don't have any files there. I don't know why I expanded it. Let's create a particular file here, and we'll name this file as usual, demo.py, because that's what we're doing. We are seeing the demos. So what exactly we are going to do here? And as we discussed, we are going to create the object. I want to create the object of a computer, and I'm going to name it as comp1. Now, first of all, it's just a reference to the object. So whatever object you're going to create, you can assign it to comp1, just like we did for the variables. Example, let's say if I just comment this part and come back down, and if I say a is equal to 18, now that's a value. This is a integer object, and what you got here is a variable to assign it to, or just reference it to. Now, before you and I jump to comp1, I want to show you one more thing. What happens when I try to print the type of A? First of all, we are not printing it, so let me just print it somewhere, and here itself on the console. And when I say type A and I'm going to print it, let's see what it returns. And before I do that, I have to first move to my folder, which is OOP. And now let's run demo.py, run, and you can see we got the output and it says class int. This is something you have to remember. So this is of type class integer. Okay. This we know. I'm trying to get your attention for this class here. So everything which we did till now, they are objects. Whenever you create functions as well, they are called function objects. So this int is of type it's an object of type class int, and all these objects are getting created with the help of class. Okay, so this is an object here, and the type of this object is int. So we can expand this more, where I'm trying to access some methods. Now, since we have an object, of course it will have methods, right? We have talked about that. So I can say a dot, and you can see we got multiple methods here. We can take care of any method here. Let's go for bit length, and doesn't matter what it does. What's important is, if you see the implementation for this is bit length. That's a function or a method because it belongs to a class. So this is how you create a class. So you create a class, you name it, and of course you have to use this keyword class, and then you have to use some name, give a colon, and inside this you can define your functions, which we call methods, and that's how you do it. So one of the methods which we are focusing now is bit length. So how do you define a method? You say def, then you mention the method name, and in bracket you pass self. We'll talk about this self in some time. Okay, let's go back here and see that. So I'm not going to use this, I just wanted to show you. So this is the object which I'm going to create, but if I uncomment it, it has no idea. How do you create an object? If it is a type int, you can simply say 10. Now this comp1, if you say type of comp1, it will be integer, class int to be specific. But I don't want class int, I want a class computer. So how do we do it? So first of all, we don't have inbuilt class called computer, so we have to create one. So if you don't have any class inbuilt, you can create. So let me get a class, and this is how you do it. We have seen that. Okay, so class, then you have to give a class name. I'm going to give a class name as computer itself, and then we have seen we have to give a colon. The same way we do it for the functions, right? We say def function name and round brackets, and then give a colon. Same way we have to give a colon here. Now in this class you can have your things. Now when I say your things, what do I mean by it? Every class will have two things, or it can have two things. One, it will have properties, and second, it will have methods. Now the properties are your variables, and the methods are your behaviors, right? Okay, so at this point I want to keep it empty, so I will simply say pass and then come back here. Now you got comp1. I want to create an object of a computer and assign it to comp1. How do we do it? So you simply say computer, but then if you simply say computer, let's see what happens. I'm going to say type, okay, I'm going to say print type, and I will say comp1 here, and let's see what is the output. So I'm just curious, I will just clear the screen first, run, and for the second one, for this int, it says class int. But for this, it says class type. No, this is not class type, it should be class computer. So what is happening is, what you are doing here with the comp1, you are assigning a class itself. You're not creating an object. This is not how you create the object. You're just assigning a class. The same way we have done for the functions. You know, we can define a function and we can assign that function to something else. Example, let's say if I say function ABC, that's my function, and you can do whatever you want. I'm just saying pass here. And then you can create another variable which is xyz, and then you can assign ABC here. Now, you're not calling this function, right? You're just assigning this function to some other function. So even xyz becomes a function. Same way, comp1 becomes a class. We don't want to do that. We want to create an object. To do that, we have to use round brackets here. Again, what are these round brackets? Just to give you a hint, basically this is a constructor. It creates an object for you. What is constructor? We'll talk about that later. At this point, this creates an object. That's important. Now you will say, I don't trust you. No problem. Don't trust me. Trust the code. Look here. Now look at what it says. It says class of type computer. So it's in the module called main, and you got computer. Perfect. So now, if you can create the object, and I'm also trying to print the type of it, so we know it's an object. But what values you can have in the object, and what else you can do with the object? Let's do simple stuff first. Let's define a method. We have talked about it, right? You can create a method which acts like a behavior. Now, when you say a computer, maybe you want to print the configuration of a computer. That's what normally we do, right? So when you want to buy a computer, the most important thing for the computer is the configuration, not the color, not the brand. So it should be, let's say, i5, 16 GB RAM, or maybe i7, 16 GB RAM, 1 TB hard drive. Those are the configuration I'm looking for, not a fancy blue color laptop I mean, I do have it, but that's not what I wanted. I just wanted a configuration and then whatever laptop works. So here I will say def and I will say config. That's how you create a method. And then you will say, hey, that's function. Yes, that's function. When you create a function inside your class, that becomes a method. Okay, so this is your method. Treat it with respect. So when you say def config, and here I can just print it. So I can print, let's say, the configuration, which is i7. I will say 16 GB RAM. I will say GB capital, and then 1 TB of hard drive. Now this is how you create a method. Okay. Now a method will take one more thing. I don't know why my IDE is not suggesting it, but it should. You have to pass self. Now what is this self? You will understand that in some time, but we have to do that. And it's not self. You can use any other variable name your wish, but then self is globally accepted. Okay, so everyone, when you show your code to another Python programmer, they will know this is your self. Okay, so they will know it. Okay, so now question arises. I got everything ready. I will just put all these things at the bottom because that's not our main concern now. In fact, if you want, you can delete this. That's not the concern we had. We're just going to focus on this part now. So once you have the object, once you got the method, the question is, how will you call this method? First thing first, for time being, I will remove self. Okay, let's go with the flow. I got the class, I got the method. I will just come back here and I say, I want to call this method called config. Your IDE will not be happy with it. IDE will say, config is not defined. What you doing? How can you call a method which is not there, or function which is not there? You will say, hey, the function is there. Can't you say it? Actually, Python cannot say it. It's because it's inside a class. So you can solve with this problem by saying, okay, go to computer. You will find config. There's no problem now. Let's try running it. And you got it. Our job is done. We can stop the video. But if you observe the video, we still have a few more minutes. That means the video is not done. Okay, what is going wrong here? Nothing is wrong. We got a class. We are getting a method. We are calling the method. Everything works. But this is not how you create a method. You always pass self here. Again, we have not talked about why self, but we'll talk in some time. So we pass self and then you try to call it. Now it's not working. And then you're saying, or in your mind, you're saying, it was working before. Why you are spoiling the fun by adding a self there? See, the thing is, in the object-oriented programming, everything is an object, right? So when you create this comp1, that's an object. Don't you think that object need to be referred here? Now you will say, why? Why we need to refer an object here? It's because when you say computer config, and when you're calling it, don't you think a computer can have multiple objects, not just one? So example, in this particular table, which I have two tables here, one laptop can be here. One laptop can be there, one for recording this video, one for practicing there. So we got two laptops, right? And if I try to damage one laptop, okay, I don't want to do it. Why are you even talking about laptop? I don't want to damage my laptop. This is cheaper. Okay, so let's say we got this remote, using which you can control these lights. If you can see, I don't know. Yeah. So you can control this light. So it has a behavior, it has a property. So it is white in color. It has few buttons there. It has a behavior. You can control the lights, right? Now in this particular studio, you can see we got, actually there are three lights. One is not working, but there are three lights and I got three remotes. I'm using only one because I can control all the lights with this remote, but there are three remotes. So we got three objects. If I break this by any case, maybe I'm sitting, maybe I kept it on a chair. I sat on it by mistake. And if I break it, it is only damaging one particular remote, not everything else, right? To give another example, all the humans are objects. I mean, not a good idea, but then let's say if I have three people standing in front of me, let's say we got Kiran, Harsh, and Sushil, and then they are humans, right? So I can say human walk. The question is which human will walk, right? So they are confused. So I have to be very specific. Human walk in bracket, I can pass Harsh. Or I can say human walk in bracket, I can pass Sushil, right? Same way, when you say I got one object, you can have multiple objects. Imagine we have multiple objects. And how do we do it? It's very simple. You say com2 equal to computer. So we got two objects, right? Now when you say computer or config, which object you're talking about? Because two laptops can have different configuration. So in this bracket, you can pass comp1. So you are specifically mentioning, hey config, I'm calling you, and I know you are in computer, and I want you to work with the comp1 object, the first object. So there can be multiple objects. This is the first object which I'm passing. And now this comp1 goes to self, and that represents the current object. So example, if I refer to three objects here, and let's say two remotes are there on my table, one is in my hand, and I'm talking like this remote or self remote. Or you can also use this if you want. If you're confused with this self, I can say this. And in Java language, we prefer using this, but in Python, we say self. And there's no compulsion that you have to use self. Even if you try with this, there's no problem. Your Python still works. But then we normally use self so that other developers will be happy with it, or Python developers will be happy with it. Okay, so that's why we use self. Now you can do the same thing by saying computer.config, and you can pass comp2 here. So let me run this, and you can see we got two configurations. They are same because we are printing the same data, but we can print different data for different objects. So this is how you pass it. Okay, so I hope it makes sense now. So whenever you want to call a method, you basically have to use a class name because it belongs to that class, and then you have to pass the object. This is one way of doing it. The another way of doing it is very simple. You use the object name, which is comp1, and then you say config. And you have to mention the round brackets. Now, will this work? Now, in your mind, it may not work is because in the config, we are not passing anything because we are accepting an argument, right? We have to pass it. But if you try this, it works. How? We need to pass it, right? So the thing is, when you mention the object name and when you say object.config, this object becomes a parameter here and it is passing here. So behind the scene, even if you write this behind the scene, this is getting called, okay? So you don't have to mention computer is because you are mentioning the type of that computer, which is comp1, or the object of the computer, which is comp1. And then this comp1 will go as a parameter. So I can say human walk, in bracket I can pass Kiran, or I can say Kiran walk, which is simpler, this one, right? But behind the scene, it is still human walk Kiran. So that's how this thing works. That's how we create object. That's how we create a class, and we'll do more with this, like passing different data, but we'll do that in the next part. We'll talk about a dunder method called init. Now, first of all, what is dunder? Is basically means double underscore method init. So when you look at init, you will see 2 underscore at the start and at the end. Something similar to what we have done with the name variable. It's just that this time we are working with a method. But why do we need it? Let's understand that step by step. So till this point, we have worked with a computer, which is a class. And then the way you create a class is class, then a computer name. And then you mention the method name, which is config here. And then we are able to create 2 objects. And then we are able to call it. And we have seen multiple ways of calling a method, but let's stick to one style now, which we are going to continue, which is the object dot the method name. Now, what we have done till now is we got all these particular values, which is we are printing in the config. Okay. Now the problem is, doesn't matter how many objects you create. So when you got a computer class, you can get multiple objects, right? So let's say it's a factory where you have given the design for the computer. A factory can create thousands of objects of it, or maybe millions, depending upon who wants to buy it, right? But then everything will be having a same config. We don't want it. Even Apple go for different configuration with their limited range of designs, but we got multiple options there in terms of CPU power or RAM or the storage, right? So I want to have different configuration here. So how do we do it? Logically, if you think, when I create a computer object, in this bracket, I should be able to pass the values. But how will you accept it? How will you assign it? That's the question we are trying to solve here. And before I do that, I want to show you one thing. Now, if you look at this computer class, we got only one method, but there are no properties here. There are no variables for this particular class. So if I come back here and say computer1 dot, can I access a particular variable? Let's try. So in fact, I should be doing that in a print statement. So I will say print. And let's say I want to print a CPU here. Now, look at the class. Do we have CPU variable? Of course not. So if I try to run this, first of all, I have to get into up, and then I will say python demo.py. And when I say enter, you can see we got an error. It says we don't have anything called CPU here. Computer object has no attribute called CPU. And Python is right. There's no CPU here. So what we can do is we can actually create a variable or attribute. I can say comp1 dot CPU is equal to, let's say, i5. Okay, you can actually do that. But if I try to run this, it works. Okay, so even if you don't have a variable inside a class, after creating an object, you can assign a value to it. Something like, let's say if you buy a laptop, we don't have a webcam on a laptop, and you will say, hey, where you will find a laptop without a webcam? I once bought a Asus laptop. I think it was a gaming machine, and it was not having a webcam. That's weird. I got to know that after buying it, and then I have to literally buy an external webcam, connect it. It works, but then that's an external thing now. So when you try to do that, when you say I'm creating a variable externally after creating the object, it works only for this particular machine. If you try to do that, so you can see there's no error. But the moment you say CPU2 now, does CPU2 have access to CPU? And the answer is no. CPU is only for the comp1. Okay, so this, you can create attributes, you can assign it, but then you can't access that in the other objects. So we can do this, but we don't want to do this. So what's the other option? The other option is you can create a variable inside a class. And with that, we have to understand different types of variable inside a class. One of the type is the class variable. The second type is the instance variable. Now, what is class variable? So let's say if I create a variable called CPU here, and if I assign a default value, which is i5, now this variable here is a class variable, which means the variable is there. You can print it. It will not give you error now by saying, hey, I'm not able to find CPU. It will be able to find CPU. But then this becomes a class variable. That means all the objects will share the same value. Okay. And how do you access it? One way is using the object, and second way is using the class itself. Why class? Is because it's a class variable. It's common for all the objects. Maybe it's something like brand. So when you go to a factory by saying, okay, I want to build different computers, but then the brand will be common. Let's say Telusko is the brand, and it will have different configuration, but the brand remains common. I hope you got the point. So if you want to set a brand, you can make it as a class variable. But CPU as a class variable doesn't make sense because every object should have a different value for it. So this should not be doing. Let's go back to comp1. Now, how do you create an instance variable? Instance variable basically means a variable belongs to an object, and every object should have a different value for it. I mean, they can have same value, but you can have different values. Now, to do that, we need to use something called a method, which is init. And that's how we started, right? So this is a method. Now, it needs 2_ before and 2_ after. And that's a method, so you have to give the round brackets. And now you can do it. Now, what you want to do, let me just print to check if things are working. I will say init called. Now, what happens is every time you create an object, it will call the init method by default. So behind the scene, even if you don't know it, it will call it. Okay, so with this statement, it will create the object for you, and it will call the init. Let me show you that you will get an error, and you got the error. It says init takes 0 positional arguments, but 1 was given. So this init, where we are not accepting anything, it is saying that you are passing 1 argument. Now you will say, where's the argument? I'm not passing it here, but every time you create the object, it will call init. And since we can have multiple objects, don't you think it is going to pass the object here? And that's right. The first parameter of init is always self, and that's a compulsory parameter. Otherwise, this will cry. Python will cry by saying, what you're doing. Run, and you can see it says init called 2 times. Why 2 times? Is because we got 2 objects. If you create 3 objects, it will call 3 times, and you try it out and let me know. If you create 10 objects, it will call init 10 times. But why we got error for CPU? Because we still don't have CPU. So let's create one. How do you create a variable? You can simply come back here and say CPU is equal to i5, and your job is done. Let's try and let's see the error. And the error is it still says I'm not able to find the CPU. Reason now is you are creating a variable, but that becomes your local variable. This thing you can't access outside is because it does not belong to an object. So let's make it belong to an object. And you can do that by saying self.cpu. So whatever object you're passing in this bracket, you're not passing it, but behind this it is getting passed. That object will get an attribute called CPU. So it doesn't matter how many objects you create, every object will get this CPU now. And let's see the output, and it works. So you can see we got 2 init called, logically, that's right. And then we are printing the CPU only once, and that's why you got i5 here. Beautiful, right? And that's how you do it. But I want some other values as well. So self.ram, I can say RAM is 16 GB. then self.ssd. Let's say this is 1 TB, not ITB, but 1 TB. Okay, this is how you can assign the values, and you can access all these values outside. No problem there. But when you call config, it is going to print this. Doesn't matter what values you have here, it will always print this. So I don't want this to be printed. What we can do is we can say config colon, and then you can pass the values CPU, RAM, and SSD here. So you can type CPU. Let's try to print CPU now, nothing else, but it will give you error. It's not able to find CPU. Then you will say, hey, it belongs to the object. Then Python says, if it belongs to the object, why you're not using object here? Okay, Python is always right. It's your mistake. So we can also access self.ram. We can also access self.ssd. And now let's see if things works out. Let's run, and it works. You can see we got config printed, but we should also print config with comp2. But unfortunately, it will print the same value. Both are same. It's because we are assigning static values. How do you make it dynamic? It's so simple. Just pass it. Just pass it. So when you are creating the object by calling the constructor, just pass the value. Let's say the first machine is i5, then you are passing, let's say, 16 GB RAM, and then you are passing, let's say, the hard drive, which is 512 GB. The same thing you can do for the second machine here. And maybe you can say this is i9. This is like a machine on steroids. Okay, this is the configuration you need. Maybe even 64 is less for 19 i9. I think one of the machines in my office is 96 GB for the editing. And the person who's editing this video will enjoy it because it's his machine. Anyway, so let's not print CPU anymore. Let's stick to configuration and let's see what it prints now. Run. Oh, we got an error. It's because we are passing these values, but nowhere we are accepting it. So we need to accept it, CPU, RAM, SSD. So when you are passing it, also accept it. And whatever value you got here, just assign it here, right? So whatever CPU you got, assign it here. Whatever RAM you got, assign it here. And whatever SSD you got, just assign it there. And let's clear this and run. It works. If you can see, both the objects got different values. And that's what we wanted from the start. So yeah, that's how we work with init. But let me point out one more thing. In the object-oriented programming, or whichever language implements it, basically whenever you create the object, it calls something called a constructor. And maybe somewhere we have used that term constructor before. Now, constructor has this special property where constructor belongs to a class, and every time you create the object, it will call the constructor by default. In Python, init is the method which gets called by default when you create the object. Does this make a constructor? And the answer is no. Constructor is different. This is just an init method which is used to initialize the variables or values. This is not a constructor. We'll see the constructor maybe later, but this is not a constructor. Okay, just wanted to point that out. We have talked about init method, and now we know when you create a class, when you create the object of it, it's going to call the init method. But then in between I mentioned about constructor, right? And then we have also discussed that constructor is not init, it's something else. So let's talk about what is that something else. And to understand that, let me create a new file. Let's not touch the computer class. Maybe we are going to do something more with this. So in this package or in this particular folder of OP, I'm going to create a simple file. Let's name it as cons.py. Okay, that's the name sounds weird, but anyway, that works. In this file, I'm going to create a simple class, which is called ABC, nothing fancy, just a simple class. And I'm going to create a simple method, which is show. And we know that the show need to have self as a keyword. And then inside this, we can basically print something. Let's print in show. Okay. And now let's do the heavy task, which is creating the object for ABC. And now we know how to get the object. We can say obj1. And to create the object of a class, we use a class name. And then we give a round bracket. And that's how you create the object. And then here, obj1.show, that's how you call the method. It should work. We have not done something very different. So it prints in show. But then let's also try to use the init method here to see what happens. So if I use init here, and of course, init also needs self. And if I give a colon, enter, and let's also print something here. So I'm going to print init called. Okay, so now let's try to understand the sequence. The sequence is we are creating the object of a class. Now whenever you create the object, it will call the init method. So it should first print init called, and then we are calling show, so it should print in show, right? So I'm going to clear this and run, and that's what we got. We got init called and we got in show. So nothing much. But then if you try to create another object, which is obj2, and then of course with obj2 I want to call show. Now this will not work because we don't have the obj2 object. So let me create one. So I will say obj2, and the way you can create the object, we know the syntax, but let me show you another syntax here, which is ABC. And the moment I say dot, it should give you multiple options, but one of the option, if you see, we got something called new. Okay, so we can use abc dot new underscore underscore, and we can use a bracket here. But then this method, so it's an inbuilt method which takes class as a parameter. So I can pass ABC. Okay, this works. And let's see if it creates the object or not. See, ultimately we just want to call show, right? If we can get in show 2 times, our job is done. Let's clear this and run. And you can see we got in show 2 times. So that means this is one way of creating an object. Now, what is this method here which is new? So what we can do is we can create a method called underscore underscore new underscore underscore, and this will take what? Now since we are passing a class, we have to accept a class here. So I will say CLS, and let's print constructor called, and that's right. This thing here is a constructor. So even if you do this, it is calling the constructor. Okay, let me show you something now. Let me just run this. We got the error, but ignore the error. Look at the first statement. It says constructor called. So that means even before you call the init, the moment you create the object, it will call the constructor first, and then it will call the init method. But the question arises, why we are getting an error? It says attribute error, none type, object has no attribute called show. Okay, so the problem is when you call show here, and you can see it is on the obj1, not on obj2, because we have not even went to obj2. We got the error on obj1 itself. When it calls show, it is expecting that there's a method called show, and even before you call the show, the init method should be called. Unfortunately, init method is not getting called because behind the scene, when you write the syntax, it calls the new method. Now you will say we are creating now. We have not done that before. Even if you don't do it, the new method will be there. And that new method calls the init behind the scene. Okay. And again, there's no compulsion to write init method, right? We have seen that. We wrote init method before so that we can initialize the values. So even if you don't have these two things, you can call show. It's just that these two things are predefined and they will be getting called in sequence. First it will call new will call init. But now we are creating our own new method. Now, before I describe how do you solve this problem, I want to tell you one thing. Whenever you want to create the object in future, this is a syntax which you're going to use. You're not going to use this syntax. This is just I wanted to show you how constructor looks like, because people do get confused between init and constructor. This is a constructor. This is not a constructor. Okay, so you're not going to use this. And not even you are going to write a new method. There should be a very special case to do this. Example, if you want to create a class where you just want to create only one object. That means even if you try to create new object, it should always return that one object. So that is called a singleton class. And if you want to achieve that, you have to write this syntax. Maybe you want to control the object creations with the values. In that case also you can use new. But those are very rare cases. And in the entire series, this was a rare case where we are doing this. Okay, now let's try to solve the problem. The problem is the new is not calling init. So if you are defining it, it is your responsibility to pass it forward. Even if you're not calling init, you have to pass it forward. And the way you can do that is by saying return. You have to pass the object of a class. So you can pass the object of a class by saying new class. But then even to call new, you need something, we'll say super dot, which will take two parameters. So one is ABC and second is this CLS. Now this syntax looks weird and we don't want to focus more on the syntax here because we have not talked about inheritance and all the stuff. But the super, you will see the inheritance, and that's how you do it. Now, do you want to remember this? Of course not. I just wanted to show you how this new looks, and this will solve the problem of this. It's going to forward the request and you can call show, but still it is not calling init. So you can call init from here, or you can manually call init. So if you want to use new syntax, you have to use their rules. Now let's see if this works, and it works. You can see init is getting called. So yeah, that's about constructor. This is a constructor. This is not a constructor. That's what I wanted to prove, but we are not going to use this example again, so ignore it. We'll talk about types of methods. So till this point, we have used methods, right? We have used init and we talked about config. Now both these methods are called instance methods. Reason, they work with the instances. Now what is instance? Instance means object. Okay, so when you are working with init and config, you are passing this self, which represents an object, and you are basically calling those functions or methods with the help of the object itself. Now apart from it, we got two more methods. One is the class method and second is the static method. And let's talk about them now. And before we do that, I want to talk about a variable. So let's say we have actually created three variables here. If you see, we got CPU, RAM, and SSD. Now these are called instance variables because they work with the object. And the way you created them, we are saying self.cpu, self.ram, self.ssd. We are using self there. That means this belongs to the object, right? What if you create a variable outside the method, your init method, which is your instance method, and then you make it inside a class, but you will name this as, let's say, brand, and brand is, let's say, Telusko. Now, when you make a brand as Telusko, this brand here is a variable, but what type of variable is this? Is this an instance variable? The answer is no, because these are the instance variable which got created with the help of object. Now, this here is called a class variable, is because we created that inside a class. There's no object reference to it. Now, what's the benefit of creating a variable which is for the class but not for the instance? See, these variables, which is CPU, RAM, and SSD, they are instance variable. And whenever you create object, they will have different values. Of course, you can have same values, but then normally we have them as a different value. So when you create computers, this is i5, this is i9, then we got 16 GB for the RAM, then 96 GB for the RAM, and so on. Values are different. And it makes sense, right? Every computer will be different. So instance variable will have different value. But the class variable is common for all the objects. So whatever computer you make, they all have the same brand, which is Telusko in this case. Okay. And that's how it works. So if you change the brand name from Telusko to, let's say, Telusko AI, and that's what every company is doing nowadays, just rebranding themselves with AI, and they think they are into AI. Now, I think I'm into AI by just rebranding it. Now, this will affect all the objects, right? So if you use an instance variable, and if you make a change for one object, this will not affect the other objects. But if you make the changes in the class variable, it will impact all the objects. And that's your class variable. Now, how do you access it? So if you want to access your brand here, you can see we can't print the brand. Directly, we can't access it. So we have to mention where it belongs to. So of course, you can use the object. In this case, I'm using comp1.brand. And let's see if this works. I'm going to say Python demo.py, and it prints Telusko AI. So brand is getting printed. But we don't need to use object here. We can directly use the class name, which is computer, is because it's a class variable. Anyway, it is shared by all the objects. So why we have to specify the object? We can directly use the class name there. And if I clear this and run, you can see we got the output. Now, this is how you basically use the class variable. But what if you don't want to directly use it? You want to use some methods like info, which should give you the brand name. So I'm saying computer.info, which is going to return the brand name. How will you do that? Now, we don't have this method created anywhere, so we have to create one. So we'll say def info, that's the method we have, and enter. And this is going to return the brand name. But if you see, we are getting an error here. It means it's not able to find brand. And when you run this, you will see you are getting error. It says brand is not able to find it. What's the reason? The reason is this brand belongs to a class. So if you want to access brand, you have to refer it with the class. Okay. And why it is useful to refer it to the class is because you might have an instance variable with the same name. So the class and instance will have their own namespace. So when you create a class variable, it goes to a class namespace. When you create a instance variable, it goes to the instance namespace, which is for the object. And I hope I mentioned the class variable If not, let me repeat. The class variable goes into class namespace. The instance variable goes to the instance or the object namespace. Okay, so how do I use it? So I have to use a class here. And you can pass that class here as CLS. There's no compulsion to use CLS. You can use any other variable name. But it's widely acknowledged that for class representation, we'll be using CLS. And then I can say CLS.brand. Okay, so this is your class. And just by mentioning CLS, will this become your class? No, you have to basically pass this class. Then only it will understand. This is just normal variable. Okay. Now let's see if this works. Let me just go back and run. And you can see we got an error. So when you're saying computer.info, this is not working. Why it's not working? And you will see that in the error. It says missing one required positional argument CLS. That means we are accepting a CLS, but we are not passing it. Now, in your mind, maybe it happened that when you called config, we are not passing parameters, right? But it is accepting a self there, which means it is by default is passing an object which goes to self. Now, which object is passing? The object from it you are calling. The same way, if you're calling info and it is accepting a class from you, we are not passing it, but don't you think we are specifying that's computer? So that should be passed in the parameter. That will happen if this is a class method. Now, how do you make this a class method? Because by default, the methods are instance method. Even if you do this, this becomes an instance method. Now you will say, hey, we are writing CLS there. You are writing a variable name. Okay, that's not class. You have to make this as a class. And to do that, we have to use a decorator by mentioning, hey, this is a class method, treat it with a respect. I'm just kidding. So we are just specifying this is a class method and Python will treat it as a class method. We have to give respect to each method. Why? Class method needs respects. So now if I enter, it works. You can see it prints the Telusko AI. That means we are able to return the value for the brand, which we are printing here. So that's your class method. Now, when do we use instance method? When you want to work with instance variable. When do you use class method? When you want to work with the class variable. Now, what if you want a function or a method which is not linked with any class variable or instance variable? Then what you will do? Just to give an example, let's say I got this configuration and I got this RAM as 16 GB. Now, I'm not sure what 16 GB means. What I know is only bytes. Maybe I'm a person in the world who judge a machine by the number of bytes of RAM it provides. I want to know the bytes. So I can simply come back here and instead of printing info, I want to print GB to bytes. Okay, I don't know why we got bracket there. GB to bytes as a function name or a method name, which will accept a value from you, which is 16. So this is 16 GB and it should return you the number of bytes you have. Now, if you think about this particular function, of course, we don't have this function. But what do you think? This function should be a class method or it should be an instance method? Think about this while I am typing this. It will accept a variable. Yeah, now I think you have thought about it. See, this particular function is not dependent on any instance variable or a class variable. What you can simply do is this: you can make this particular method as a static method. So static method is a method where this is like a utility method. It's there for some processing, but nothing to do with the class variable or the instance variable. So I wanted a function or I wanted a method. I can just make a static method and you can create any number of methods you want. And this will return the value in the bytes. Now, the formula is not important, okay? And even if that is correct or wrong, that's not important. What's important is we're talking about static methods. If you want to do something extra, which is not linked with any variable type, you can go with the static methods. But since we're talking about conversion, I will do that here. So basically, if you want to convert GBs into bytes, GBs is your 1 byte raised to 3. Okay. So GBs is basically 1 million. So we have to say 1000 raised to 3. And that's how you write 1000 in memories, because that's a 1024. And then you have to also multiply that with the number of GBs you have passed. And let's see if that works. Let's run this, and this is the number. You can let me know if the number is right or wrong, but again, the formula is not important, the concept. We are able to create a static method which is not working with any type of variable. So we have talked about 3 kinds of methods. One is instance. These 2 are instance method. This is your class method, and we normally work with the class variables there. And this is your static method, just for some extra features if you want in your class. When we talk about object-oriented programming, we started with class and object, and now the next most important feature is inheritance. Now, in the real life, what is inheritance? So let's say if you have a lot of cars, a lot of property, there's a possibility that you have built it or you got it from your parents. That's inheritance. Or maybe they got it from their parents. That's multi-level inheritance, right? Or maybe your mom had a property, your father had a property, and now you have both the properties. That's multiple inheritance. Now we can do the same thing in programming. How do we do it? It's very simple. First of all, let's create a new file, which is inheritance.py. Okay, let's write some code here. So what I'm going to do is I'm going to create a very simple class, which is A. And in this class, I'm going to create some functions or methods, let's say, which is F1, which is feature 1, or you can name anything you want. And then we are going to print something like F1 works. Okay. And then let's say in this particular class, we got one more method here, which is for F2, which prints F2 works. So we got a class with two methods, F1 and F2, both works. And if you want to call them, first of all, these are not instance method anymore, is because we are not writing self there. So let's come back here and let's create the object of A. And this is how you do it. Now, once you got the object of A, how many methods you can call? So if I say obj1 dot, so you can see we got two methods there. We got F1 and F2. Now, of course, we got other things as well. If you scroll down, there are so many things here. We'll discuss about it from where you are getting those things. But at this point, we got two methods, F1 and F2. And we can call any of one, whichever you want to call. And now let's print it, or let's run this. So we'll say Python inheritance.py, enter. And you can see it says F1 works. And you can call both the methods, right? And with A, let me create one more class, and I can just, because it will have almost the same schema or same style. So I'm going to say this is class B, and this is F3 and F4. So this is F3 and F4. Okay, so we got two classes, A and B, and A got two methods, B got two methods. And when you create object of A, you will get two methods. But what if you create an object of B here? Can you call F1? Of course not. We have seen that before. If you don't have a method in a class, how can you call it? So F1 belongs to A, not B. That's what you got here. And it also suggests, hey, you're trying to call F1, but did you mean F3? No, I mean F1. It's still not working. So I want B to have all the methods. Now you have two ways. One, you can just copy this code and paste it here. So something like this, you can just copy that and paste it here. So now you got four methods. And with this particular change, this will work. But I don't want to do this. I don't want to copy paste it. So what other option we have? So what we can do is we can use inheritance here. So B inherit things from A. So when you write this syntax, which is B in round bracket, when you say A, this means B is inheriting from A. So this makes A as a parent class and B as a child class. And child will have all the features of the parent. Makes sense, right? So a parent got a car and a Formula 1 car. Okay, that's nice. And a property, B has its own properties, but B will get everything from A and their own. What I mean by that is you can call all these functions F1, F2, F3, and F4. It's all yours. So this thing is called a single level inheritance. Cool. We can also talk about multi-level inheritance, where you got one more class, which is C, and C is inheriting from B. So as you can see, B inherits from A and C inherits from B. So this is multi-level, right? Grandparent, parent, and child. Now when you create, first of all, let's have one more method here, and I can just reuse it, copy and paste. This is, let's say, feature 5, and we are saying feature 5 works. And in this, let's create object of B. Let's see if B can call 5. Let's run this, and no, it's not working. Even if you know that B is a parent of C, unfortunately, you can't call the methods of your child class. So the object of is of B, you're trying to call the methods of C class, it's a child class, you can't access it. So child has access to all the methods of parents, but unfortunately, parents don't in programming. And let not that happen in real life. Okay, so this works, and you can see, this is not working. Let me get object of C instead of B, and let's see if that works. Now run, it works. So C can actually access all the methods. So when you say obj1 dot, you can see them options here, f1, f2, f3, f4, f5. You can call all the methods. So this is multi-level. How about multiple? So let's say we got B, and now this time, observe, B is not inheriting A. So A, individual class, B, individual class, but C says I will inherit from both. Now what this makes is C can have all the features again, but then initially it was multi-level, it is now multiple. Okay, now what's the difference? The difference is when you create object of B, you can only access F3 and F4. You can't access F1 and F2. Okay, imagine this is your father, this is your mother, and you can access methods from both the classes, and of course your own. So this is multiple. But when you work with multiple, we have some twist here. Let me show you what that twist is. Let's say you got a method here which is called show, okay? And even show is an instance method. And in this, what you're trying to print is very simple thing. You are printing in a show. Let me just copy this and put that in B as well. But this time we'll say this is in B show. And let's also have that method in C, which is in C show. Imagine show as your mobile phone. When you want to call someone, example, let's say if I say obj1.show, it's like you're calling someone. If you have a phone with you, right? This is your phone. If you have a phone with you, and if you try to call someone, it works. It says in C show. That means you can call. But what if your phone is not working? It is switched off, or you lost your phone. Now question arises, whose phone you will take? Okay, so when you don't have a function or you don't have a feature with you, you will search for that feature from your parents. Now I have a question for you. We got show in both the classes, in A and in B. Which show it will call? I mean, indirectly, what statement it will print, in A show or in B show? Think about it. I hope you thought about it. Let's run this. And it says in A show. Why A got preference over B? Let's say we don't have show in B. Let's see what happens. When you don't have this thing in B or in A, it will call from B. So what is happening here? See, the thing is, there's a concept of MRO, which stands for Method Resolution Order. Whenever you look for a particular method with the child class or child class object, when you call show, it will first search for it in the own class. When you don't have show, of course, if you have show, it will call it. It will not go to parents. But if you don't have show, it will first go to the first class, which you have mentioned in the order sequence, A and then B. It will go to A, it will check. Do you have show here? If you have show, it will execute this. If you don't have show here, then it will go to B. But since we have show, that's why it's saying in A show, if that makes sense. And that's why you got, oh, I have to run this again after making changes. And that's why you got in A show. But what if you want to print in B show? In that case, you can just change the sequence. You can make it B comma A. Now, since we have written B first, let's run this and it says in B show. But let's say I don't want to change the sequence. I want to stick to this sequence here, but still I want to call the method in B. So we have one option here. You can call the show method of B from this show by uncommenting it and add some line, or we can go with our old style. This is your new style. The old style is, which we have done before, use B class and call the method show, but then to call show we need object as well. Pass the object of child class. That works. Okay. And now let's try. It works. So this is inheritance, where we have multiple types of inheritance. We got single level, where we have A and B. Then we got multi-level, which is A, B, and C. And then we got multiple, where you got two parents as A and B, and the child is C. Yeah, and that's how inheritance works. And we have also seen MRO, which is method resolution order, where it will first check in the own class, then it will go to the first parent, whoever you mentioned in the first year. Once we understood what is inheritance, now let's try to focus on init and super method in this video. So before that, what I'm going to do is I'm going to remove all the methods from here, or maybe just skip F1 there. And let's remove B class, let's remove all this stuff. So we got a very simple class here, which is A, in which you got this function called F1, and we are printing F1 works. It always works. And let me move to my folder and let's run this. Let's see what happens. It will not do anything. It's just that print blank. Okay. So now what I'm going to do is I'm going to create an object of A, and let's say A, and we can call F1. Okay. Now we can call F1, but apart from F1, Of course, F1 we created, but then the moment I say dot, you can see there are so many methods which we can use. The question is, from where we are getting all these methods? And do they really work? They do work, and they are part of class A. And then you will say how they are coming there. See, every class in Python like this, they are by default child class. And in your mind, you want to be thinking, it should be a parent class. Why child class? Maybe you made a mistake, Naveen. No, every class in Python is a child class. How? Every class in Python inherits a class called object. Even if it don't mention, this is a class object which it inherits, okay? And this class has everything. Whatever you're getting, the suggestions, they are from this class, okay? So by default, every class in Python inherits this class object. So even if you see it or not, it's there. And that's why you got all the option. But at this point, I just want to focus on F1. I just wanted to talk about the object class. And that's done. Let's run this. I don't know why I cleared when it was already clear. Habits. So you can see it says F1 works. Now I want to add a method here which we have worked before, which is init. And in this, I'm going to print in a init. Okay. Now you tell me, if I run this, will it print in a init? And if you have seen the previous videos, you will say yes. And the answer is yes. It will print in a init. But let me just go towards inheritance now, which is create a class B. And in this class B, let's say I have these two things. And time being, let me comment out the init. And this should be F2. And this should be F2 works. Now when I create object of A again, it still says in a init because we are creating the object of A and we are calling F1. But what happens when you create the object of B? Let's see. When you run this, it says you're not able to access F1 because I forgot to inherit. I wanted to, I forgot about it. Let's clear and run. You can see it says in a init and F1 works. Why it is calling init of A is because when you create the object of a child class, it will look for the init method if you defined it. And we are defining that in the A class. But what happens when you define that in the B class now? Let's see what happens. So let's clear and run. And it says in A because we are printing in A. My bad. Let's run this and it says in B init. Now this time it is not calling this particular init. It is just calling this init. So it will call init if you have defined it. So first it will search in its own class, which is B. If you don't find it there, it will look for the init in the A class. And that's why it was printing in A init before, and now it is printing in B init. That means it will call only one init, not both. But what if I want to call both? In this scenario, you can use something called a super method. Now, what is super? Super basically represents the object of a superclass. Now, what is superclass? See, we have talked about parent-child. We can also name it as a super class and a subclass. We can also say it's a base class and derived class. Different naming conventions, but means the same thing. So super means it will create the object of a superclass. Now with that object, I can call the init of the superclass, which is this init. So we are calling this by default because that's what you're doing here. And then this will call the init of the A class. Let's see if that works, and it works. You can see it says in A init and in B init. Now you can use this super method, which is object of a superclass, to call some other features of A as well. Example, from F2, you can call F1, but not like this. Either you can say self.f1, even that works. It is not, okay, because we are not calling F2. So let's call F2 so that it will call F1. And you can see it says F1 works and F2 works. So we are calling F2, which is this, but F1 is calling F1. So either you can use self or you can use super, both works. Like this. So yeah, that's about init and super in the inheritance concept. We'll talk about polymorphism. So when you talk about object-oriented programming, we have talked about classes, objects, because if you want to create the object, we have to create a blueprint, and that is done with the help of classes. Then we have seen the next important thing, which is inheritance, where one class can inherit the properties or the behavior from the other class, right? Now, let's focus on the next concept, which is polymorphism. Now, what exactly is polymorphism? So it's one thing, multiple forms. That's what poly, which means many, and morphism means forms, so many forms. Now, in real life also, as an object, we behave differently, right? So example, when I make videos, maybe I look like extrovert, but I'm introvert in real life. I don't talk much, but my behavior changes based on where I am. So if I'm at my home, I behave differently. When I am with my colleagues in the office, I behave differently. When I'm with my friends, I behave differently, right? So that is multiple behavior. Same person, but multiple behavior. So in programming as well, when you want to have one particular type, it can behave differently based on the implementation or where it is. And to understand that, let's look at the implementation. Now, there are multiple ways of implementing polymorphism in Python. One of the way is through duck typing, and that's what we're going to focus in this video. So what I'm going to do is, I'm going to create a new file, and I will name this as poly.py. Name can be anything, but let's stick to it. And now, to understand duck typing, let's create a class. In fact, okay, let's talk about duck typing. What exactly duck typing is. So as per definition of duck typing, if a bird quacks like a duck, it is a duck. What I mean by that is, of course, duck quacks, right? But what about the other birds? Let's say if we talk about crow. If the crow quacks, I will treat that crow as a duck. If there's a sparrow, and if a sparrow can also do quacks, I will call it as a duck. That's what duck typing is. To understand this, let me create a class, let's say laptop. I know from birds we went to machines, but that's how technology works. So we got a class here, and this class laptop will have a method called build. Because as a developer, when we use laptop, we build stuff with it. So I will say build, and let's print something here. I'll say laptop builds. I know that what that means, but anything we can print there. Now, who uses laptop? Of course, everyone in the world for different purpose, they use laptop. But for me, as a programmer, and I call programmers as aliens, we normally use laptop to code. Now, when I say code, I'm saying building projects. Okay, it can be designing the applications, writing code for it, testing it, maintaining it. Everything comes under code. That's a simple word to use. And then we'll say print, and here we'll say alien building. And in this building, I made a spelling mistake. And that's why it was not building, it was something else. Now, of course, right, if you want to write a code, you need to have a machine, right? So that's your laptop. And what I'm going to do is I'm going to call build from here. So when I'm writing code, of course, I want to build, and I need a machine for that. But you can't call build directly. You need to pass the object of a laptop here. So I will call this as a machine. And even we can also specify the type of it. The type of this machine is a laptop. Okay, so this is how you specify the type for a particular variable. Okay. Now, can you call this build? So let me try. I will say machine.build. And it is able to call it. But then if you want to really make it work, you need to first create the object of alien. And I will say Naveen. Naveen is an alien. That's the object. And using Naveen, I can call code. But then in this code, I have to pass something. If you directly call code, it will not work. Let me show you. I will clear the screen. And I will say Python. The file name is poly.py. And if I say enter now, it is giving you an error. It says required one parameter, but I'm not passing it. I have to pass machine. I don't have a machine here. So what I will do is I will build one. I will say laptop. So the machine which I use personally is Asus ROG. It's not sponsored by them. I hope they will do it in some day. But if people from Asus are watching this, please sponsor. Okay, so Asus ROG, and I'm creating a laptop object here, and now I can pass. So if I want to build, I need Asus ROG, provided I'm pronouncing the company name properly. And now if I run this, it works. You can see it says alien building and then laptop builds. That's what we are doing. So we are printing alien building and then we are calling build, which prints this. Perfectly works, right? And still we have not talked about duck typing. See, imagine this laptop for us is a duck. Okay, so we are expecting a duck here. So whenever someone says, hey, you need to build, it will use laptop, but then I want it to quack. So it will say duck. But then let's say, if you join a company, of course, some companies have a policy, they will give machines to the people, right, who joins. Now, this can be a laptop, this can be a desktop. And in laptop also, you can have a heavy machines or a light machine based on the kind of work you do. Of course, if you're using Docker, if you're using any heavy applications, you need heavy machines. But let's say if your works around Chrome and then Excel, Light Machine will do. So I will say class and let me say desktop here. And maybe company choose to give desktop instead of giving a laptop. You can't say no to that, provided if you want. You can say no if you don't want to work there. So let's say we are saying desktop builds. Now my question to you is, let's say Naveen says I want to code and expecting the object of a laptop. But what if company decided to give you the desktop? So the desktop which I'm using now for the recording, it is called Beast, Black Beast actually, but let's say Beast. And let's say this is the object of desktop. And now I can call code by passing Beast. But question is, will this work? I will comment the first part, which is I'm not passing Asus now, I'm passing the Beast. Should it work? See, technically, logically, looking just at the code, it should not work because you are expecting a laptop here and you're passing a desktop. But if you run this, it works. It says desktop builds. And that's the whole concept of duck typing, where you are saying, I was expecting a duck, but now you are giving me a crow, but this crow quacks. Okay, so as a bird, you need to have a feature of quacking. That's it. So if you need a machine, if the machine says build, your job is done because ultimately you're calling build. Okay, just to make this more clear, what I will do is I will create another machine. Let's say class tablet, and this one says build self. Now, the thing is, in tablet, you can't have build because normally we don't do developments on tablets. One of the main reasons we use tablets is to read. That's what I'm using it for. So I will say open PDF or any other ebook format or whatever. I will simply say print opening PDF. Okay. Now what happens is, let's say in your company, you got this tab. So the tab which I'm using on the desk is from Lenovo. Again, not sponsored, waiting for them. So I will say Lenovo tab equal to tablet. I don't know why I'm sounding like waiting for the sponsors. Maybe I am. Okay, so Lenovo tablet, and here I will say Naveen dot code. And now for coding, if you pass the object of Lenovo tab, let me comment the Beast part now. The question is, will this work? Logically, it should not work. But then if you run this, it will not work. You know why? Because this particular bird is not quacking. In our sense, quacking was build, and this particular tablet is not building. And that's why it is failing. Okay, so desktop and laptop both are ducks because they both are quacking. This tablet is not quacking, and that's what is called duck typing. So it needs one thing, but it can have different behavior based on which objects you pass. If you pass the object of laptop, it will behave like this. If you pass the object of desktop, it will behave like this. And that's, my friend, polymorphism with the help of duck typing. In polymorphism, the next thing we're going to talk about is operator overloading. And to understand that, let me just go back here and create a new file, and I will say this is oper.py. Just wanted to have some small names for the file so that I can type it easily. So what we're going to do is very simple. We'll create two variables. Let's say a is 5 and b is 6. And then we are going to add them, which is a plus b. And then you'll be saying, hey, we have done that in the first video or maybe on the earlier videos. Why we are talking about this? I will get to it. But before that, I'm going to print C. And let's move to that folder, OOP, clear it, and let's run this now. So Python oper.py. And once we got the output, you can see we got 11, and that's what I was expecting. But the question arises how exactly this plus is working. Now, plus behaves differently in different scenarios. Example, when you say a plus b, when both are integers, it's basically adding them. But let's say if I make this as a string, now both are string, and then still we can use plus here, and let's see what is the output. Now when we use them as integers, we were getting 11, but now when I use them as a string, we are getting 56. So something is different, right? So we got the same operator, but as the operands are changing, the type of the operands changes, it changes the behavior. Now that is what is called operator overloading. So based on its operands, the behavior changes, right? So that is polymorphic. So it's one thing, but behaving differently, right? So one thing, many forms. That's polymorphism, right? Okay, but then let's understand how it is working, how that plus is behaving differently. Now what happens is when you try to add two numbers, this 5 and 6, both are objects, right? Yeah, we know it's int type, but they are of type integer class or int class. And we have seen that before. So if I try to print the type of this a, it will be saying class type int. So what is happening behind the scene? Now, since it's a class, what I can do is I can just comment this part and let's rewrite this here again. But this time I'm going to use int as a class. And you can see on the screen it says class int. Now it's a class, so it will have some methods to work with. And when I say underscore, there are a lot of magic methods here. So all these underscore methods are magic methods. And we got one of the method here is called add. So if I use this add method, which takes 2 parameters, because of course, if you want to add 2 things, you have to pass as 2 parameters. So I'm going to pass A and B, and let's see what it does. Let's run this, and it again gives you 11. So even if you do this operation or if you do this way, both are giving the same output is because both are same. You will say, hey, they are not same. We are using plus here and then we got add here. That's a method. Why you're saying it is same? They are same is because even if you say plus, behind the scene, Python will do this. Okay, that is your syntactic sugar. This is what you want to do, but you do this just to make it more readable. Otherwise, if this was compulsory, then a lot of people would have left Python for some other languages, right? So this is what we use, but this is what is happening behind the scene. Now, going forward, if you're thinking, hey, we are going to use this every time you want to add, please don't do that. You're messing up with the readability of the code. So this is what you have to do. I'm just trying to make you understand this is what it is working with. Now, if you click on add, you can see it takes 2 parameters. One is the self and second is the value. Now in this, A is the self and B is the value. That means you can also write this statement something like this. You can say A dot underscore underscore add and you can pass B. And we have talked about this before when we were working with computer class, where you can call a method with a class by saying class dot method name and then you can pass the object, or you can use the object name to call the method. Both are same, right? So this is what it is doing. So once we understand this, let's try to write our own class and see if we can do that. Can we just do this operator overloading on our own class object, because we are using int class which is inbuilt. So what I can do is I can create a class called account, which is like a bank account. So in a bank account, you will be having multiple fields like your username, your name, your bank account number, your balance, the type of account and location, multiple things, right? To simplify, I will go with 2 things, the name and the balance. Just keep it simple. And to do that, I'm going to create the init method so that I can define those variables. And this is going to be instance method. So I will say self. And I'm going to create 2 variables. One is the name and second is the balance. But I want to assign the values to it when I create the object. So of course I have to accept it here, name and balance. And let's assign name and let's assign balance, whatever you get from the object creation. What I'm saying is when you create the object, let's say the first user, I will say user 1, the first user has an account. Now we have to pass 2 things here. One is a name. So let's say it's my account. And then let's say the balance in my account is 1,000. Now this can be rupees, dollars, or bitcoins. Imagine 1,000 bitcoins. Anyway, so user 2, and then we'll create account. Now this is for my wife. So I'm going to say Kiran, and let's say this is 2,000. So that's the balance in our account. Okay, so we got 2 accounts here, one for Naveen, one for Kiran. And now let's do the operations. First of all, I want to do one more thing before I talk about add. So let me print user 1. Now you tell me what will happen. In fact, I'm not just going to print user 1, I'm going to print the user 2 as well. Now when you do this, when you try to print the users, this is what it will do. It will say the type of the object, which is account type. So account object at this location and account object at this location. So we got 2 objects on different locations. My intention was to print the values, not the address. How do I print the values? You can do that. You can say user1 dot name, user1 dot balance. You can do this. But if you just want to print the object and you're expecting it will give you the values, we can do one thing. To understand this, let's go back up. And now here, if you take this variable A, and when you try to print the value of A, will it print the object, something like this, by saying int object at a location? Let's see. If you run this, it actually prints the value. It's not printing object at this location, and it thinks an object, right? It's an object. Still, it is printing value. How it is printing value? Because by default, every time you try to print the value, it calls a method, which is inbuilt method, which is called str. This is the method which is getting called, and that's why you are getting that value. So even if I write that method and run, you will get the same output. So I'm proving my point that even if you call a, it is going to call this method. Now what this str method does is it's like a string method which returns the value of that object. So when you say click here, it's an inbuilt method, but we can't see the definition, but it returns the value of integer. So what if I come back here, user1 dot, and if you say str, you can see we do have this method inbuilt. And the way you can check that is by running it. No error. That means yes, this method is inbuilt. Even if you don't mention that here, it's there. From where you are getting this method? You're getting this method from the object class. And the default behavior of the object class is to print this. I don't want to print this. I want to print the values. So what you can do is you can do something called method overriding, which we're going to see in the next video. And I'm going to say str. This is going to be an instance method. I don't know why I said static. So this is the instance method. And what we are going to return is the value, right? And I want to print that in a particular format. So I'm going to use f. And if you want to print a particular format, you can use f. But then in the single code, you have to define your variables in the curly brackets. So the variables I have is self.name, and then you can give a space, and again you can put self.balance. If you want, you can give a colon in between so that you can differentiate them. Now what we are doing is we are defining our own str, and run, you can see we got the values. So for the user one, I'm actually calling str. So it makes sense to print this. But for the user two, I'm not even saying call str. But as I mentioned before, every time you try to print the object, it will call the str method. And for the user one also, I don't want to do that now. It should call automatically. Clear, run, and it works. Perfect. So let me just comment this part now and also comment this. Let's focus only on the account now. So what we are doing is we are overriding the behavior of str. But the video is not about overriding. The video is about operator overloading. So what I'm going to do is, let's say I want to know what is our combined balance. So I will say combined equal to, I want to say user 1 plus user 2. Maybe we want to buy something and we are not sure if will it be enough. So we'll combine both the balance to see can we really afford it. So we'll say combined equal to user 1 plus user 2. And I want to print the combined. And the type of data which you should get from combined is the account object, right? But if you do this, it will give you an error. It says you can't use plus here because these are objects. But we have used plus here and these were the objects. So you think what can be done? When we said plus, we were actually calling add method. And it's not there in our class. That's the issue. It's not even there in the object class. So what we can do is we can create a method called add, which will take two parameters. One is self for sure. The second one is we can name it as other, or you can say value, your choice. But self, other makes sense. Me, you, right? I mean, we can do that. It's me and you. And then we can return the type of account by passing two data. One is the name of the account. I will say this is a combined account or join account. And then the value is the addition of both of the balance. So I can say me.balance plus you.balance. And that should work, right? Let's try it out. And it worked. Okay, so what we are doing is when you say plus here, it is going to call the add method. Earlier it was not there. Now we have it, which will take two parameters. One is this, one is this. Now why this is me is because I am adding my balance with the user 2. So that becomes you. But then this is not a good names to use. We should say self and other because this is what you will see on the internet. So I don't want to confuse you with those names, me and you, but self and other makes sense. And with those variables, it still works. Okay, that's what is called the operator overloading. The same operator but behaves differently based on what operands you pass. So that is operator overloading, comes under polymorphism. But we can do one more thing. Let's say we are going for a dinner and who should pay for the dinner? So if I don't want to pay, I will basically go to wash my hands, right? But nowadays in restaurants, they give you the bowl where you can wash your hands. It's tricky. But let's say we'll decide on that particular day, on that particular moment, whoever has a good balance or greater balance, they will pay for the bill or they will pay the bill. So I can check if user 1 is greater than user 2. Now this is tricky because you're not comparing the balance. What could be easier is by saying user 1.balance is greater than user 2.balance. It will be much easier because you're comparing the numbers And you can compare the numbers using greater than symbol. We have seen that before. But now what I'm doing is I'm actually comparing the objects. Let's see if this works. If this works, it should print Naveen pays the bill. If not, else Kiran pays the bill. Okay, but if you do this, it will give you an error because you can't compare two objects. How do I do it? Now, in this case, we have to overload this particular operator, and you can do this. So in the integer as well, we got different functions. Example, if I uncomment this, I'm uncommenting A so many times. I should have uncommented it before. You can see we got all these magic methods, right? We got add and so on. And few methods are like equal, greater than, equal to. This is greater than GT. Then we got LE, which is less than, equal to. LT, which is less than. So we can use all this. We can also got multiplication and so on. There's so many methods here. So what we can do is we can overload one of the method, which is def GT, which is greater than. And this will take again two parameters, self and other. And you just have to return self.balance is greater than others.balance. Then whoever has a bigger balance will return true. If self is greater, it will return true. Then that means Naveen pays the bill. If it is false, Kiran pays the bills. Or pays the bill, yeah. Let's try, and the answer is Kiran pays the bill. But let's say I got some amount from somewhere, let's say 4,000. My account balance updated, and now you can see it says Naveen pays the bill. So that is your operator overloading in Python. Same operator, but depend upon what are the operands, it will behave differently. We're going to talk about a concept called method overriding, and we have seen certain things about it in the previous video. So when we talked about str, we discussed that str belongs to the object class, and by default is there. So whenever you try to print the object type, or whenever you try to print the object, it calls the str of the object class. So what we did here is we have overridden the str method of the object class, right? But then let's try to understand this with a new example, and we'll keep it short. I will say this is override.py. So let's say we got a class A, and I just want to keep the example very simple. And we got def, a method which is show. And this is going to be instance method, so I will say self, and this is going to print in a show, and we can basically create the object of it, right? And we can call it. So let's say obj1 equal to A, and if you say obj1.show, let's see if this works. So I will say Python override.py, enter, and you can see we got the output in a show. Perfect, right? We have not done anything fancy till this point. But what I'm going to do now is I'm going to create a class called B, and B inherits from A, and let's say pass here. Now my question to you is, if I create object of B, will I be able to call show? Now, if you remember inheritance, we should be able to do that, and it says in a show. Now, why we are taking this example is, in fact, I want to link this with my personal life example, and every time I talk about method overriding, I talk about this example. So when I was at my 11th standard, after completing my schooling, so I was in junior college, and then I'm talking about year 2005-06. At that point, mobile phones were getting very famous, and then most of my friends, they were having phones. I was not having phone for different reasons, but then they used to ask me which phone I have, and a lot of time I said I don't have a phone, but one day I decided I have to say something, and then instead of saying I don't have a phone, I said I have Nokia 1100. It's a fancy phone if you can just check on the Google. It's a very minimalistic phone, not fancy phone, but very, very, very nice phone. And I used to say Nokia 1100. But then it was not my phone. It was my parents' phone. And whatever parents have, it belongs to me, right? So example here, B class has nothing. So whatever belongs to A belongs to B now, right? I was happy. After a few days, I got my own phone. So I got a gift. And this time the phone was Motorola. Okay. So if I got a Motorola phone now, and if somebody is asking me which phone I have, what will I say? Nokia or Motorola? And that will be decided by this code. And I said Motorola. Okay. So when you have your own method show, and if you print in B show, and when you call show, it will print your own method. So what we are doing now is this particular method show overrides the behavior, or it overrides the method show of the A class. So when you don't have your own method, you can talk about the parent method. But if you have your own method with the same name, same parameters, it will call your own method. This is called method overriding. I hope it makes sense. The concept was small and we have talked about it. We'll talk about abstraction. So we'll divide this into two sections. The first section will talk about what is abstraction and how do we implement it. And the second section will be, why do we even need it? Okay, because it's easy to understand abstraction. It is easy to understand the way to implement it, maybe in different languages, but we'll stick to Python here. But it's difficult to understand why do we need it. So we'll need a separate section on that. So let's start with what is abstraction. So abstraction basically means hiding the complex implementation from the user. Okay, that's what abstraction is all about. So just to give an example, let's say if you drive a car. Of course, car has multiple components, right? So we got an engine, we know how the braking system works. So we got brakes, clutch, accelerator, then we got gear. So we have all these components, right? And because of this, your car moves. Now, the most important part here is the engine. But when you learn to drive, you don't have to know how engine works. Of course, it's good. It's a good knowledge, and a lot of people love understanding how engine works. And I got to know that a bit later. But the point is, when you are learning to drive, you don't have to understand how engine works. What is important for you is that steering, that those three things, ABC, and the gear. So important is, here what we are doing is, we are doing abstraction. So we are hiding the complex implementation from the user, okay? The advantage is, let's say in future, you are learning to drive one car, which is, let's say, EcoSport, the Ford EcoSport. I love that car. And now you know how to drive that car. Maybe you also understand how the engine works of that particular car. And then you are going for a different car, and different car will have a different engine. Maybe this time you are driving a V8 engine, and that's my dream to drive that once. But let's say if you have that V8 engine there and you got a car, you can still drive it, right? At least basically you can start it and you can drive it. You don't have to understand how engine works, right? So you are basically hiding that structure. So for you, what is important is the interface which you see in front of you. So that is abstraction. Now, the way you can implement that is, we have a concept of interfaces and implementation. So what you do in the interface is you define or you declare what are the things needed to build a car. Maybe you need a steering, you need an engine. So you can declare those things. As a user, you are only focused on the interface. Mind you, in the interface, we are not implementing anything. We are just saying, this is what it should do. And then you implement it. Now you can do that in a class, right? So, and we have seen that, right? In a class, you create variables, you create methods, or you can call it functions. So you create everything in a class, but in the interface, you just declare them and you implement that in the class. And you are basically hiding this class from a user. So as a user, I'm just going to focus on the interface, but yes, at the runtime, you are going to use the implementation. Now, just to give an example, and let's go back to the override example which we have done. Even if you're creating the object of B here, as you can see, we can still refer that as an object of A, because A is inherited by B, right? What if you declare this? What if you don't define the function here? So let's say you have a function show, but you're not defining anything there, but still you are implementing it. So this can be our interface where you're not defining anything, you're just declaring it, and this is your implementation. In this example, we have implemented both, but let's say I'm just giving you a situation. This is what you can do, but how will you do it? That's a question. So let's understand how do we do it, and then next part we'll talk about why do we need it. So it's actually simple. What I'm going to do is I'm going to create a new file here inside the OOP, which is abstract demo.py, and in this I'm going to create a very simple class. Maybe we'll try to implement this only A and B. So let me create a class called A, and in this class, let's say I have a function called show, and we'll pass self here. And I'm not doing much here, so I'm just saying print A show, okay, in A show. Simple. Now, what I want to do is, of course, for this particular class A, I can create the object, and that's the main use, right? So if I say obj1 and A, I can of course create the object of it, and I can call that particular function. There's no problem in that. I will just try to run this. So it's Python abstract demo.py. And you can see it says in A show. Now I want to achieve abstraction. Okay, so to do that, we have to basically build the interface first. And the way you can do that in Python is with the help of abstract classes. Okay, and to write an abstract class, we need to have abstract methods. So this class need to be an abstract method, and this class need to be an abstract class. Now, how will you do that? See, there are different ways to do that in different languages. In Python specifically, it was not built for OOPs. Python was built for functional programming. and oops came later. To do that, they had to build a particular module using which you can do that. And that module is called ABC. Okay, I know, weird name. It's not escalator, brake, and clutch. It's abstract base classes. Okay, why abstract is because you want to make it abstract. You don't want anyone to create object of it. Why base is because someone else is going to inherit it. And classes because they are classes. We don't have the interface keyword in Python. So we'll say from ABC, and what you have to import is ABC class. Yeah, that's right. So package name is ABC. The class name is also ABC. This time ABC stands for abstract base class. And apart from this, you need one more thing, which is the abstract method. Okay, so you need to do these two things, the ABC class and the abstract method. Now, once you have that, how will you make the object and how will you make an abstract class? Now, just by importing them, of course, it's still going to work. Now, I don't want it to work. It's because there are certain properties. The first property is you cannot create object of the abstract class. Here, we are able to do that. Second, abstract method should be a part of the abstract class. And this class is not an abstract class yet. And if you want to create abstract method, you cannot define it. There should not be any statements. So these three things you have to remember. So I want to stop the object creation. Now, the way you can do that is by inheriting the ABC class. And that's it. This is how you make an abstract class. I know you don't trust me and you should not be trusting me. So there's one more thing left is in this class, we need abstract methods and we don't have that. The way you can create an abstract method is just on the top of the function, just write a decorator abstract method, and we need to do one more thing. Since abstract method don't have the implementation, we can write pass. We can't keep it empty, unfortunately, so you have to say pass. And now if you run this, you will get an error. It says cannot instantiate the abstract class A without an implementation for abstract method show. Okay, so since you don't have the implementation for this, you can't create object of abstract class. So this is how you can achieve abstraction. But I know still doesn't make any sense. It's because we are not, why do we use it, right? If you can't get the object of it, why in this world we are creating a class and then doing all this stuff when you can't create the object, when you can't call it? To make it more sensible, let's use another example in the next section. Now, what we are going to do is let's remove everything. Now we know how abstract class works. How to create an abstract class, how to create abstract method. Let's take another example. And this time, let's take example of a payment gateway. See, whenever you build an e-commerce application, this can be for courses, this can be for a product buy, let's say Amazon, Flipkart, or maybe courses like Telusko. So what you can do is you can basically have a payment gateway. So if I want to sell my courses, I need to integrate the payment gateway. But then which payment gateway I should use? So let's say if I'm building an e-commerce application, of course I can choose one payment gateway. And for that particular payment gateway, I can write a code. So there's my application, there's my payment gateway connected. So they are tightly coupled. Now in future, if that payment gateway is not agreeing to my terms, or maybe they have changed something which I'm not happy with, what should I do? Of course I have to change my payment gateway, but then should I write a separate code base for that since I'm changing my payment gateway? Of course I can, but then does it make sense to change the code base just if you're changing a payment gateway? So if you're tightly coupled with your payment gateway, then that's an issue. What if you can say, let's do plug and play? So now I'm using, let's say, Razorpay. In future, if Razorpay has some issues, I can use Stripe, I can use PayPal. That switching should be easy. How will I do that? So let's say I have a class called purchase. This is where, or you can say a page where you can do checkout. So we got this purchase class. In this, I have a particular function called checkout. And of course, in checkout, there should be multiple information about the products, or maybe I can pass a cart. In this cart, I can have different products and different pricings. But let's keep it empty. And the only thing I'm going to pass here is self. Now in this checkout, I'm going to print checking out. We are not here to learn about payment gateways. We are here to learn about abstraction. So let's keep it simple. So checking out, and of course there should be a payment gateway. So what I want is I want an object of a payment gateway. So I will say gateway dot pay. Okay, this is what I want to achieve. So when someone says checkout, there should be a payment gateway and I should be able to pay for it. But if you observe, we don't have the object of gateway. So what you can do is you can use init to initialize the object. And unfortunately, this is not an inbuilt object, the payment or the gateway here. So what I can do is I can accept gateway and self.gateway is equal to gateway. Okay, so the thing is I need to pass the gateway object. Then only I can do pay. Now, one thing you can do is you can be very strict here. You can do a tight coupling. So let's say I have a class called RazorPay, and let's say that's my payment gateway which I'm using. And RazorPay says I have this method called pay, and in this I can print paying using RazorPay. And of course, this video is not sponsored by RazorPay, and they should sponsor me. So let's say I got this class, I got this method or function pay, and then I'm saying paying using RazorPay. And of course, to actually make it work, you need to create object of payment gateway. So I will say gateway 1, and this will be from RazorPay. Then I will create object of purchase. So let's say purchase, and this will be object of purchase. And now with the help of purchase, I should be able to check out, and then checkout says pass me the object of payment gateway. And I'm doing that now. So simple, right? Nothing fancy. Normal classes, normal implementation is just that the gateway or the purchase is dependent on the gateway. And if you're making it very strict, you're basically saying this is tightly coupled. So let me run this, and it says, okay, there is an error. It says one positional argument missing is because I should have been passing gateway here and checkout. Okay, why I'm passing gateway in checkout? My bad. So let's run this and checking out paying using payment gateway. Everything works. Okay, so I built an e-commerce website and I'm able to pay for it. Okay, the problem is in future, if they decided, hey, I want to go with some other name. So, or I want to go with different implementation, I'm stuck. So what you can do is you can define certain properties, right? So every payment gateway should have this particular function called pay. Otherwise, this will not work. Example, let's say if they decided to go and rename it to pay, and I will get an error now because then I have to change my code base based on their code base. So example, let's say we got one more payment gateway here, which is let's say Telusko pay. We should build our own payment gateways. And they are good. They are using pay as a name. They are good because that's my company. And I'm going to say, now of course, RazorPay will not going to sponsor me for this. Okay, so I'm using pay here. Now, when you pass the object of RazorPay, now RazorPay don't have this pay, they got pe. So it should give an issue. But the moment I'm passing an object of Telusko, so let's say I'm saying gateway 2, and this will be Telusko pay. I'm going to different gateway now, and I'm going to pass 2 here. Let's run this, and you can say paying using Telusko pay. So it works with this. Now there are two things. One, I want to maintain the standards. When I say payment gateway, it should have this function called pay, not pe. Second, why a purchase or the e-commerce website should stick to the object of RazorPay or the Telusko pay. There should be some standard, some default interface, and I should be using that interface. So the way you can do that is, because see, when you specify the type here, and if you are very specific, hey, I'm going to accept a RazorPay object and I'm passing Telusko, let's see, it still works is because that's how your duck typing works or polymorphism works. But I don't want to be very specific here that I'm going to pass a RazorPay. So what you can do is you can use a standard class, and that class would be payment gateway. And this payment gateway should have a function called pay. And the beautiful thing is I'm not going to pass anything here. I'm not going to have any statements there, just pass. And this class, I'll make it as ABC, abstract class. Why? It's because I don't want anyone to create object of a payment gateway because it's just a concept. The actual implementation is Telusko pay and RazorPay. And this particular function will be an abstract method. Now, you can make it compulsory for all the classes to inherit the payment gateway. Where you can check that. So let's say when you accept this object, you can actually check which type of instance this gateway is. If that instance is of type payment gateway, then only accept it. Otherwise, don't accept. So how will you know that's a type of payment gateway? Just by inheriting it. So it becomes compulsory now for them to have this method which is pay. So now let's say if I'm passing gateway 2, so you can see we got an error. It says abstract class RazorPay, we can't instantiate it is because there's an abstract method called pay. So now we know there's a problem. So we can, for the standards, and we can say pay. There can be another function here, which is pe, your choice, but pay need to be there. And that's how you can maintain a standard. So every payment gateway should have this particular function. So you can have an interface by saying, if I have a steering, there should be some implementation. If I have a gear here, there should be some implementation. So that's abstraction. And how do you implement abstraction is with the help of abstract method and the abstract class. It's time to talk about exceptions in Python.
Now we have talked about the good things, right? Now we know the basics. We have talked about oops concept. Now when we talk about exceptions, they are something which you have to handle. Now what if you don't handle them? First of all, what is exception? How it works, how to handle them. So we'll divide into multiple segments for this particular topic. But let's talk about why you have to handle certain things. See, when you build applications or as a user of the application, whenever you use any app, it can be on your phone or it can be on your desktop, you expect them to work, right? And you expect them to give you the response which you are expecting, right? So a lot of expectations there. But the point is, the app should work. The app should work smoothly and then it should not crash. But then if you talk about the kind of application which you are using, so there are some applications which are not very critical. There are some applications which are very critical. Now, applications which are not critical, example, let's say calculator. Now, of course, if you want to calculate something, you can do in your mind, but we are lazy. So you open your calculator and you start typing something. And then what if something goes wrong and your app crashes? That's fine. I mean, of course, you will be angry, but then you can simply reopen it, enter the same number, and you're done. But what if the app which you're using is critical? Now, see, when you talk about app, you picturize something, right? You have an image of an app in your mind that it should be visible, and then you are clicking something. But if you talk about the hardware which we use, they are using a software, right? Example, the plane, the car, the MRI machine, all these are actually running on softwares, which you can't see. Because that's how the things work, right? You see the hardware and then the software are running behind the scene. Even if you buy a new car now, all the modern cars, they have a lot of softwares in it. So they have a lot of semiconductors and softwares. And what if you are on the highway and something goes wrong with the software and it crashes? Okay, it shouldn't happen, but then you can see the impact, right? So these are mission critical softwares for the flight, for the MRI machine and banking applications. So you have to make sure if something goes wrong, of course, things will go wrong, but it should not crash the software. It should not stop it working. So those things which comes are called exceptions and you have to handle them. Okay, so we'll divide it into multiple sections for this particular video. First, we'll talk about what are exceptions. And in fact, we'll start with different types of errors. We'll move towards exception and then we'll see how do you handle it. Now, let's talk about errors here. Now, if we talk about a code can have different type of errors, okay? In fact, to show you that, I will open any code, okay? Randomly, I will jump to, let's say, this code, okay, which is fact recursion. So we have done this before. Now, if you have reached till exception, I guess you know what is factorial is and recursion is. So let's say if you talk about this code, and in this code, there can be different types of errors. The first error could be a compile time error. I don't know why I was saying logical error, but yeah, compile time error. Now, what is a compile time error? Now, whenever you make mistakes with the syntax, okay, so when you play around with, you're not doing something correct as per your compiler or the interpreter, it will complain. Example, let's say, if you talk about this code, what if you make a mistake here? So instead of saying single F, you typed double F. As soon as you do that, your IDE, in fact, if you're not using IDE, if you're using a normal editor, your Python interpreter will give you error. But your IDE says, what you're doing? This is an error. There's nothing called def here. Okay, so as a developer, you know, okay, you have written something wrong and your compiler is shouting at you or your IDE is shouting at you. That's a compile time error. And one of the most easiest error to solve is the compile time error, is because as a developer, when you're typing it, you can see the errors. So sometimes if you write something in the if condition, you might not see the error by the IDE. Example, if I write break here, okay, it gives an error. Yeah, if you write pass here, there's no problem. If I say PAS, you are getting a warning, but you can see there's no error on the screen. And it's actually an error. There's nothing called pass, right? So, I mean, PAS, not PASS. PASS does exist. So you got the point, right? So at least your IDE, your interpreter will help you. So when you run that, it will say, hey, what is pass? I don't know. The second kind of error which you normally get is a logical error. Now, what is logical error is when you have some logical mistakes which you have done. Example, let's say in this code, if you try to run this, first of all, I have to go to the folder, cd basics, clear. And now if I try to run this, which is fact_recursion.py, you can see we got 120, and that's what the factorial of 5 is. But if you make a mistake here, let's say if you instead of returning 1, you returned 2. Now in this case, you will get a different output, and that's 240, which is incorrect. And this is a mistake, right? This is a logical error. There's nothing wrong with the syntax. Everything works. Now, since you made a logical mistake, you will get a different output. Now, this is actually tricky, okay? So this is difficult to find this type of errors is because if you know for 5, it should be 120, and if you get 240, then you know that's a problem. But what if you have written something and you're getting an output and you're not sure if that's a correct output? Example, let's say if you're fetching something from the database, let's say you want a name of an employee with the ID 5, and if you get a name, let's say Naveen, and you expected was Harsh, and you don't even know you're expecting Harsh, you got Naveen, you're happy. I mean, that's what you get in college and dummy projects. You get some output, you feel happy. But that's a mistake, right? You got a different answer, or you got a wrong answer. Now, to solve that, basically we have a team, right? So the developer, you test it first, then you have a testing team who will test it. And then if something goes right, or if everything goes right, then only you will make it into production. And in production as well, sometimes it breaks and sometimes it's not giving the correct output. You do A/B testing, you do testing with your client, and then they give you some feedback. So that's the entire process. That's the logical error. The third kind of error is the runtime errors, or you can say exceptions. Now, exceptions are actually tricky because this is not the problem by the developers, right? So they have done everything correct. It's a mistake from the user, okay, most of the time. Because let's say if you are dividing a number by 0, as a developer, you will not do that. But if you are doing an operation where you're dividing by 0 and this input is coming from the user can say divide by 0, and then it will give you an exception. Second, let's say your app is looking for a file, okay? So if it has to work, you need to have a file where it stores data, and that's in your C drive. When you are developing the application, the file was there, and you have never got an error where it says file not found. But now let's say you have given this application to your user, and user knows there should be a file in the C drive. Maybe it automatically creates that file, and everything is working for a few days. One day, user got an error by saying, your C drive is full. And then user start deleting some folders or some files. And one of the file is the file which your app needs. And then user deleted that file. And now you're trying to open the app and the app crashes. Not because of developer's error. It's the user problem. They have deleted that file. And when you get an error like that, your app will crash. And you don't want it to happen. And that's why you should handle it. Now, how will you do that? So basically the concept is exceptions. So let's try to handle the exceptions. And to do that, what I'm going to do is I'm going to create a new folder, and let's say advanced, because now we are in the next step of Python. So let's say advanced, and in this, let me create a file called exception demo.py. And in this, let's write code. Now, first of all, I'm not going to disable my Copilot for this particular videos, because now you know the syntax. Even if AI is helping me to write the code, why not? Okay, so let's write some code. What I'm expecting here is, let's say I got two values. One is A, and the value of A is 5. Then B, the value of B is 2. And I'm going to do a very simple operation where I'm going to store this operation of divide into a result, and then I'm going to print it. Nothing fancy, simple stuff, right? If I run this, so of course I have to come out of basics. Let's get into advanced mode and clear. Let's run the Python. So Python exception -demo.py, enter, and you can see we got the result as 2.5. Everything works, no problem. Happy life, happy code. Okay, so let's print one more thing here, which is, let's say end of program. I was supposed to type by, but then Copilot suggests write end of program. Now, why I'm writing this is because when you execute this, of course, your application has so much things to do. And let's say that code is here, not just end of program. Let's say we have a lot of code. If this executes, I'm expecting other thing will also execute. Okay, so if something breaks here, this will not execute. So if I run this code once again, it works and it says end of program. Or it will say end of execution. Okay, now let's say I make it as 0. So if you make the B value 0, let's see what happens. Enter, you got an error. And this is not the first time we are getting error, but something to observe. First of all, it is giving you the reason on line number 5, because of this operation, you're getting the error. You also have this operation here. It says this is a problem. This slash is a problem here. Actually, the slash is not the problem. The problem is B. The value of B is 0. And you can see you are getting a message as well, which is division by 0. And observe this 0 division error. We'll talk about this later. But let's look at the message, which is division by 0. And one thing to observe, this message, which is end of execution, is nowhere. That's trouble, right? Because I want it to be there, because the app is crashing and I don't want my app to crash. So how do you handle this? Now, when you say you want to handle something, you can basically look into the statements and decide which of them are critical statements and which of them are normal statements. Now, what do you mean by normal statements and critical statements? So let's say if I'm going with my family and I have a kid as well. So let's say we are going to a mall, and in there we went to a restaurant and we are having our lunch. And at this point, let's say my kid got up from the table and just trying to run away somewhere, so to a different table which is empty. Will I be panic? Depending upon situation, it's a restaurant, it's a closed restaurant, and the next table is empty, so no one is there to get bothered. It's okay if my kid gets up from my table and goes to the other table, right? Where else he will go? We have a short space there, or small space. And that's a normal situation for me. But now think about a situation where I'm going on a different city, and then on the highway, we got a small restaurant, or maybe called dhaba. I'm waiting there, and we are having lunch. And now the open restaurant, which we can call it, is next to the highway. And now my kids get up from the table. Now that's a panic situation, right? Because we have a highway there, or the road, or the vehicles are coming there. And that's a critical situation. So I will just get panic, I will jump and hold his hand, right? So that's a critical situation. So depending upon situation, you will try to handle it. In this particular code, these two statements looks normal to me. What will go wrong there? But this line is critical. So what I will do is I will try to handle it. And the way you can do that is by writing in a try block. Okay, so this is a try block, and this is the code which you want to write in a try block. Now, what try block will do is try block will say, okay, anything inside my block will be handled critically. So it will try to execute this. It will say, let me try to execute this statement. If it works, that's great. If it doesn't work, I will handle it. But then to handle it, you have to write, and you can see if you go here, it says try statement must have at least one except block. So you need to have the except block here. And except block says you have to mention what kind of error you want to handle. Now this is important. So let's go back to that restaurant near to the highway, which is an open restaurant. Now, a lot of things can go wrong there, right? One of the thing is my kid gets up from the table. That's critical thing for me. I have to handle it. But there are certain other situations as well. Let's say there is a dish which is getting overcooked. Now that's not my concern. I'm sitting on my table. That's a concern for the chef. Chef need to handle it, right? Or maybe there's something, other things that are happening there. Not my concern, right? So I should handle my exceptions. So in this situation, I should be very clear what kind of error I want to handle. So in this case, it is zero division error, which we got earlier. So we should handle that. But to understand what other errors we have, so let's go to the Python documentation and let's get into the exception hierarchy. Now, if you see here, the base exception is the top class exception. Okay, when I say top class, it's a pun intended. In the class hierarchy, it's a topmost class, but also the top best. Doesn't matter. I tried something, it's not working. But the main point is this exception. This is the main exception for us. So this can handle everything. Now, when I say everything, what it means, it can handle arithmetic error. If something goes wrong with your calculation, or overflow error, or there's a problem with the floating point, and there's also a problem with the zero division. So this zero division is a subclass of arithmetic error. Arithmetic error is a subclass of exception. Okay. Now, if you go down, there are more errors. Let's say we got buffer error, we got end of file error. Then what other things we can use? Yeah, file not found error. This is what I was talking about. The file does not exist. And recursion error could be one, value error, which you're going to see later. So there are different kind of errors which comes under exception. So if you get any of this exception, and if you have exception which can handle it, it can handle it. So what I'm going to do is, in our code, let's write, instead of saying zero division, I will write exception. Okay, the main exception. And if you click on exception, you can see it's a class which is extending, or which is inheriting the base exception. And base exception is like a topmost class. It is not inheriting everything or anything. So you can get into exception. We also got stop iteration, which we might see later. And yeah, so we can see we got arithmetic error, which extends or inherit exception. Inside this, there should be zero divide error. Yeah, zero division error, which inherits arithmetic error. So now you know the flow, right? How it is doing. But now if you say exception, it can handle everything, So let's write exception and let's print here something. So let's print here by saying, okay, I think I made a mistake. An error occurred, division by zero is not allowed. Okay, this is what I'm going to write. I think I clicked something because of which I'm getting this thing. I don't want it. Let's stick to our own, the original terminal. Okay, so you got these statements and you're putting that in a try block. That's how thing works, right? So let me just save this and run. And you can see it says an error occurred, division by 0 is not allowed, that's proper. But if you observe, it is not crashing the application. You are saying end of the execution. This is important. It is saying end of the execution. So that's how basically you handle the try. I mean, you handle the statements by putting that in a try block. And then you try to handle the exception by using except or exception. And then you print something. I mean, it's not just printing. You can do some operations as well. Maybe you can do this operation again by changing the value of b. You can ask the user, hey, give a new value for the b, and then you can do that here and make it work. So you can do whatever you want in the except block. So that's how you use try and except. Now let's say you are taking the input from the user. So the way you can do that is by saying int. You have to also convert that. So let's say input. I will say enter a numerator, and here enter the denominator. That's perfect. And now let's see if this works. So let me just run this. Enter, asking for the numerator, 4, 2, everything works well. You can see it says result is 2.0 and then end of execution. Perfect. Now let's run this. I will say 4 divided by 0. Okay, it says error occurred. That's good. Division by 0, my mistake. And end of execution. App is not crashing. That's great. Let me run this again. 4, and I wanted to type 5, but then I entered T. When you say enter here, you can see we got an error and the app is crashing. How do I know? It is not printing end of execution. Now what went wrong? This line, which is b equal to this line, is the problem, and the error is value error. Remember, we talked about value error. I mean, I've shown you in that hierarchy. It says invalid literal for input because input function tried to convert into integer. It is trying to convert integer. T is not integer, so you cannot convert it. So these statements also become a critical statement. These are not normal statements. So I can just pick it up, put that in a try block. At least it should not crash it now. So let's run this. Okay. And run. Let's say 4 and 2. Everything works proper. Let's say 4 and 0. Everything works proper. And now let's say 4 and T. Okay, you can see for T, it's not crashing. It says end of execution, but there's some problem with the error message. It says error occurred, division by 0 is not allowed. It's not 0, it is T. What is going wrong? See, if something goes wrong with the try block, of course you will execute the except block. We only have one except block. It is going here. It is printing this message. Not a good message, right? Because the problem is different. What you can also do is you can print the message here. So you can just say exception E. So whatever exception object which is getting raised, you can put that in E and you can print E here. Okay, now you will get the error message. So 4 and T. You're getting this message because that's what you have written here, hard coded. But look at the E message. It says invalid literal for integer T. Perfect. So that's actually good. But then for 4 and 0, we are also getting the same message. Not a good style, but yeah, this message is different. This is same. So if you want to type a different message, don't you think there should be different except block for different kind of errors? Example, let's say if you're preparing for a board exam, and I remember my school time, when you're preparing for the board exam, before the exam, my school used to arrange this 10 days doubt solving sessions with your teachers. If you get errors, let's say for maths, we have a classroom where we have a maths teacher. You can go there, resolve your doubts. We have a teacher for science. You can go there and resolve your doubts. But there are certain doubts which no one can answer. Okay, maybe someone is bullying you, you lost your hall pass. In that case, you will go to your class teacher. So you can be very specific here. So exception, you can say this is 0 division error, and I can just write ZDE just to differentiate the objects. And the message is this. And then you can write one more except block, which is for the value error. And you can write a message like this. And then this works. And then you can have a universal exception where you can say unexpected error occurred. Now for the first two, for this particular except block, we got this is 0 division, this is value error. Now based on which error is arising first, it will execute that particular except block. Okay, so if I run this and if I say 4 and T, now this time it is not divided by 0 error, it is the value error. And that's why you can see it says an error occurred, invalid input, please enter numeric values only. And that's a proper message, right? And that's why, and since you're printing VE, again, it is printing the same message. You can skip VE now, right? That make much more sense, but let's keep it there for our understanding. If it is a 0 divided by error, it will print that message. So let's say 4 and 0, it will print division by 0 is not allowed, right? So that's for the 0 error. So it will not execute both. The moment it gets at least any one error, it will jump to the matching except block. Okay. Now I don't see any extra error here, but we just wrote this for our safety, right? If something goes wrong, which is not, I'm not handling it here, except will handle it. If you can generate any error which is not in this, let me know, and somewhere in the comments or in the notes somewhere for the others to see. Okay, so this is about try with multiple except block. Now we can talk about try with finally. See, what happens is when you work with the complex software, you work with databases, you work with network connections, you open files. Now, all these things are actually called resources, right? So database connections are resources, files are resources, and it is your responsibility as a developer. After using the resource, you have to close it, right? So let's say in this code, I'm not using any resources, but let's pretend we are using some resource. So I can say resource opened successfully. This can be database connection. This can be a file opening. This can be network connection. Resource opened successfully. And then I have to make sure I will close it. Now, which is the best place to close any exception or anything? The best place to close a connection is a final block. Now, final block is a block which will get executed even if you get the exception or even if you don't get the exception. Because see, the except block will execute only when you get the exception, right? Try block complete executions depend upon if you get the exception or not. If there is no exception, it will execute the entire block. If there's exception, it will stop the execution into try block and jump to accept. But final block executes irrespective if you get the exception or not. So it's always better to write final block in which you close the resources. So if you run this, let's run 3 and 4. You can see it says resource closed. And even if you get the exception 4 and 0, it will say resource closed. And even if you crash for some reason, so let's say I'm not handling value here, and let's see what happens. I'm just experimenting it here on the go. It says resource opened and it crashed. It crashed. Okay. So it's not printing end of execution, but it says resource closed. Doesn't matter if it is crashing or not. So before crashing, it will close the resource. And that's important. So that's why you should put things in the final block. Perfect. But there's one more important thing with the final block is, let's say if you don't put final block and try block, if you skip that, try block will say, try statement must have at least one except or a finally clause. Okay, so either you need except or you need finally. So you can also have a finally here. Maybe you can print something, clean up resources. So if you want to write try, either you need finally or you need except block, or you can have both. Just remember that. So yeah, that's it. That's it from the exceptions. I hope it makes sense. We'll talk about multi-threading. So basically we'll work with threads. Now in this particular section or video, depending upon how you're watching this, we are going to talk about what is thread. We are going to talk about why do we need threads and how exactly it works. And then we'll also move towards multiprocessing. So we'll try to understand how multiprocessing can be useful over threads in some use cases. So let's start with an example, okay? And then we'll start with the code, and then in between I will give you some analogy to understand why we need threads. So let's create a file here. So let's go back to our advanced project, and let me create a simple file. So I will say this is threads demo.py, and in this let's create a simple example. So whenever I want to teach threads, I normally take this example of hi and hello. Okay, very lame example, but it shows you the importance of threads. Okay, so bear with me, logic is not important, what you're getting in the output is not important, but the use of threads are important here. So what I'm going to do is I'm going to create a class. Now see, when you talk about threads, again, we have not talked about what is thread, but when you talk about threads, we can create threads in two ways. One is using classes and the other way is using functions, which is a Pythonic way. So I will show you both, don't worry. So I'm going to create a class called hello. Very simple example, a very simple class. In this, I'm going to create a function called do, which will do something. And since we are writing this inside of class, let's pass self there. And in this, it's going to print something. Now we can print amazing stuff, but let me just print hello. And I'm going to do that. I'm going to print that 5 times. So let's say for I in range, and since we want to print it 5 times, I will say range of 5. And every time I'm going to print hello. And then after printing hello, I'm also going to print the time it is printing. I'm not the time, but the occurrence. So I will say I. So it will print hello 1, hello 2, hello 3. In fact, for that, I should say I plus 1. So it will print hello 1, hello 2, hello 3. That's what we want. And then I want to do the same thing to one more class here. So let's say in our case, it will be hi. So we got 2 classes, hello and hi. And here we can print hi. And then I can just simply execute them. So let me do that in if name is equal to main. In this case, I want to create object of both the classes. So I will say obj1 equal to hello and obj2 equal to hi. But time in I will just name it as T1 and T2 because we are going to need these names later. See, name doesn't matter, right? So we got 2 objects. And with those 2 objects, I can call those functions. So I can say T1.do, which will call the do function of hello, and T2.do, which will call the do function of hi. And both of these are going to print the same thing. Not exactly the same thing, but same pattern, right? Hello 1, then hi will print hi 1, and list goes on. So let's see if this works. Nothing complex, right? Simple example, very weird examples. Simple and weird, but then it will make sense, don't worry. And here, let me first of all move to the advanced folder. And now let's run this. So I will say Python threads demo.py. And let's say enter. So before I say enter, in your mind, just write on this and let me know what is the output. Maybe you can use a comment section or wherever place to answer this. Think about this and answer. Now, when I try to run this in my mind, what I see is I'm calling do function of hello, and then I'm calling the do function of hi. It will first, so we have the flow. So the flow will start from here. Of course, this will create these 2 things, but it will also go here and it will check what we are doing here. We are creating the object of hello. We are creating the object of hi. It will do that in sequence. And then it will go to this particular call. It will say, okay, it's my job now to execute the do function of hello. It will go there. It will complete the entire task. Now, when I say entire task, nothing complex. It will execute this for 5 times. And 5 times it is going to print hello with different numbers, of course. And once it is done, the pointer or the flow will go back to here and then says, this is done. Let's go to this particular function, execute this, and this will execute hi 5 times. So that means the output I'm expecting is 5 times hello, 5 times hi. And let's see if it is matching with our dry run. Let's run this. And yeah, that's what we got. We got hello 5 times. We got hi 5 times. We got what we wanted. But now I want something else. I'm greedy. Okay, so what I want now is I want to print hello and hi simultaneously. Now that's weird. Why someone will need that? We'll talk about that in some time. Why? But let's say I want it. I want to print hello, then hi, then hello, then hi. May not be in the perfect sequence, but I want these 2 functions to run parallelly. At this point, we can't do that because that's how your code runs, right? Step by step. It will execute this, complete the task, then only it will go for the next step. Now I want both these functions to run parallelly. How will you do that? Now, for that scenario, we have to use threads. But before we go there, let's talk about why. Why do we need it? Why do you want to execute 2 functions simultaneously? See, when you play a game, or in fact, not just game, whatever application you use nowadays, they all have this feature where you can execute multiple things at the same time. Example, let's say if you are using your phone, and normally we have this tendency when you get a call from someone, and if you know you are going to talk to them for a long time, and it's not an important discussion. I mean, of course, it's important, but then not critical. So while talking to them, let's say for half an hour, you minimize the call and then you open some other application, maybe your WhatsApp application, or maybe if you are watching some cricket match or cricket score. So at the same time, you're talking to someone. At the same time, you are opening a cricket application to watch the score or to update yourself. And then at the same time, maybe you're opening WhatsApp to chat to someone. So you're doing multiple things at the same time. As a human, we can do that, not perfectly. But what about your OS? What about your phone? Can it execute multiple things at the same time? It can, right? So if you say call is one function, WhatsApp is another function. Your updating your cricket score is one function. You are executing all these functions simultaneously. We can also look at the example of game. When you play a game, so I was a big fan of NFS or maybe Mario. So I don't know how many of you know Mario games. So let's say if you play a Mario game, so what happens is there is a player, or which is you. Basically, you are trying to cross certain hurdles and you are jumping, you're getting stars, you're getting all those features. Okay, I will ask my editor to put some Mario screenshot on the screen to make you understand that. So in this game, basically there are multiple things happening at the same time. You are moving, you're jumping. At the same time, the enemies are coming towards you. They're trying to hit you. At the same time, there's a music playing. At the same time, there's a score updating. So a lot of things are happening, right? Now, if you say you are moving is one function, the enemies are moving is one function. I mean, of course, there will be multiple functions for the enemies because there are different enemies there. Then there's score update for one function. There's music, one function. All these functions are executing at the same time. I mean, simultaneously. So if you don't have this feature of executing them simultaneously, then what will happen is you are moving, then you are stopping, then enemies are moving, then they are stopping, then music is playing, then that is stopping, then score is updating, then that is stopping. So we don't want that, right? We want everything to run simultaneously. And that's what I want here. I want this hello and hi to execute simultaneously so that we can mimic that feature. How do we do it? And that's where we can use threads. Now we can do that with the help of threads. Okay, so executing multiple things. Now what are threads? Now in your system, there's something called process, right? So whatever you execute is happening with the help of process. So if I show you, if I open my task manager, it opened here. So that's my task manager. And so you can see multiple things are executing at the same time. So we got a PowerShell, we got console, NVIDIA app because I'm recording the video. So it is using that. Claude is open. I don't know why. Edge is open. I don't know why. So a lot of applications are running at the same time, right? But if you go here to this particular section of performance, you will see there's something called process. So when you execute this multiple applications, they are using process behind the scene. But then process itself is a heavy thing. To create a new process, it takes time. It has its own memory. So of course, to execute things simultaneously, we can use process. But as I mentioned, it is heavy. It has its own memory. So you're wasting a lot of memory there. What if you want to create a smaller version of it? You want to create a lightweight version of process. And that's where you get threads. So in one process, we can have multiple threads. And as you can see, what application I'm running, of course, I'm not running 5,000 applications here. But if you see threads, there are more than 5,000 threads running now to do this. Maybe recording because it's a heavy software recording it. The only thing is I'm not recording my face with the system. So it is not that heavy, but even recording the screen is heavy. But at the same time, if I open some other application, let's say IntelliJ, it might spike this. So if you can see it is opening, it went up. So the more applications you have, the more threads it's going to use. And you can see the consumption just went up. Let me close this. I don't want IntelliJ at this point. So it will drop. The number of threads required now will go down. Exit. So you got the point, right? So threads are the lightweight process. You can say that. The question is, how do we create one? So if I go back here, how do we create threads? There are two ways. You can directly create a thread here. So you can say thread, and then in this thread class. So the thread is basically a class and you have to import that. So I can say from threading module, I can import thread. And if you look at thread, it's a class. Okay, so if you have a class, you can create the object. So you can see we are creating the object here. And you just have to specify what is your target. So you can say equal to hello.do. So this is how you mention your target. So you mention the class name. Because see, if you just create a thread, how it will know when you execute this thread, which particular class method is going to execute or the function is going to execute. So you do like this. But I don't want to do in this format. I will simply say hello here because we are going to see that format later. So let's see the normal inheritance way. So if you want to make this hello as a thread, if you want to run them simultaneously, you have to make them threads. So what you can do is you can say, you can inherit thread for both hi and hello will inherit thread. Now, the benefit which you get is, first of all, these are not normal classes now. These are threads because you are inheriting threads. It's something like if you inherit Bill Gates, you become Gates. Right? You will be rich in one day. Okay, doesn't matter. So, hello got all the features of threads because it is inheriting threads. Now, this T1 is T2, not normal objects, they are threads. And with threads, you get superpower. And to get that superpower, let's change our function name from do to run. So you have whatever function name you have, replace that with run, because thread runs. So you have to make sure that you keep it run. And then here you will call run. So simple, right? Let's see if this works. Let's go back. Hopefully it's going to execute them simultaneously now. So let's try this, enter. Oh, it's not happening simultaneously. It's still going in sequence. Why? Why it's going in sequence? It's because we have two threads, no doubt in this. It's just that they are not active. What I'm expecting is there's one particular process which is executing this, and now I want two threads out of it. So there should be a bifurcation of two threads, and these two threads are going to execute hello and hi running simultaneously. That's not happening. It's because we are not starting the threads. But you will say, hey, we are running the threads, right? It should work. Now, thread says, if you want me to work the way you want, start me, don't run me. So you have to say t1.start and t2.start. Then there's a problem here. The problem is the function name is run and you're calling start. How that works? Let's see if this is working with this code. So I'll just save this, clear the screen, run. It's working. Can you see that? Something is happening parallelly. Okay, so not exactly the sequence I want, but hello got printed 3 times, then hi came in between, and then hello, then hi, then hello. Something is happening, okay? So not exactly the sequence of hi, hello, but two functions are running simultaneously. That's what we wanted, right? But let me answer this question. When you're calling start, how it's calling run? See, behind the scene, when you say t1.start, behind the scene, it will go to your system and say, okay, now user wants me to start. And then it will start behind the scene and it will call run. That's not our lookout. That's a lookout of your system. Okay. So internally, start will call run. So you do need run there. If you have some other function, it will not work. So let's say if I have do there, and if I try to run with do, nothing is happening. Okay. So T1 or this particular function is not getting called. But there's no error. Where's run? Run is there implemented by default in thread. So if you search somewhere, there should be run. Okay. So when you call start, start will call run. And this is a run function. So even if you don't mention, it is there. But I want my run function. So you should say run. Okay. So this is working. But then you will say it's not what I wanted, right? So I want in proper sequence. First of all, let's try to understand how it is happening. Why? Oh, okay. By the way, when you saw the output initially, it was hello 1, hello 2, hello 3, then hi 1. So the sequence is not confirmed. So what is happening is, in our brain, we are expecting when it goes to your system to execute, to your CPU, it says, hey, execute this. We are thinking that T1 and T2 will take, turns and say, hey, T1 will execute, then T2 will execute, then T1 will execute. But then, depending upon your system speed, now this will change in your system as well. Depending upon your system speed, depending upon how many other processes are waiting to execute on your CPU. When T1 goes to your CPU, it will say, hey, I want to execute. CPU says, let me check. I have other process to execute. And once it gets free, it will say, now T1, it's your turn to execute. Now, in that turn, whatever time specified to T1, in that specified time, it might execute this loop once, twice, thrice, or maybe 5 times. You don't have a control. In this case, it's executing only 2 times. And then CPU says, your job is done. Let me give chance to some other process, maybe some music app which is running behind the scene. And yes, Spotify is running behind the scene. Let me close this. And some other application running behind the scene. And then it gives chance to hi to print. And then hi is doing its job. And then it is printing only once. And then again, the chance is given to hello. It is executing 2 times. And we don't have a control on that. The only thing you can do is, since hello is executing a bit fast, I can just slow it down. And the way you can do that is by importing from time import sleep. This is what you can do. And every time this execute, I can ask it to sleep for some time, maybe 0.3 seconds. And I'm just trying to do that. Okay. It's not like CPU will listen to me. I mean, of course, CPU will sleep for 0.3 seconds, but it will not guarantee the sequence which we want. So we got hi 1, hello 1. Hello 2, hello 1, hello, hi 1, hello 2, hi 2, yeah, it messed up here. So you can see hi is getting printed 2 times. We can add a delay between the calls as well. So maybe one will start after the other with a delay so that they will not reach at the same time. And no, I can just delay it increase it by bit late. You can only try. You can see it is working this time, but I'm not sure if I run this once again. Yeah, it messed up. So you don't have the exact control on the scheduler. Yeah, that's what handles the execution of the threads or the process. But we can try. And with sleep, I try to do that. But intentionally, we are slowing down our system, right? Not a good idea, but just to show you how things works out. So this is how you do it with the help of class. But what if you want to do this with methods or functions? Let's try that. For functions, what you can do is you can use these functions without classes. Let me remove classes and let's put that here. One more thing will change. We can change the function name. Instead of run, we'll say hello and hi. Now, since it is not inside the class, I can remove that self. And then here, instead of creating the object, I have to create threads now. Okay. So things will remain same. Nothing changes apart from removing the class. And here, because we don't have a class, right? So I have to create the object of thread. And in this thread, I have to pass the target. So for this thread, which is the target function is hello. The same thing. Okay, why thread is not working? Oh, my bad. I'm saying target there. Happens with most of us. So I will say target, and this time the target is high. So we got the target hello. We got the target high. So when T1 executes, it will target hello. When T2 executes, it will target high. That's what I want. Let's see if this works in the same way. Yeah, same way. You can see we have two options. Either you can use class approach or you can use functions approach. The more Pythonic approach is functions, so you should use this. But I wanted to show you the class approach as well, in case if you see some code which has a class, you should know what is happening. Now let me show you one more thing. So let's say at the end here, I want to say bye. Okay, so simple stuff. At least when you execute the code, when it ends, greet the user by saying bye. Okay, so when I say enter, I'm expecting bye at the end, but see what happens. Bye is coming here. That's weird. Why it will come in between? It should be at the end, right? See, the thing is, when it starts, okay, we have a single process which is executing this, which is executing this. And then at this point, we are creating two threads, right? And then these two threads, one will execute hello, one will execute hi. But what about the thread which started this, the middle thread? It is still empty, right? It's not doing anything. Not empty, but it's idle. It's not doing anything. So that thread will say, okay, my job is done creating this two. I will continue and I will print bye. That's what is happening here. How will you pause it? We should ask that main thread or the middle thread to wait. Let them complete their work. T1, T2, let them complete their work. Once they come back, then execute bye. So how will you wait for the other threads to complete? In this case, you will say T1.join, T2.join. Basically what you're saying is you're saying wait for them to complete, let them join back. Once they join back, then execute bye. So that's the importance of join here. So if I run this, you can see bye will get executed at the end. So the middle thread will wait for the other two threads to complete or to complete and join back, come back and join. So that's how it works. That's how join works. Now to make this better, we can use another example. See, till this point, we know threads are useful, but I want to see, does it also increase the speed of execution? And for that, I'm going to use some other function now. So let me remove this too. And let's create a function called download, okay, which will download the files. And I will say file name here. So it will download some files. And we are not literally downloading the files. So you have to write a lot of code for that. And if you have free time, you can do that. At this point, I'm just going to say downloading files or downloading file ... And maybe we can also print the file name if you want. So we'll know which file it is downloading. And then since it will take some time, I will add a sleep of 1 second or maybe 0.5 seconds also works. At least this much time will take to download. And then at the end, I will say download complete. Okay. So it will say downloading file. It will pause for some time and it will say download complete. Now I want to have, in fact, I will just keep it like this. Let's change it and let's keep the bye at the end. That is a good sign. Now what I want to do is I want to have multiple files. So I can say files. So let's say that we have different files here. One is video.mp4. Then we got image.png. And let's say we have one more file, which is data.csv. So we got these files and now I want to download them. So let's do that one by one. And If you want to do it serially, it's very simple. You can use a for loop and you can say for in files, and you can call the download functions for each file. Okay, and then you can download it. But I also want to know how much time it is taking to download the files. And before that, let me just run this and see if these things are working. It says downloading file, video, and it will go in sequence, right? It will first complete the video, it will then go for image, then it will go for data CSV, and then it will say bye. But I want to know how much time it is taking to do that. So I will say start time. We have to also import time here, sleep and time. So if you want to know how much time it's taking, so current time, and at the end, you will say time, and then you can simply subtract them. So I can print in a particular format. I will say serial time. I can put that in curly braces. It should be end minus start. That's how you find the time, right? End time minus start time. But it should be 2f. I don't want to print all the decimals, only 2 decimals. And I will say seconds. Simple stuff, nothing fancy, right? Let's see how much time it takes. Run. It is printing everything, and it took 1.5 seconds. That's a good time. But now let's try to do that with threads. Okay, so I will just remove these extra spaces from here. So this is for serial. Let's do that with multithreading. Now for multithreading, we need multiple threads, right? And let's create the list of threads because we need 3 threads here. And that depends upon the number of files. So I will say for f in files. So depending upon the number of files, we'll create number of threads. So I will say t is equal to, let's create threads. And threads will have one target, which is the download function. But then download also need the argument, right? So download function needs an argument. So you have to pass the argument as well. So args equal to f, comma. So this is the syntax. You have to pass the comma as well. You have to mention the target, which is the function name, and then the arguments. Okay. And then we can simply add this thread to the threads. Append the thread. Now, once you got 3 threads, let's start those 3 threads. So for t in threads, t1 dot start. Simple, right? So depending upon number of threads, you have to start those threads. And then we'll also wait for the joining them because by should be printed at the end. So for t in threads, for each thread, wait them to complete their work and join. And before we start this download, or here at this point, I want to start the timer. So I will say start equal to time, end time, and then I can simply execute this part. Parallel with threads, and that's the time. So let's see how much time it takes now. Let's run this. So serial takes 1.5 seconds. You can see that. And the parallel takes 0.5 seconds. And things are happening parallelly. You can see downloading file this, downloading file image, downloading file data. And then all these things are getting downloaded parallelly, and then they are complete. That's what I want. Now, yes, people who will say, we have a limited bandwidth. It's better to download one file after the other, but let's have unlimited bandwidth. It works, right? So it saves time. So threads are useful, right? So it saves times. You can execute things parallelly. So what we are doing is we have 3 files. We are creating 3 threads for those 3 files. If you have more files, you can simply add them and it will do that. And in serial, that as the number of files increases, the time will increase. In fact, you can make it more interesting by specifying the file size. And that size will define the number of seconds it will take. So you can make it more dynamic. Okay, so you try that. That's your homework. Yeah, so that's helpful. Now let's see where threads can impact. So whatever we have done now is basically IO bound operations. And in an IO bound, threads make sense. But what if you are using CPU intensive work? And for that, let me take different example now. So instead of download, let me say, in fact, let me just clean this so that you will not get confused. And I also want to remove this part. I want to keep this because we'll need this part. I think I deleted end as well. We'll write it once again. So let's try with something. And yeah. So let me get a function and it will simply say calculate. So what we are calculating is whenever you get a range. So let's say n1 to n2. Now this can be any range. It can be from 1 to 100 or 1 to 1000 or 1 to 1 million. Now, whatever range you have, for that range, you have to find the square of each number and then sum it up. So we are basically doing the sum of the squares. And for that, we have a formula as well. Let's do that. So we'll say for I in range, and we can specify from where to where, from n1 to n2. Basically, we have to find this sum. So we also need to create this variable sum, which will be 0 in the case. And then we just have to say sum plus equal to n. This instead of I, this should be n. Name doesn't matter, but it's good to have a good names. Even n1 and 2 are not good names. But this is what we're doing. We are basically doing the square of it, and then we are summing it up. This is a logic for summing all the squares. Simple, right? And I want to do this. I want to call this. Now, what should be the range? What should be the first number? What should be the last number? So let's create that. So I will say num is equal to, and we can have a range of 50. So from 0 to 50. But I want to do something weird. Okay, so I got this very big number, which is 50 million, and the range is 0 to 50 million. Now, output doesn't matter. So I'm not going to return this sum, and we're not concerned about the output. I'm just concerned about this speed. Okay. And let's do that in sequence. So at this point, I have this number. I will try to execute that calculator function by passing 0 to num, and let's see how much time it takes. Clear, run. So it is taking time. You can see it took some time, and 1.59 seconds. That's a good time. Parallel says 0 because we are not doing anything here. At this point, we are just going in sequence. So that's the time. I want to see if I try to divide this into two parts, from 0 to 25 million, and then from 25 million to 50 million. So we can have two threads running parallelly, executing the first half and second half. I'm expecting it should speed up. Let's see. It should complete in half a time, right? So let's create two threads. So T1, this is the thread, and the target for this is the calculate function. Now, calculate functions takes two arguments. I can pass the arguments. One is from 0 to midpoint, and we have to find the midpoint. So I will say mid is equal to num divided by 2 because I want integers. So I will just say double slash. So from 0 to mid will be T1, and T2, the second thread, will start from mid to the end. So this is T2. This will start from mid till the end. Okay, so we got two threads, one first half, second half. Okay, now let's start them. So I will say T1 dot start. Now since we are not using a list of threads, so we can do that now like this. We don't need for loop. And then we have to wait for them as well. So T1 dot join, T2 dot join. And now let's see how that works. So how much time it takes. Let's clear, run. The serial takes 1.67 and parallel is 1.57. There has been increment, but I'm just not sure is it only this time or every time. In fact, I was expecting half of a time. It's not half time. There's a minor difference. And maybe there will be a time where it will take more time than serial. Okay, but now the question is why it is not that fast if you are executing two things at the same time. See, what happens is when you have a CPU intensive work and when you have multiple threads running this, we in our mind we're expecting that my CPU is multi-core CPU, right? So it should execute T1 on one core, T2 on another core. It should work parallelly and it should take half a time. But then that's not how Python works. In Python, there's something called GIL, which stands for Global Interpreter Lock. So what it does is, if you have multiple threads, it will lock one thread. So one thread will lock your interpreter, and then the second thread will wait for your execution time. So if T1 is working, T2 can't work because of GIL. And then once T1 is done, T2 will execute. And then if T2 is done, T1 will execute because of the GIL. And that switching takes time. In my version, it's not happening that often, but it is still not that fast, what we're expecting. So what's the solution? The solution is multiprocessing. So process and threads. Process are a bit heavy, as I mentioned before. So threads basically share the memory. Threads is lightweight. It is fast to create. Process, on the other hand, it takes time to create, but they have their own memory and they have their own GIL. So every time you create a new process, it will have its own GIL. So there's no locking problem. In terms of threads, they share the same GIL or GIL in short. So how do you make it fast with process? So from multiprocessing, you can import the process. And the way you have done threads, we can do the same thing with process. The only thing you have to change is instead of thread, you have to say process. And even here, you have to say process. I think I'm importing process. Oh, P small, capital P. Now there's no problem. Process. And let's see, parallel with process takes how much time. So let's clear this, run, and serial takes this much time. Parallel, if you can see, took more time than serial. But parallel process took 0.8 faster, right? So because of that GIL, threads were taking more time than serial. So if you have a CPU intensive work, I would stick to serial or I will stick to process. In process, you are wasting a lot of memory and time also to create those processes. So which is better? That depends upon situation. For IO bound, threads are better. If you want to execute something parallel, doesn't matter the speed, threads are better. But if you want to execute a different process with their own memory and GIL, you can use process. And it's very simple to use process. Just import from multiprocessing, import process, and your job is done. So yeah, that's it from threads. So thank you so much for watching. I hope it makes sense.